Hello, everyone. Good morning, Columbus. Come on, let's make a little more noise than that. All right, thanks a bunch. That's a lot better. Welcome to the 2023 OLF Conference. It's fantastic to have you all here. This is our 21st annual event, and we're so excited to have it here in the Hilton. This is a brand new hotel. We had the conference here last year as well, and it was a great space, and we're happy to be here again. We've got a great lineup. If you look at our schedule, you'll see we've got sessions all day today. We'll also have in the Ferris West C room, the Tibber room, I believe. See, I gotta know my own schedule. Yes, in the Tibber room, we're going to have be showing some videos of Sean Powers had put together about the LPI Linux Essentials material. And that might be interesting for some of you. It's not really a full-blown training, but there'll be a gentleman in there to be able to answer some questions and facilitate a little bit of discussion about that. But we all have great sessions all day in this room here, and you can see the listing on the schedule. So I hope you'll take advantage of whatever captures your interest the most. I want to thank all of you, the attendees. You're what makes this happen, especially those of you who purchase a supporter pass or one of the professional passes. That really does help contribute financially to making this happen. All right, let me introduce our first speakers. So unfortunately, Karen and Tracy Hughes were not able to travel out here. So we have a pre-recorded video that we're going to show first. But then after that, we'll have the Q&A. And they'll be joining us through Zoom and be able to handle the Q&A that way. We'll have someone here to run around with a microphone and so you can ask questions. Or if you wish to, you can also, on Slack, go to our main stage channel and you could ask questions there. That's especially for you folks online, that's the mechanism for you to ask questions. When you registered, you got a confirmation email which included a link to join the Slack. The folks that are physically here, you'll see we have posted up some QR codes with that same link. And so without further ado, we're going to hear a little bit about using Arduino and Raspberry Pi with Karen and Tracy Hughes. So please welcome them.
Started here. All right, first I want to do a couple of acknowledgments. Thanks to the OLF 2023 for presenting us this year. We're very appreciative for the opportunity to be here and make this presentation before you. Thanks to Vance for all the technical support and all the extra effort and all of the back and forth and and everything he did to help us pull this presentation off. I also want to give a shout out to George Mason University and the library research specialist there, Trevor Watkins, and helping us and sponsoring us with this Zoom connection. They're making this Zoom opportunity possible. And we want to give a thanks to our sponsor, C-Test Laboratories. That's where we do most of our daytime work, and they're very good at sponsoring us, and they provide a lot of support for our efforts, our side efforts to promote citizen science. we believe a lot in that, and so CTEST Laboratories has been very supportive in any kind of effort and endeavor that we've decided to pursue in that regard. So we're fortunate, and so we thank our sponsors here. And also, we want to let you know, here's the URL on this slide for this video. It's going to be on YouTube, so you'll be able to access it from the YouTube page, and it'll be available for a link from Linux Fest 2023 as well. And so you will be able to access this. So for those of you that can hear the Zoom and you don't know where we are, you're not able to actually be here today, or you're off-site for whatever reason, you couldn't attend the conference, you'll be able to access this video. As well, we've provided a URL for supporting videos, videos related to the material that we're going to be presented today. We're going to do like a 45 or 50-minute talk, and this talk's got a lot in it, and so there'll be a need to follow up on some of the material and check some of the references, and you may need to come back to it again. And so there are other videos that support some of the more involved concepts that we're going to talk about. So please take advantage of those and be aware of those here. And at CTEST Laboratories, Tracy and I, our primary function is computational epistemology and epistemic visualization. And those are big words for we focus on methods of putting knowledge inside of computer programs, getting knowledge inside of a computer. Not just data and information, but how do we get knowledge? How do we represent the knowledge? Our main focus is on coming up with methods and algorithms, discrete structures and data structures, and different computational approaches to storing knowledge, retrieving knowledge, and finding knowledge in a computational context. And so that's kind of what Tracy and I do. And when we are not largely focused on that, we have a lot of volunteer efforts with citizen science in our neighborhood. We're in Youngstown, Ohio, and so on. We work very closely with the Oak Hill Collaborative Makerspace there, and we do volunteer work there, volunteer teaching engineering to any of the citizens and folks that live in the neighborhood, young and old. We support a lot of citizen science efforts. We are engaged in a lot of local lake and water testing, watershed testing, and that kind of thing. Environmental monitoring, that's the kind of stuff that we do for the citizen science effort and support at CTEST Labs. And so this talk is kind of coming from that area. So that's enough. You can check us out on ctestlabs.org if you want to find out more about the kind of projects that we're both engaged in, or if you're trying to get in touch with us, I believe you can get our emails directly from that site. Okay, now as far as the matrix of, we try to score our videos in a way that will let the people in the audience know what to expect, and whether the talk that you're getting ready to hear right now, whether it's too easy for you, it is too at a low level, and then maybe you're already beyond this point, or whether it's maybe it's not something you're interested in, or maybe it's the material might be too advanced for you. So we try to get come up with a matrix and to give you some idea of the level of knowledge that the audience needs to participate in this. So on the Linux level, we're really talking just beginning level Linux stuff, nothing really fancy there. The same thing with the Arduino. If you know basic wiring with the Arduino and you kind of familiar with the Arduino environment, there won't be any surprises here. Raspberry Pi, the same thing there. And we put intermediate here because we talk about the GPIO pins a little. And so we realize there's some people who use the Raspberry Pi and they don't get into the pin programming at all. And so, that might be considered an intermediate. And then there's some folks that use the Raspberry Pi and that's all they do is the GPIO pins. And so for them, some of this may be beginning. C++, and that is primarily the language that we use at C-Test too, as well, and in all of our efforts. This is intermediate level stuff. We will at least talk about how implementing certain kinds of member functions. But if you know basic C++, you'll be able to follow and sing along, right? Prolog is beginning knowledge. For those of you who know who Prolog is, know what Prolog is. That's a programming language where logic programming techniques are used. You can, if you're familiar with GNU Prolog or Switch Prolog out of Amsterdam, you'll be very familiar with this. It's very beginning stuff. And the knowledge, representation, and reasoning aspect that we talk about is just beginners. And the same thing with descriptive logics. So this is a lot, and some of it could be dense, the stuff that's not beginning. And not everybody will necessarily get this the first time through. So fortunately, it's on video. And so you'll be able to, rewind, stop, pause, go back to it, and, get yourself a drink and come back to it at a later time. So good that it's on video. And now, for who this is for, we kind of see this talk is for 5 people. There are 5 different categories of people. And you're going to have to select to see which one of those categories you're in. So category 1, if you are a Linux, Arduino, or Pi programmer with just way too much time on your hand, then this talk is probably for you, okay? Also, category 2, if you're a sci-fi hacker who has been secretly developing your own private thinking machine and you're missing just a few pieces of information, something you can't just quite get there, this talk could be for you. If you are an AI researcher out there and you're just a tad bit suspicious about all of this chat GPT stuff, this talk could definitely be for you. There's no question about that. If you're in category 4 and you've had no other session to go to this morning, and you got caught up by the clickbait title of this talk, right? For you, this should be a wild ride, and hold on, right? And the last category we have, if you believe you are the last Jedi, or the Kwisatz Haderach, or you're the chosen one, and you feel no one understands your strange Arduino Pi Linux creations, then this talk is definitely for you. And maybe you should drop us an email at CTEST Labs at your earliest convenience. Now, if you don't feel like you're in any of these categories, right, and you manage to survive till the end of the talk, then drop us a note in the comments and let us know what you thought, and let us know what categories we should add in the future when we make this talk. And the title of this talk is Arduino meets Raspberry Pi, old programming techniques for knowledge embedded systems. And old is an acronym, and we'll get into that. That's kind of like a double entendre, because some of the techniques we are talking about are really true and tried, and they've been around in the thinking machines community for some time. But some of it is state-of-the-art stuff too. So old is kind of just a play on terms here. And here's another important point that we don't want to leave out. As far as the term artificial intelligence, this is a disclaimer here. The AI is being hyped. That term in the abbreviation AI has been hyped and applied to so many technologies in so many different ways, with so many vague expectations and so many just weird notions with so many contradictory and undefined features that we really don't even know what the phrase artificial intelligence even means anymore. AI, we can't put our finger in it anymore, so we just don't use it. And so we won't talk about it beyond this slide. Okay, so you may be, as you're listening to our talk, placing this in various AI categories, and you're welcome to do it. We're just letting you know that we won't be using the acronym, the abbreviation or the term artificial intelligence for the rest of the slide. That's just kind of like this is just a disclaimer, just so we won't, fray any expectations here. Also, this is only old programming techniques. There will be no discussion of ChatGPT. So for those of you that are looking for that kind of thing, it's not going to be here. Won't be any talk about machine learning or deep learning or large language models. All of those of you out there that are looking for the latest and greatest in web programming, we're sorry. There's none of that going on. No Rust, no Node.js, none of those things. This talk is really going to be just focused on embedded type programming, microcontroller, Raspberry Pi level stuff, and that's the gist of it, right? And so if you're looking for that other kind of stuff, this probably is not your talk, right? And so we've got embedded devices, and what those are, and we've got this Arduino and Raspberry Pi combo, and we're developing these devices, and the point of these devices is to do environmental monitoring, and we're really talking about home level, do-it-yourself environmental monitoring, and of course, a lot of these devices, at least not the thinking versions, you can get simpler versions, off of Amazon for $40 or $50. So, it's not like this is some kind of breakthrough technology. This is for those, those hackers and those tinkerers and those programmers that want to make their own, and they've got the time to do that, and they want to make something that is knowledge based and that will give them a little more bang for the buck, and it's just interesting programming for them. And so the kind of monitoring we're doing and making autonomous devices for, I might monitor things like carbon monoxide or other dangerous exhausts that could be in your home. Maybe you got a soldering bench, and you don't realize how much of that solder has gotten into the air. And so your system is going to let you know that. Fire, smoke alarms, all kind of things for indoor environment. Also outdoor monitoring, any kind of like monitoring your lawn, your garden, those kind of things. The soil monitoring, checking salinity and conductivity, pH, nitrate levels, all that kind of stuff. And if you need an autonomous embedded device that helps you monitor, maybe you got a small farm or small garden or something that you're trying to monitor, keep the flowers growing, something like that. We give you ideas and an approach to do this and build a system on your own that has some heft to it. Also, we're into the local lake watershed testing for harmful algae bloom. Like if you were to go to our site, you would see some of the underwater robots that we use. We have sensors and cameras attached to those things, and we have smart devices that we've designed to be a part of those. that help us do watering, monitoring of like park lakes and recreational lakes in the Northeast Ohio. Like for instance, we have a Mill Creek Park Lake project where we're working on doing a video survey, an underwater video survey of some of the Mill Creek Park lakes, like Lake Newport, Lake Dozier, Lake Glacier, some of those different lakes. So these are all environmental monitoring devices that you can build using a combination of Arduino and Raspberry Pi, and some of the techniques, the old programming techniques that we're going to talk about today, and give you an overview today. If you apply those, you'll come up with something that'll give you monitoring ability, autonomous monitoring ability, but this has way more functionality than something you might buy on Amazon, right? And so for those of you that are the do-it-yourself types, or folks with some of those Arduino and Raspberry Pi programmers that have way too much time on their hand, here are a couple good book references. They have some real easy and interesting projects in them. They're pretty inexpensive from what I remember. They're like under $10, these things. And so if you were looking for ideas for environmental monitoring, and little projects with examples and that kind of thing, these are good starter type things, stuff that will kind of inspire your imagination with respect to atmospheric monitoring or environmental monitoring. And I recommend them. I have them. I've used them. I use them in classes. They're good books for what they are, and for the cost, you really can't beat them. You're done by O'Reilly and MakerPress. So this is good stuff. And so for those of you that are interested in this kind of thing, this is a good place to start, right? And so we have the Arduino and Raspberry Pi, and the Raspberry Pi OS. It's like a trio here that a lot of times people just refer to the Pi and they're just thinking about the hardware. But boy, that Linux basis, the Raspberry Pi OS is with all of the tools and utilities and the access and availability and the applications that are available in a Linux environment. It's a powerhouse in its own right. And so we use these three things together. First of all, there are things that we need to do as far as sensors and dedicated effectors and actuators that the Arduino is best for, right? That's what it has. The ports, it has the pins. It's designed real well for that. It has the price point for that. It's a nice little microcontroller, and so we have dedicated things that we do on the Arduino. And then the Raspberry Pi just has way more capability at a higher level, having that ability to attach external storage and HDMI monitors or whatever it is that we might want to attach to it. The Arduino brings that, the Raspberry Pi brings that bigger thing, and then we have the entire Linux environment with the free and open source software that just allows us to do things from a citizen science level, and it just brings down the cost and makes it accessible to people that need to do this kind of stuff, or that want to do this kind of stuff. So the Arduino and Raspberry Pi and the Raspberry OS for us, it's a nice trio for a lot of reasons. Some of them, beyond those I just mentioned, are just the sensors that are available. If you're doing monitoring type and measurement type work, the Arduino and the Raspberry Pi, they are your friends. You can find a whole bunch of sensors in a wide range of application areas that are just readily available for both the Raspberry Pi and the Arduino. The ultrasonic sensors, connectivity sensors, magnetic sensors, tilt, gyroscopes, communications. soil, oxygen, just about anything that you want to get at in terms of home, do-it-yourself environmental monitoring. There's a Raspberry Pi or Arduino sensor out there for you, and if not, a combination of those sensors can give you a little bit even more functionality. So as a wide sensor array, these things are also very affordable. You get packs of them for, in some cases, under $100. So that was another reason why we went to Arduino and Raspberry Pi to build our embedded devices, because the availability of sensors is just rich. And folks that know a lot about sensors are part of the Arduino and Raspberry Pi community. And so for those of us that need help with that kind of thing, there's plenty of folks out there that will help you and that are knowledgeable about that. And also the folks at the NIST, there are some folks behind the scenes there that work with the Arduino and Raspberry Pi community. National Institutes of Science, Standards and Technology. Those folks, they have some good people there. And as a matter of fact, in any of the 17 national labs, at least the ones we work with, there are people that will work with you behind the scenes on some of those, and they work with your school and that kind of thing. So anyway, sensors was a big thing. For the Arduino, that Arduino programming environment was also a big reason why we picked that. It makes programming these microcontrollers, it makes it very accessible, a lot more accessible and a lot more open than some other environments. I won't mention names. And the support that Arduino has for C++ and object-oriented programming. And make no mistake about this, the programming environment for Arduino is a subset of C++. There are obviously, because it's a microcontroller, there are obviously things that you can't bring the full set of class libraries in, and the full set of memory management and those kinds of things in. But it's a legitimate subset of C++. It's not some strange variant of C. I hear that a lot of times. People think that the Arduino is some kind of a C because when they boot up the environment, all they see is a setup and a loop function, and they don't really see the C++ they're used to. But those functions are really just convenient candy functions, sugar functions out there to make things easier. There's a main line, and there's you can get at regular C++ in the Arduino environment. So it has full support, or at least as much of the support for object-oriented programming that we need. And in the object-oriented programming that we use, we implement a lot of procedural and declarative knowledge techniques using that. So the Arduino environment is perfect for us in terms of the microcontroller programming, and so that was a big thing. And then the Raspberry Pi, you just can't beat this thing with all of the capabilities, the Ethernet capability, USB access, the storage, the processor speed, the HDMI is just, and it has the GPIO, these 40 GPIO pins that let you program serial programming, I2C kind of programming if you've got the courage for that. It's just a wealth for people that are trying to do low-level programming. That you can't beat it. It's 5-volt power, 3-volt power. UART kind of programming. You got the clocks that you have. It's just for people who are doing microcontroller, microcomputer, pocket mobile microcomputer, or computing kind of applications. The Raspberry Pi is like, and it's Linux based. It's just a powerhouse. And so that's also the camera. Like we. In a lot of our applications, we have a camera component. We're running OpenCV on there for object recognition. It's just a powerhouse, right? So you couple this with the Arduino and Raspberry Pi OS, and you really have something to work with. Okay, so let's get right quick here. We're going to talk about this old architecture, and we're just giving like a simple overview right here. It's we're just kind of giving a logical view of a knowledge-based embedded device. And keep in mind these embedded devices are used in physical computing most of the time, and I guess I want to distinguish physical computing from like desktop computing or web computing. You know what I mean? Where in the physical computing you're using the device in as a part of some other process, outside of say a business application or something. But that's a whole nother talk, a whole nother discussion in of itself. Let's just suffice it to say that we're talking about knowledge-based devices that are used primarily in physical computing. And in this case, the physical computing application is environmental monitoring. Now, in our OODA architecture, so we're going to talk a little bit more in a minute here about what OODA means. But in this OODA architecture, it's an agent-based architecture. So we have two agents. We have one agent that runs on the Raspberry Pi, and we have one agent that runs on the Arduino. The Arduino agent it has procedural knowledge about sensors, effectors, and actuators. The Arduino agent has C++ models, detailed models of specific sensors, specific actuators, specific effectors. So it's the device-specific knowledge that we model and that we run on the Arduino. Okay, so if I am using a particular, let's say, an HRSO4 ultrasonic sensor, then the model of that sensor, that specific sensor, has been implemented and is running in the Arduino environment. Okay, and on the Raspberry Pi, we also have a sensor agent there, and on that sensor agent, it has access to the knowledge base that we're kind of alluding to. It has access to algorithms that we call reasoners and inference. It also has high-level sensor models. And so what we mean by high-level sensor models, it may know how to interact with let's say, an ultrasonic sensor or a light sensor or a magnetic sensor at the high level, but it doesn't have any knowledge about a particular ultrasonic sensor or a particular conductivity sensor, right? And so that kind of knowledge is actually stored in the class that's running on the Arduino. So if you look at it, the Raspberry Pi agent has high-level knowledge about sensors, effectors, and actuators, and it has models of those things. And the Arduino has low-level, detailed, device-specific models of vendor-specific models of those kind of things. And then we have the Raspberry Pi. So it's kind of a dual-agent thing. One agent runs on the Raspberry Pi, one agent runs on the Arduino. The Raspberry Pi is more generic with respect to the hardware. Our Arduino is more specific with respect to the hardware. So kind of keep this picture in mind as we're going. And the devices that we are running need both of these components, right? Where for the architecture that we're talking about, you can't just have a Raspberry Pi. I mean, you could just have a Raspberry Pi, but it's going to make a lot of your programming harder, and you're going to be taxing those GPIO pins beyond what you need to. And so it just makes better sense to distribute that work. Okay. And so what do we mean by OODA? It's an acronym. OODA, the O is for object-oriented programming, the L is for logic programming, and the D is for descriptive logics. And we use those three concepts to help us develop embedded, knowledge-based, agent-oriented systems that can think about the monitoring process. Okay, and when we highlight think here, we really do mean that. And we say old, again, as it's an acronym, but yeah, these concepts have been around. These are true, tried things, and they aren't going anywhere. And for the work that we do, these are the best techniques and approaches to architecture that we've been able to come up with. And we've been at this for a few years now. And so we stick with these things. And it's an approach to using Arduino and a Raspberry Pi. We feel that will help you, if you're trying to do this kind of work, it will help you be more, you'll get a better handle on your projects. You'll be able to maintain them better, understand them better. You'll be able to apply them in more areas. And so C++ is the primary thing that we have going on. And then on the logic programming side, on the Raspberry Pi, we use switch Prolog. That's what we call it. We've got a link here on the slide. Some of you may have never even heard of this before. I don't even know what Wikipedia says about this language. I just know that in the logic community, it's a big deal. And as far as we're concerned, it's state-of-the-art in many ways. Others may see this as a language from days gone by, but I assure you it's alive and well. There's a GNU Prolog, but we didn't find it flexible enough to do what we were trying to do, and so we went with Switch Prolog, which is also an open source technology. So anyway, the old programming techniques that we're talking about involve object-oriented programming, logic programming concepts, and descriptive logic programming concepts. And combining those things together, we're able to make these systems that can think about the monitoring process. And so what do we mean by think, right? That's a charged word. And so at CTES Labs, we kind of define it by a list of terms, right? So for us, it's these operations here: evaluating, calculating, computing, analyzing, supposing, positing, deducing. It's those kinds of things. Notice we have some of these terms in red. These terms, although a part of thinking, we do not implement those. And so we haven't been able to do pondering and innovating and wondering and imagining yet. We'll save that for other kinds of ambitious software. But the other ones we do. And there we have very specific algorithms and procedures and programs and functions that implement these kinds of operations. And they are running on the Raspberry Pi and on the Arduino, right? So these are not things that require massive supercomputers running in the cloud and all this kind of stuff. We don't have that going on. We're talking about everything we're talking about today actually executes right on the Arduino and the Raspberry Pi, and so these thinking operations are done. We're going to give you references to this kind of programming at the end of this talk. But this is all done with epistemic and dosastic and deontic temporal logic frameworks. Again, I wouldn't be bringing them up if we couldn't implement this stuff in a Raspberry Pi and Arduino environment, but we can. And so when we say thinking, this is what we mean, and these are the kind of operations we're talking about. And now we keep saying knowledge base. I want to differentiate and just contrast a knowledge base to a database. So when we say knowledge base and knowledge based, you can kind of picture what we're talking about. In a database is typically going to just store, a collection of data and information. That's what it does. And the kind of operations you get happening on a database, you get selection, and I'm just using SQL, SQL here. You get selection operations, union, intersection, subtract, those kind of operations. You do that on the data and information that's stored in a database, and that's what happens. A knowledge base is a very different thing. Contrary to some of the things you might see on the web where they show knowledge base just being a collection of frequently asked questions, that's not what it is in our community, in the KRR community. Knowledge base is a very technical thing, and it's a set of propositions, and it has a set of reasoner type operations. The operations that you do, where you do selection, union, and intersection on a database, on a knowledge base, you're going to do assertion, deduction, abduction, induction, retraction, logical type operations. So a knowledge base has a collection of propositions, and database has just data and information. Very different things, very different kind of processing. And just for those of you who are trying to look ahead, the knowledge base runs on the Raspberry Pi. And we also want to make this point, there's different kind of proposition types using knowledge bases. We got like 9 of them here. You got rules and facts, and you got axioms, theorems, conjectures, suppositions, corollaries, lemmas, and assertions. Those are all different kinds of proposition types that are stored inside of a knowledge base. So whatever is in the knowledge base is going to be one of these kind of things, one or more of these kind of things you see in this table here. We use these type of propositions to give our devices, our smart devices, the ability to think, right? To perform those operations that we talked about in the previous slide, right? And so keep that in mind. These operations here, we use those propositions to perform these kind of operations, just so everyone has that in mind here. And again, in our embedded systems, the knowledge base is stored on the Raspberry Pi, right? Okay, and what do we mean by agents? So we talked about there's an agent that runs on the Arduino, and we talk about there's an agent that runs on the Raspberry Pi. Well, for our purposes and the development that we do, an agent is an autonomous, knowledge-based program, right? It is not something that is interactive. You're not going to be pointing and clicking with a mouse to use it. This is something that is these are autonomous programs. The program that runs on the Arduino, those of you that are familiar, the minute the Arduino gets power, it just starts running whatever has been stored on it. And on the Raspberry Pi end of things, we launched that Arduino as a part of System D with a System D timer or with a cron tab scenario. So it runs at all times as well. And it runs immediate. And it's autonomous. So whatever it's going to do, it does that without your input or with very little input from you, just enough to get it started. Okay, and so the agent types, there are a lot of those out there. Those of you that are hearing the term agent for the first time, you might quickly run to do a fact check on us and jump on the web and see what you can see. And you're going to find out there are lots of different types of agents. The ones that are relevant to what we're talking about today: rational, epistemic, hysteretic, utility, tropistic, and deliberate. Those are relevant to the kind of agents that we're talking about today. But specifically, the agents that we develop at CTES Labs are epistemic agents. Now, epistemic agents are basically knowledge-based agents. Agents where knowledge is the primary focus of the function of what that agent is. So we have epistemic highlighted here. And so if you really want to dig down deep and try to see what's going on at maybe the formal level or the conceptual level, you might look up epistemic agents on Wikipedia or something. It might excite you in some kind of way. Okay, and now we're going to give just a brief overview of the programming techniques, try to give you a little more detail on it. Okay, so there are 2 C++ classes. One of those classes is going to be defining the Arduino sensor agent. The other is going to be defining the Raspberry Pi sensor agent. So keep that in mind. To do this programming technique concept, you have 2 different classes. One class runs on the Arduino, the other class runs on the Raspberry Pi. The Arduino sensor agent is going to be a specialist. It's a sensor specialist, it's an effector specialist, and it's an actuator specialist. In essence, that means it's going to have the models of the device-specific things that you have attached to your Arduino. If you've got a magnetic sensor attached to your Arduino, then your Arduino agent is going to be a magnetic sensor agent, and it's going to have a model, a C++ class model of that magnetic sensor. That's what this is referring to here. And on the Raspberry Pi is going to be an environmental specialist, right? And a measurement specialist. And I say that, like, for instance, in one of our applications that we just did recently, we did for Robot Week, we were measuring the salinity of soil, how much salt is in the soil. And so that Pi agent needed to have a lot of knowledge about soil salinity and measuring soil salinity. So it's a specialist in that regard. It also knows something about the sensors. It's a generalist in that specific sense. And it's a generalist at the effector level, and it's a generalist at the actuator level. Like, for instance, to measure salinity in the soil, any soil, and this could be soil your front yard or backyard, you could use something called a conductivity sensor, electroconductivity sensor. How conductive is the soil in your front yard or backyard, and the Raspberry Pi sensor agent generally knows what a conductivity sensor is. It has a general knowledge of that. And the Arduino sensor, in our case, we use something called a veneer conductivity sensor. The Arduino sensor had very specific knowledge of that veneer sensor. It knew what modes that sensor operated in. It knew what the voltage translation was for that particular sensor. It knew what the slope and the intercept was for that sensor. It had very detailed knowledge of that particular vendor sensor. Whereas the Raspberry Pi sensor agent, it knew the function of a conductivity sensor and what kind of readings you should get back from it and what those readings should mean. On the other hand, Arduino sensor, it doesn't know what those readings mean. It knows how to get them, it knows how to be specific, but it doesn't have any environmental or real measurement knowledge. The Raspberry Pi has that. You'll be able to see that as you get into this kind of a design. One of the agents has a high level knowledge of things and the other agent has a very low level knowledge of things. Also, you have a Arduino sensor agent.h file where you declare the class, and a .cc file, .cpp file for those of you that prefer the CPP thing. You define those two files, and here's an important point. You put those in that Arduino/libraries directory. I have library singular here, but that's libraries plural. Libraries directory. You do not put the class declaration and the class implementation in the setup and loop functions. That's just going to get you into trouble. Okay, so those of you that are beginning, just your beginners at the Arduino programming thing, I'm letting you know now. You find the directory on your computer that has Arduino at the head of it, and you go to the libraries subdirectory, and then you create a directory for your Arduino sensor agent .h and .cc files. And you will also have Pi sensor agent.h and Pi sensor agent.cc. You put those wherever you want. That's a Linux development environment on the Raspberry Pi OS, and so you'll know where all of that stuff is and where to put it. You want to put this when you get to the Arduino, it needs to go in a certain specific place. Okay. Also, just dividing between the functionality between the Pi sensor agent and the Arduino sensor agent. The Arduino sensor agent, the member functions. Okay, so keep in mind a C++ class is a set of attributes and member functions. The member functions implement device-specific procedural knowledge. Okay, I do not have time here to define what procedural knowledge is, but it's the knowledge of how to. I can give you just a brief kind of a quick kind of thing, like the knowledge of how to ride a bike, or how to jump a car, or that kind of knowledge. The member function on the Arduino class, they implement procedural knowledge. That's one of the reasons why we call it knowledge based, because it has particular kinds of knowledge that it implements.
Thank you very much. So we do happen to have Cameron and Tracy on the Zoom link. So if any folks here have questions, please go ahead. Any hands? All right. Oh, and also, if you want to, you can post questions on the main stage channel in the Slack if you have them.
Thank you for the talk. What sort of speeds would you typically be sampling that at? Like 100 samples a second per channel, or 1,000? Can you give me an idea of what you typically sample that stuff at?
When you say sample, what do you mean? We are using, in most cases, Hawkins and helping us and sponsoring us with this Zoom. Okay, in most cases we're using a 9600 baud serial connection, maybe 38K serial connection. We're not going any faster than that. Can you hear us?
Can you repeat that for us?
Yeah, most cases we're using a serial connection, and even the Bluetooth, we don't go any faster than 38K. You guys hear us?
Barely. It looks like the problems on our end.
Okay. And this is the end of part one. We have part two for this video is available at the URL that we mentioned at the beginning of the slides.
So maybe if the initial part of the answer, maybe if they repeat it, I can relay it through.
Yeah, if
38K, 9600 baud, 38K.
Can you repeat the initial part of the answer again?
Yeah, we are running over a serial port connection between the Raspberry Pi and the Arduino. So at best, it's for us is 96 baud
to 38K. That's about as fast as we reliably connect between those two devices.
Okay. Sorry, folks, for the issues. All right. Any other questions here in the room?
Hi, Sam. Can you hear me?
Yes.
Let the audience know that part two of this video is at the link that we gave at the beginning of the talk. So we ended part one here because of time constraints.
There is a second part of the video that is available. There was a link at the beginning of this video, and you can find it there. So it looks like there are no more questions. So thank you very much.
Thank you.
And we'll get ready for the next speaker. This should be easier because we were Oh, yeah, I'll do a little intro and then hand it right off.
Yeah, give it, well, 9:59. Good to go.
All right, welcome everybody. Thanks everyone for coming out. We're excited to present our next speaker, who's going to be Brad Krumme, and he's going to be talking about exploiting the IT value stream. So please take it away, Brad.
Thank you, everybody. So quick intro for myself. My name is Brad Krumme. I'm a Red Hat certified architect and solution architect at Red Hat. My specialty is in automation. My primary goal in my day-to-day work is helping my customers, which are the enterprise customers throughout Ohio, Kentucky, Indiana, and Michigan. I help them with automation and automation strategy. Of course, I'm a pre-sales person, so it means I'm also trying to sell them something. I'm not trying to sell you guys anything today. I just want to talk a little bit about that strategy piece that I mentioned. From a agenda perspective, I have kind of two parts of the talk today. First, I'm going to talk about the why, which is the challenges that IT leaders have and the IT teams have when they're tasked with automating everything. And then I'm going to talk a little bit about how, which is a methodology that I've developed. I didn't invent it, but I've helped develop it for use in information technology in order to help inform teams and IT organizations when they're trying to automate the entire world of technology that they have. Right? So let's start off with that why first. And this why really starts with one challenge for the teams that I see very, very pervasively throughout technology. And it's a concept we call the 80% trap. Now, just a real quick raise of hands, how many of you have heard that 80% of the things that you do are made up by about 20% of the changes you make, or 20% of the incidents? Who's heard that 80% rule? Yep, just a lot of folks, right? So when IT teams try to automate, what they typically focus on is that 80% of the things that they track in tickets and in changes and things like that that are really easy to automate, right? And it's okay, it's good that they're focusing on that, but what that means is they're getting rid of all the little pieces of work, that are things they do every day, they're very repetitive, and the idea is they're trying to get it out of their way, right? That's all well and good, right? So that's that 80% that's easy to automate. They're the things that you're going to do, you know, when somebody gives you a quick call, hey, I need to clear temp space on a system, or I need to reset somebody's password or something like that. We automate those to try to get them out of the way, right? That leaves this other 20% of the work that we do that's really, really difficult to automate, okay? The problem with this, though, is if you see the correlation here, that 20% represented in black here, they're the easy things to automate, but they're the ones that actually provide the most value to our business, right? This is kind of a problem because not only are the IT practitioners trying to automate things to get out of their way, but they have vendors, like me, who are telling them that this is the way that they need to do things from an automation strategy perspective. It's actually not the case. That 80% of things they try to automate that's very easy is usually about 20% of the value to their business. Which means the other 20% of things that are difficult to automate really makes up about 80% of the value to the business. Now, give or take a little bit, that's pretty much how it goes. So when you have people who are trying to automate things and get them out of the way, that's usually referred to as toil, right? There's a problem with trying to automate away toil, though, and that big problem is that when we try to automate toil, which is that kind of invisible, pervasive work, it's unrewarding, it's things that we just want to get off of our plate, usually what happens is you'll have multiple teams or multiple individuals that try to solve the problem each for themselves, from an individual perspective. So you'll have a systems administrator that tries to solve a problem. They'll do it in one way. They become the master of that problem. You'll have a Devops engineer who tries to solve a problem in their own way. They become the master of that problem. And what it creates is these silos of automation. We'll talk about that here in a little bit as well, but it creates these silos of automation where you have individuals who are really kind of specialists, and they end up becoming a constraint in your environment. When we talk about automating toil, one of the primary things that I like to tell my customers is that if you're going to automate those simple things, those tasks that are invisible, the tasks that are pervasive, you want to try to get them out of the way for everyone, which means you want to standardize across your entire organization so you're not repeating work, so you're not doing rework, so you're not really having to do the same thing over and over again, just like you already were. Okay. Next problem for teams is this widening skills gap. Now, the data you see on screen right now is from a study that was done in 2017. I think it is still pertinent today, where we have IT teams who they're being tasked with more. They're being told, hey, we need to automate. Hey, we need to adopt Kubernetes. Hey, we need to make sure that our virtualization systems are in check. Hey, we need to go to the public cloud. There's all of these things that our IT professionals have to do, which means they have to learn how to do it, and they have to learn how to do it well. They're not able to learn all of the things they need to do, so there's this skills gap that is being created throughout IT organizations for teams at every level. I see it all the time. When I speak to my customers, it is really a problem, and one that we should probably try to be solving, right? When we talk about IT leaders, there's a problem I see with automation strategy, right? So as a IT leader tried to strategize on how they're going to do automation, they know they need to automate. They've gotten the direction from their C-level or senior management. They understand that building automation capabilities is going to be important. The enterprise they manage usually has some critical workloads that they need to maintain. And they have to do it with less. There's probably less people. They have lower budgets, things like that. The only way to achieve that is through some kind of automation, but they don't know where to start. So their automation strategy usually consists of, hey, all of you teams over here in IT operations or in infrastructure or wherever, go do the thing, go automate the stuff. What that ends up with is we have teams using domain-specific tools for their specific case. So in the case of, say, systems administrators, they're going to use something like Puppet, maybe Chef, maybe Ansible, to do their configuration management. From a networking team perspective, they might use something like Cisco ACI. Maybe they'll use something that comes from Aruba or another network provider. Your cloud engineers are going to use something like Terraform from HashiCorp. And then, of course, there's the age-old problem of shell scripts that end up getting kind of shoved under the table when they either don't work or they get sent to some new guy to try to fix when things don't work. Another thing we see is that there's kind of laissez-faire, siloed automation. Maybe the IT leaders aren't telling people to go automate things, and they're deciding to do it on their own, like we talked about before, to get it off of their plate. And what this does is the same thing as having those domain-specific tools. It creates those silos of automation that have boundaries around them that end up causing more of that, that toil to be reworked over and over and over again. And finally, of course, we have teams that are doing tactical task reduction techniques when it comes to automating their environments. Each of these has their own kind of challenges, but what they all lead to is this one big problem for IT leaders who need to be able to prove that success is achievable and they've achieved success, and that is fragmented observability. Because they have these domain-specific tools, teams are working on their own, and they're doing tactical measures to automate their environments. The observability of where they've been successful is basically nil, right? Or it's fragmented at best. What this leads to is IT leaders end up using metrics that aren't necessarily great. So I'm going to go through a few of these today that have a component in reality and will help to a certain extent, but don't really tell the full picture, right? Our IT leaders' hearts and minds are in the right place, right? I think they want to do things for the betterment of the business. But these metrics tend to have a negative impact on not just the business, but also on the IT practitioners, people like you and like me, who are trying to get work done. First one is, how many incidents did we have over X period? Like, how many things happened that were a problem over 3 months, 6 months, whatever, right? How many failed changes were there? When we made a change, how many times did it not work, right? And then how many production outages did we have? So I'll quick show of hands again. How many people have seen this metric be collected where they work? Yeah. How do you feel about these metrics? Yeah, I see some thumbs down from everybody. So what happens is they probably make you feel bad about your work. They're not encouraging you to do better, right? They're not actually helping you feel as if you're successful or valuable to your business, right? It's leading to a negative impact on productivity and on engineers' morale, right? These are things that we don't want. If we're trying to accelerate the things we do via automation, we want engineers' morale to be higher. We want the productivity to go up instead of down. The last thing from an IT leader perspective that they face is a funding issue, right? Of course, it takes money to do a lot of these things. We're here at an open source conference, so you could save some money by using an open source tool to do some of these things, and that's great. But from a funding perspective, let's go back a little bit to where we talked about that widening skills gap. Talent budgets, from what I've seen at least, are at an all-time low. I remember before I came to Red Hat, I actually worked at a Fortune 500 company in Cincinnati, and I didn't have a talent budget to speak of at all. I had to do all of my learning on my own, right? Next thing is tools cost money too. I already talked about domain-specific tools that multiple teams are using. They've probably paid something for those to get support for them. They cost money, and we already have 10 of them. So we're not going to spend money on another tool, right? And then finally, we've automated a lot already, but we can't prove success. And because we can't prove our success because of the fragmented observability of those domain-specific tools and laissez-faire automation, we can't actually put a proposal into our senior management to get funding for the tool that will actually help us do what we need to do. So now let's talk about the how. All of these things said, I've found kind of a methodology that I would love to share with everybody about how we can shift the focus and solve some of these problems and take down some of these challenges, okay? This starts with isolating the constraints in our environment. In order to isolate them, though, we need to kind of know what these constraints are. Now, this comes from a manufacturing background. I don't know how many of you work for a manufacturing company and have seen this. A few people? Okay. So this concept is one that was really pioneered by Toyota back in the 80s, the Toyota production system. It was a way for them to make their operations more efficient. It was a way for them to start building better cars. If anybody had a Toyota vehicle back in the 80s, you know how not great they were. But now, everybody wants a Toyota, or it's a very pervasive vehicle, because the efficiencies they built into their manufacturing processes have helped them. Right? They build better cars, they build cars faster. Right? So let's talk about some of these constraints. These are types of waste that are in the processes that we see across the entire IT enterprise. Right? Like I said, they have a background in manufacturing, but they apply to technology as well. The first one is defects. Right? So a defect could be any kind of error, any kind of rework, a bug that occurs, you have an incident that happens, something like that. That would be a defect. Right? Next up, we have overproduction. This is working ahead just in case. Now, we've largely gotten rid of overproduction in IT because we're adopting technologies such as cloud providers, such as VMware, where we're not putting things out there ahead of time and making sure that we do things extra in order to get things done. Waiting. This is probably one of the biggest constraints that I see in every single one of my enterprise customers. They end up waiting to get work done. There's always some kind of extra lead time for whatever process that they're trying to automate. Non-utilized talent. So I talked earlier about that domain-specific siloed automation. Maybe you have a subject matter expert who automates something. They're not the person whose talent is underutilized. The people whose talent is underutilized is all of their teammates who didn't help them develop that solution, where they're not using the same language to do automation, where they're not using the same techniques to do automation, so that talent is underutilized. And I'm sure everybody here has heard of the bus theory. When that one person who created everything gets hit by a bus, now you have no talent being able to do the work because that knowledge that was held by that individual is now lost. Next up, we have transportation. This is going to be movement of data, mostly for technology. It's movement of data in the manufacturing world. It's movement of inventory or parts that doesn't have value, right? It could be process components that don't really help us do anything, like that extra piece of reporting that nobody looks at. If you think of a monitoring system where you're collecting a whole bunch of events and then you're reporting on the events, or you're sending an email about something that nobody ever looks at, that would be transportation. Okay. Next up is inventory. I mentioned inventory before. This is kind of like overproduction. We don't do as much of this as we used to in IT, but something I did when I started in IT 20 years ago is I used to have an inventory of a whole bunch of pieces of hardware sitting there in my warehouse, ready for me to go put into the data center. Right? We don't have inventory anymore. We like to do just-in-time enablement of our technology nowadays. We have motion. Okay? These are the extra meetings, the extra steps that you have to take, the extra kind of fluff. When you get invited to a meeting for an hour that really should have been a simple email or maybe a text message, that would be motion. When you have to walk over to another building on your campus to go talk to some dude on the network team that's really separated from you, that could be transportation or motion. But it's the extra things that don't really have any value. Right? And then E, excess processing. Excess processing is repeating or duplicating steps. This is where rework comes in, where okay, we have this thing that we've automated. We did it with a shell script, but it only works 10% of the time, so we have to rerun it almost every time we do it. That would be a really great example of excess processing. If we can remove that constraint that we have, then we're going to be better for it. Now, all of this, as you can see, creates a nice acronym down the left there called downtime. So excess in any or multiple of these areas is going to create more downtime for your services. You isolate these constraints, and you help solve the problems that have created them, and it's going to create more downtime for the engineers, which is a good thing. I talked about metrics before. Most people gave a thumbs down when I talked about collecting those negative connotation metrics, but there's some good ones out there as well. If you've never read Accelerate, I highly recommend it. This is most of the data that is behind books like the Devops Handbook and Phoenix Project, if you've read those. And it highlights 4 metrics. The first one being lead time. Of course, lead time essentially is the total time that it takes for a task to be completed or for a process to be completed, from beginning to end, from the time it's requested until the time it's actually completed. A value that is lower is going to be better. The lower the lead time, the quicker we're bringing value to our business and to our IT organization. A high value of this actually suggests some of those constraints exist. Something like waiting, transportation, or motion. Usually it's going to be waiting when it comes to technology from my experience. The next one is change frequency, right? So the more quickly we can make changes, the more agile we are, the more adaptable we are, right? For this, a higher rate is better. And a low value, it really indicates excess processing, non-utilized talent, overproduction, maybe excess inventory to a certain extent. The idea is we want to get our changes more frequent. We want to do them more often, right? And we want to make sure that they're complete, which brings us to our next one, change failure rate. So change failure rate, we kind of had a component of this earlier on those negative metrics, so the number of failed changes in X period. I only really told half the story. We want to collect the rate that changes fail, not necessarily how many failed, or take a look at who made an error or a mistake. And for this one, lower is better. Obviously, we don't want changes to fail. And as you can see, we put all three of these together, and we start getting a really good picture of how successful we are, right? Now, the change failure rate, a high value is going to represent some kind of defect in implementation or defect in results. This is one of the primary reasons we automate, because we have a standard way to do a particular task or a particular process, which means it's going to be completed the same way every time. There's not a human that's involved that is going to inherently make mistakes. And then finally, we have mean time to restore. Now, if you've read Accelerate, you'll know that this particular metric is one that we don't necessarily pay a ton of attention to, but it's actually an indicator of the overall success of our organization, right? Mean time to restore, of course, lower is better. And what I like to tell my customers is if you can capture your mean time to restore a service, especially if you're doing things via automation, and it's very quick, that tells you that you can also enable very, very quickly. You can do things faster, right? And then you can make sure that you have all of those abilities around your services that you're giving to your business. Right? So how do we put all of this together and actually provide a means to inform our environment, inform our organization in order to make decisions about what to automate first? If we're not going to focus on the 80% of the easy things or even the 20% of the hard things to automate, we need to focus somewhere. So how do we decide where we're going to focus? We're going to use a map. It looks a little bit like a treasure map, but not really. And the things we're going to want to put in here are identification of waste in our processes. We've started isolating our constraints. This is going to help us to identify the waste in those processes. We want to make sure we're improving our quality of work and standardization. So this map is going to have components that give us an idea of the quality of our work. Okay? Optimizing process flow, removing excess steps, taking out that transportation, taking out the waiting, taking out all of those things that there's no value in the process. Eliminate rework, utilize talent, make sure more people can actually do the work they need to do, get rid of the rework, the extra steps, the things that we repeat over and over again because they don't work all the time, which is an extension of improving quality of our work as well. And then, of course, we want to use metrics. And most importantly, inform iteration of this process. So the idea is that we have a map. We start in one place. We're getting to another. But at some point, we're going to have to go back to the beginning and do it all over again and iterate. Now, in the manufacturing world, this has been around for a long time. It's called a value stream map. Has anybody here been exposed to a value stream map before? No? Nobody's hands up. OK. So let me tell you what a value stream map is. It's a visual representation of the value or waste in a process or task. It's a way for you to actually see what's going on in that process or task in order to pull out those constraints, right? Isolate them, and then get rid of them, okay? So we're going to have a process flow. If we think about, I have an example on the next slide of like a server patching process. There's going to be multiple steps in that process. They're going to flow in a particular way. There's certain things you have to do first, certain things you have to do last. There might be some parallel processes in the middle that you have to complete. We're going to map the flow of that process. The other thing we need to capture is timing. When we talk about the constraints before, things like transportation and waiting, the timing becomes important. That way we can measure the difference between the lead time, which is the total time it takes, and the execution time or value added time. So we can try to bring that delta closer together. We want to capture the completeness and consistency of our process. How accurate is the automation we're doing? Do we have to do any rework? If it's not complete or accurate when we run it, let's do what we can to make it complete and accurate. And of course, interdependencies. When we start talking about larger processes that span multiple teams in your organization, there's going to be interdependencies. Take server provisioning for an example. You're going to have interdependencies with your security team, with your networking team, maybe a cloud or DevOps team, your server engineering team. Pretty much everybody who has a piece of the pie in IT infrastructure, there's going to be an interdependency. What does a value stream map look like? Let's take a look. So this is that server patching example I gave you before, the one and only Red Hat product reference on the entire screen here. But let's talk about the components of a value stream map, and then I'm going to talk about how you capture all of these components. Okay? The first piece is the process step or task. The details of what you see on screen here aren't really important for right now. I want you to see the overall visual perspective of what a value stream map is. So we capture the process step or tasks. This is going to be somewhat like a swim lane diagram or a workflow diagram. You're going to see data flow or the flow of tasks. You want to make sure that you represent it visually, how it's understood that your organization or your team does this particular piece of work. The next piece is the task owner. It's important to assign a task owner, which won't necessarily be an individual. It could be a team. It could be an IT manager. But somebody is going to own that task. Not necessarily the technical responsibility for the task, but the responsibility that it actually gets done, the accountability for that task. The next piece is the tool that we use. Now, in some cases, the tool you use isn't important, but when we're talking about automation, understanding the tool we use is going to give us an idea of how easy it is to automate. It's going to give us an idea about whether we actually need to change how we're doing the work we're doing. Okay? You can see on screen we have some manually executed tasks here. Those are prime candidates for being automated because we can get them out of the way. We have our task metrics, and there's 3 metrics that we capture for each of the tasks. The first one is lead time, like I mentioned, beginning to end time. The next one is value added time, which is the time it actually takes to execute a particular task. This could be lead time of a day because we had to send a ticket over to this other team to get something done. But when they do the actual work, it only takes them 5 minutes, right? So there's a big delta between those two. The third one is the percentage of completeness and accuracy. So this is how complete is that task when we actually run it. It gives us a view into the defects that we have in the automation or the defects we have in the process so we can fix them. If they're not complete and accurate, that's something that we can improve, either via automation or another means. We have our process metrics, which are basically the metrics for all the tasks combined and represented as a total value statement for the process. This gives us an overall view that we can then use at an enterprise level to inform multiple processes that are interdependent of each other. And finally, we have the definitions for the entire value stream map. My recommendation for teams that want to map out a process is set yourself some time, go into a conference room or do it virtually if that's how you work today, and talk to each other. Figure out how do we actually do this, right? Lay out the process first and then start capturing the data about it. If you don't have a way to capture the data about the individual processes, that's probably where you want to start. Make sure that you have observability into the things that you're doing. Right? So here's the way that we can actually build the value stream map. I showed you the components. Here's like the 10-step-ish process that you can use to actually map the value of a process. First one, you have to pick a process that you're going to analyze, right? I mentioned a couple today: server provisioning, server patching. Those are great processes. Maybe this is a software delivery process that a DevOps team uses, and they're going to end up using a pipeline for it, right? Then you need to chart the flow of the tasks and steps. Make sure you have it correct. Make sure you can analyze it so you can pick out those process steps or tasks that aren't necessary and just get rid of them, right? That's going to be hard for some people to do. Hey, we do that because we were told we have to do that. Well, but why, right? The question you need to be asking for all of this is why, right? Then collect the task timing and effort. This is one of the things that's very, very important. You need to know how long these things take. You need to know how long you're waiting. You need to know how long the process actually takes to execute after you've done the waiting, right? Identify task ownership, right? This one's not quite as important if you have a huge team that's trying to automate something, but assigning an owner means you can now assign accountability for the process once it's been iterated upon, right? You're going to compile your task and process metrics and have the total overall view. This is going to give you a baseline to work off of, right? Remove those unnecessary tasks and steps like I mentioned before. Highlight your opportunities for standardization and automation. Manual tasks can be automated. If you're doing something in 3 different ways, you can standardize it and do it one way. For something like a middleware deployment, if you have 3 different teams that are all deploying the same piece of middleware software in 3 different ways, standardize it. Make it done the same way, regardless of where it lives, right? And then you can prioritize the tasks where value is lost. Usually, in the terms of IT work, the value is going to be lost when we have a lot of lead time but a short execution time. That's what I tend to focus on with my customers. But it could be that we have a task that fails every single time we run it. That's a good opportunity to gain some value as well, right? And finally, go automate the things. Prioritize, automate. Start at the top and start going through your list. And then you have to iterate. So John Boyd, who was a United States Air Force colonel, developed this concept of what's called an OODA loop. OODA stands for, there's basically 4 steps: observe, orient, decide, and then act. The value stream map that I just explained, that I told you how to start putting together, helps us with 3 of the 4 of the steps of the OODA process, right? It helps us to observe. We're collecting data about our process. We're looking at the things that we have to do. We understand what we're actually doing. We understand how we're completing the work today. Then we have to orient ourselves. We're going to analyze and come up with a priority for our task. We're going to come up with how we're going to solve the problem, and we're going to maybe put a plan together. That bleeds into the decide part of the OODA loop, where we're going to decide what we're going to do. That's where we say, hey, what tool are we going to use? How are we going to automate it? How are we going to get it off of our plate and get it off of our desk? And then we have to act. The act part is the only thing that the value stream map doesn't help us with, because we actually have to go do the work. The most important part of this loop, though, is that it is a loop. Once you've done all 4 of these steps, you've observed, oriented yourself to the problems that you have, decided what you're going to do, and acted, you have to go all the way back to the beginning and re-observe again. This is the brilliance of using a value stream map for this kind of work, because you can update the metrics. You can update the process flow. You can update the documentation around the things that you're doing in order to reorient yourself with what the problems are, and then go decide what to do and act again. As you iterate through this loop multiple times on a particular process or a particular task, it's going to become more efficient. From an enterprise perspective, we also need to scale this. There's a few things you can do. The first thing is codify your value mapping process. Make it something that you do across your entire organization, regardless of the team that is working on it. Identify ownership of whole processes as well, which could be somebody who's not even involved in the team that's doing the automation work, right? Make sure that your meaningful metrics are self-identifying, right? If you're mapping things out correctly, then those metrics that you're going to compile are going to be meaningful to everyone who has a stake in the service you're trying to deliver, right? You're going to chart your process interdependencies and highlight opportunities for progress and for growth across multiple different processes and multiple different teams. And you're going to do it the same way all the way across the organization. Okay. The last couple of things I want to talk about today are, first, the importance of transparency. Here's a quote from Jim Whitehurst. He's former CEO of Red Hat. I miss him dearly. I wish he was still our CEO. But he said, quite simply, transparency helps keep people honest. It ensures that people in an organization own their decisions and actions. Creating transparency actually has some really profound effects on IT culture, right? Most notably, it helps to eliminate confusion between leadership and the teams that are performing work. If leadership has a culture of transparency, and they're transparent downward toward the people working, the people understand why they're doing what they need to do, right? Sharing the business and technical need and the importance with everyone in the organization helps build trust, right? Because everybody knows what's going on, everybody knows what the marching orders are. It builds trust, especially between IT leadership and the folks who are doing the real work, right? I know that things were very opaque, I'll use the term, to me when I was still an IT practitioner in a production environment. I didn't know why I was doing what I needed to do. The transparency is going to add that why to the folks who are actually doing the work. Okay? Makes the work environment more satisfying, right? If we know why we're doing what we're doing and we have kind of a path to follow, our work becomes more meaningful. We feel more valuable to our employers and to ourselves. Right? And of course, it increases employee engagement by recognizing effort. Now, there are some things that you have to do along with adding transparency to recognize effort. You actually have to do that, right? But it's another thing that it adds. And it empowers teams to make decisions and provides psychological safety, which is something that's very important, especially coming out of the pandemic that we've come out of, where folks were working from home, probably overworked. Instead of working 40 to 45 hours a week, we were working 50 to 60 hours a week because we were always on. All we had to do was run into our office or sit on our couch with our laptop and work until the wee hours of the morning. But psychological safety is important. Burnout is a real issue that's rearing its ugly head everywhere. That's something that we want to make sure we get rid of as well. Creating transparency in the workplace can be difficult. It's a cultural thing, and cultural change takes a lot of effort from a lot of people. Right? The first thing, create open and public channels for communication. This needs to happen from the top down and the bottom up simultaneously. You have to have your IT leaders and your senior management creating an open channel for communication upward toward them, and you have to have your IT practitioners taking the opportunity to communicate to their IT leaders. Right? It has to be both directions. It has to be open and public as well. So having things like town halls, having kind of all hands meetings where it's not necessarily just somebody speaking out toward you, but a conversation that you have with the folks on your team. The next one is share your learnings and share your failures openly and honestly and without blame. Anybody here a software developer? All right. How many of you have blameless retrospectives after a sprint? That's exactly the point of a blameless retrospective, right? You're sharing your learnings, sharing your mistakes openly, honestly, and without blame. The without blame part is the important part because we don't want to single out any particular individual, right? If we made a mistake, it's a team mistake. If we made a mistake, it's an organizational mistake. What do we have to do to go fix it? And we focus on that instead of who actually made the mistake. Next thing, openly show and tell results. Anybody do show and tell days or show and tell times, something like that? Great. And you have to do that in a community setting as well. It can't just be confined to your team. You have to do it for the larger enterprise group. Right? Next, invite questions from the start of the hiring process. This is something that I don't hear from too many folks that they actually do. But it's something that's a great way when you have a new engineer who's interviewing for a position or somebody who's coming just out of college who's been force-fed this idea that this is how it works and this is how you do it. Don't ask questions because you're learning what we put in this textbook. They don't necessarily ask questions. They have to learn to do that. And if you openly accept questions right from the hiring process and even urge people to ask questions throughout the hiring process and also throughout their entire career, it adds more transparency overall. And of course, document and share your processes across all levels of the organization. So as you're improving your automation processes, or you're improving all of your IT technology work, share that success everywhere and share how you've done it. Give it to everyone else. Be open about it, because that's what's gotten us here today, right? We're here at an open source conference. Let's be open source with how we do things in order to make it better for everyone else. And with that, I thank everybody.
All right, thanks so much, Brad. And so let's see if we have any questions here in the audience. All right.
Yeah, go ahead.
When you're analyzing process and you're trying to figure out what's going on, because we went from being able to drop our own code to have a pipeline that's slowing everything down, but we can't get them to explain why that we have to do a different pipeline. How do you work with people to explain, they change it to a better process, but it's slowing everything down? How do you get them to explain why the better process is not working?
That's a great question. I would say if they're saying it's a better process and it's slowing things down, it's not actually a better process, right? And they probably haven't done the analysis by collecting data about the process, the metrics. What's the lead time? What's the execution time? How complete and accurate is it? Is there any rework going on? Are there steps of this process that we don't actually have to do? They probably didn't do that. They probably just said, hey, we're going to do it differently to try to be different, to try to improve, and it didn't work. And then they're not being open about making the mistake or the failure, so they can't inform themselves to go fix the problem again, right? So that's what I would say is it's probably just some confirmation bias for them. It's a better process that they've used, right? So they think that it's better, but it isn't necessarily. Any other questions? Yeah.
Yeah, just first a quick reminder, if you're online, watching online, or even if you're here, you can also ask questions on our Slack. You join the channel main stage, and you can post them there, and then we'll read them out. You would have gotten an invitation link with your confirmation when you registered. Here, if you're here in person, there's some QR codes on the wall you can sign up. So now for the actual question.
Thank you for your talk. First comment I want to make, surprisingly, this is the stuff I had when I got my MBA in 1998, 99, 2000. It sounds very familiar, only it's updated.
Yeah.
And a question of updating it, what have you seen the change to make the processes you had going from, 5 years ago, a lot of us worked together in the office. Now, I bet half the people here probably don't work in an office anymore. Yeah. How has that transition, for whatever the reason, I'm not going to worry about the reason, affected the process?
Oh, it's certainly affected the process. Working remotely is something that is very difficult for people who are used to going into an office every day, right? They almost have to force themselves to log in and do the work and be collaborative with their teammates. Let's be honest, a lot of us who work in technology are kind of loners, right? We're introverts to a large degree, so we don't naturally just put ourselves out there, right? I probably have an advantage over some because I do like to put myself out there, but I'm married to a wonderful woman who is an extreme introvert. She has to force herself to go do the thing. She works 100% remote. And if it wasn't for the value that she gets out of collaborating with her teammates, she probably wouldn't do it, right? So that's one of the things that we can highlight with our teams when we talk about improving a process or something like that. The value we're getting out of it is for everyone, right? And we're going to share it. That's the point of the transparency, the honesty, and the openness. We're going to share the value that we've gotten from everybody. So I don't think that the process improvement kind of methodology has changed much in a long, long time. But the way we do it definitely changed. And it's something that we're still learning about.
All right, any other questions here in the room? Doesn't look like it. I didn't see any questions online, so thank you very much, Brad.
Great. Thank you, everyone.
All right, folks, we're going to have about 10 minutes for setting up the next speaker, and then we're going to have a Syslog for fun and profit coming up. For those of you who are staying in the hotel and didn't block a room using a room block, we have a room commitment, and we have to pay for rooms if we don't meet that. So if you did book a room and didn't use our block, please do talk to either me, Vance, or Beth Lynn, someone at registration. That would help us a lot. And if you do want a room, we have, I want to say 4 rooms available left in our block. We'd be happy to accommodate that as well. Just talk to us about that. We'll get started again right at 11. Thank you. Hello, hello everyone. Welcome back to OLF. I'm Warner. I'm on the organizing team on the board here. Be sure to recognize the folks you see around in the yellow shirts with the staff ribbon. Folks busted their butts putting this program on for you, especially Sam over here. He got up early to set up the live stream and everything else. Excited for our next presentation here. Warren Myers, who has a background in data center management operations and has been working as a Splunk consultant for numerous years now, is going to be talking about Syslog for fun and potentially profit. I think this is a great presentation. He'll be diving into Syslog NG. We're just chatting about how relevant logging still is today. Does anyone here not log? Yeah, that'd be ridiculous, right? And if you're logging, you're probably looking for ways to improve it. And I'm sure Warren here will help us do that. And remember, if you're on the live stream and want to ask questions, or if you're in the audience and want to ask questions, join us on our Slack channel. Big hand for Warren.
All right, so everybody's favorite activity is logging, right? Creating, collecting, curating, controlling all of your device, OS, authentication, application logs. Top priority. It's a priority. Anybody find it fun? Good, there are no other weirdos in the audience. I actually think it's fun, which is why I'm talking about it, right? But logging is important. It's probably the most vital task that any team needs to think about after, actually shipping. Because shipping is a feature, right? I mean, if you never get it shipped, you never get it actually up and running, you don't have a product or a service. A little tiny bit of background about me. The lead architect for analytics and automation for Alchemy Global Networks, who was kind enough to let me come up here and pay for my hotel. Thank you, AGN. My fourth OLF, first as a speaker. Spent 6 years in professional services now around analytics and automation with log management, data architecture, et cetera. After about 10 years or so in data center management automation, really like Brad's talk, I'm in to go on automation. And got my start in Linux back in '96, probably along with a bunch of you, maybe not all of you, on a book that I found is actually still available on Amazon for $250 a copy, called Red Hat Linux Unleashed. It was the first book that Sam's published on Linux. So if you're interested, you can go find that. All right, so how do you manage your device and application logging today? This is actually an open question. Do you manage it today, or do you just kind of collect it and hope for the best? A lot of nods on the collect and hope for the best, right? So if you're collecting and hoping for the best, what kind of insights are you gathering? I'm going to go with probably not a lot. What kind of insights would you like to be able to find out from what you're collecting? Maybe application performance, uptime, network problems, drop packets, lots of stuff that shows up in various monitoring tools, right? Or for that matter, do you even know what kind of data is available? There's a lot out there, right? There's application data, there's system data, network data, IoT data, right? So I'm going to talk about Syslog a little bit. You've all seen it, I'm sure. It's a very old, very basic, very texty protocol. I do have a couple of sample messages. So these are actually readable. I grabbed these off my web server the other day. So it shows it's supposed to show up. Let me put that in quotes. The way Syslog is supposed to work, not all Syslog works this way. Some's degenerate. It's supposed to work with a timestamp, an actual message in the form of more or less key value pairs that you can read and get an idea of what the message is telling you. So SNG demo kernel, it sent a signal. Max frame size is 3632, right? Or SSHD error, banner line contains invalid characters, right? So some of these potentially more useful than others. I'll talk about some of the different ways that we can use this data in a minute. But this has been around since the 80s. Wikipedia has conflicting information on when exactly it originated and who wrote it. So I'm just going to go with it's old. But it is meant to be relatively human readable. I was out at Splunks.conf 23 in July, and Several talks that I went to, several people on the floor were talking about how syslog data and syslog-like data accounts for between 50 and 70% of all of the data on your network. It is actually log data. And all of the log data that they see, it's in the neighborhood of 2/3 of all the log data that Splunk and other SIMs, so there's Logarithm, there's Graylog, there's Microsoft Sentinel, there's a few others out there. All of those different SIMs and data event managers are getting about 2/3 of their data out of syslog or syslog-like data. It's generated by everything, like I said, from IoT to network devices, servers. Heck, even Apache logs look like syslog. And in fact, there's a really great blog post on Syslog NG's website on how to get Syslog NG to manage your Apache logs, if that's something you're interested in. It's in the links at the end of the presentation, which also goes out after the conference is over. Now, the relative level of readable and anyone understanding may be up for debate, but it really is meant to be fairly straightforward to read, fairly straightforward to follow. Excuse me. And because it's generated by everything, you can get some really interesting correlations out of it. So how do we collect syslog? Because you got to collect it, right? I mean, if all you're doing is generating this data, you don't have it anywhere, you're not going to be able to use it. You need a syslog collector. Should be obvious. There are several that exist. The main open source options are rsyslog, which stands for Rocket Fast System for Log Processing. It has commercial support available. Syslog NG, which ironically, Syslog Next Generation is older than rsyslog, but it's more widely used. I also like the configuration file format on it more, which is why I'm showing that off today. It also has a commercial option. Let me talk about the open source edition today. Graylog is another open source option. They're free for up to 5 gigs a day. Technically, they can't stop you from ingesting more than that, but you're supposed to pay for it if you go over 5 gigs a day. There are proprietary options. I mentioned Splunk. There's Kiwi, PRTG, and at least 30 more that I found in a quick search while putting this all together. But a note on Splunk especially, which is a commercial option. There's also like you can log syslog straight into Elk. So if you've ever used the Elasticsearch, Logstash, and Kibana stack, you can bring it straight in there. But most of the SIM providers, so Elk and Splunk, et cetera, actually recommend a formal syslog collection layer between everything that's generating it and themselves. Allow you to do some initial processing, some splitting off. Maybe you want some data going in one direction, some in the other. And so they recommend having a layer in between. And so like I said, today I'm going to show you a basic syslog NG collection, a simplified but with 2 options config file. And so we're going to look at that in a few minutes. Excuse me. But first, I got this straight off the syslog NG admin docs. We have the message path, and hopefully that's readable on the screen. Looks fairly readable to me. So applications, and these are anything from the kernel, daemon managers, individual applications, devices, so switches, firewalls, etc. They generate log messages. So everything generates log messages. Not all of it's read, but it's all generated. So they go to a collector, a listener on the local system, which then writes it out somewhere. Now, maybe it writes it out to disk. Maybe it writes it out to the network. That's what we're going to talk about today. You may want to filter out data that you don't want to keep. Maybe you don't care about debug data. Maybe you don't care about info data. There's 7 or 8 levels of data criticality that syslog supports. But there, once you've written it out, once you've filtered it, then you can send it on, right? So you can send it on to a network destination, which is really what allows you to do your correlations, your analysis, and figure out what's going on in your environment in a central point. And then I borrowed this. I did actually make sure that it's okay to borrow. I borrowed this diagram from Iris Networks. They're a company in the UK, and I have a link to this also at the end. So this is showing a slightly more advanced architecture, logical architecture. So every site having its own local collection of data that then forwards on to a central point. And with Syslog NG and other tools, these architecture is going to be basically the same for any of the options. Slightly different configurations, obviously. But Syslog NG allows you to tee your data into multiple places. So maybe you send some of it to your SIM for data analysis, security reporting, et cetera. Maybe you send some of it off to a local SAN or an S3 bucket for long-term storage. Because a lot of SIMs, if you use any of them, they get expensive fast. They're all usually based on daily data ingest. And storage space, storage is cheap, but it's also not that cheap, right? The storage you want on something that's doing live security reporting is going to be a lot more expensive than a long-term storage somewhere else. But this architecture is really where the value of Syslog comes in. So you've got everything generating it, but if it's all sitting out on individual endpoints, again, you can't use it yet. You can't figure out what's going on. But when you get it together, you can find some potential interesting discoveries. So one case that I had not long ago with a customer, they could SSH to several servers, and they could SSH out, but they could not get into the web control, the web UI for it, except for certain servers that were adjacent on the network. So, on the same subnet and a couple other subnets, which was weird. Local firewall was disabled. All the traffic was staying in-house, so edge firewalls were never getting engaged, all on the, the site network. Management was ready to nuke and pave and reimage the systems because obviously a configuration error was made, right? Can't get to everything, so there must be a configuration problem. Thoughts on what might be going on? I know I kind of just tossed that out there without a lot of warning. What? I like DNS. That was not at this case this time. I'll cut DNS out. They're only accessing by IP address. All right, MTU could be. So go down. We went down a lot of paths looking into what was going on. We actually checked DNS. They were all everything was communicating via IP. SSH works, which is weird. When HTTP and SSH worked everywhere. HTTP only works some places. So because we were gathering everything, started expanding out. Like, all right, do we see this IP address in any other logs? Right? So we've got, let's call it quad 10, okay? Got this system showing up just fine, never hitting the firewall. What we found out of TACAC syslog was there was an ACL applied to the switch, but it was not completed. So it was a test ACL, was sent out, a bunch of stuff was supposed to be permitted, a bunch of stuff was supposed to be denied, but at the end there was a final clause that was supposed to be put in of permit any, right? We're testing this, we're deploying it, but for now, don't actually turn on the ACL. Except permit any was missing. So we have traffic sort of moving, sort of not. Now, once we backed out, it took about an hour to find that, this IP address somewhere else. We went, back through like, all right, what port is this system connected to? Is there something wrong with the port? And I went through a lot of debug troubleshooting steps to get here. We backed out, found out the ACL is broken. Solution, reapply the ACL, comes out with permit IP any, traffic is good, all right? Remember, management was ready to just reimage the system. Problem, this takes about that particular system because of some really weird things it's doing, running on a really old OS. I was running on OpenVMS, which I didn't know still existed until I was there. Took about 3 days because first they had to get someone who was actually capable to do the imaging. Then they had to get media to reimage from. The application backups, restore from there without restoring all the configurations. They only want to restore some of them. But it was not a system problem. So reimaging, let's say you do this, you take 3-4 days to get this done. once you get it approved, right? It's still not going to work because it was actually a network problem, but it was an intermittent network problem. Because we were collecting all these different logs from all these different sources, we could do that correlation, all of it, and it was all coming into Syslog NG as a collector, and then getting sent on to our SIM. So we did our searching up in our SIM. But, getting those things in allowed us to find this problem in the order of a couple hours versus a 3-day solution that wasn't even going to work. Now, we didn't know it wasn't going to work yet, right? But it wouldn't have worked. So, sizing. This is, sizing anything is a lot of, well, it depends. Everybody's favorite phrase in IT, right? How do you do that? Depends. So, Syslog NG will run on FreeBSD. I've never done it. So, and this is the Ohio Linux Fest, so I'm going to talk about running it on Linux. You need enough storage, CPU, and RAM to handle a plausible data buffer between reception and what you're going to do with it. Whether you're analyzing it locally because you love grep, and who doesn't, right? Or you want to send it on to Elk or Logarithm or whatever other tool you like to use. It's a little more user-friendly. I suggest a minimum of half a terabyte of storage. I'm going to tell you why in just a second. A terabyte is better. You need network connections to all your source subnets. It is astonishing how often this is forgotten. People will drop one NIC on something, whether it's a physical server or a virtual server, and then wonder why they can't get to it because they have firewall rules. You also need network connections to your destination subnets if you're sending this on to one or more log analysis tools. And again, I like to have at least 2 NICs on a system because one for inbound, one for outbound, keeps the traffic separated, and allows you to potentially saturate your NICs. And installing multiple identically configured collectors in a single site, you don't actually need big servers to do this. I'm sure Dell and IBM and ThinkMate will be happy to sell you a $100,000 server if you want it. They won't turn you down. See some nods in the audience. But you can actually get away with something fairly small. Syslog NG and our Syslog both say that you need enough CPU. But you also don't need a lot, and that's actually the word they use. They use you do not need a lot. It's real descriptive. Average Syslog message size hovers around 200 to 600 bytes. I like rounding, so I'm gonna round that to 1K. We're gonna do a little math. You all thought you were out of school. You're doing math this morning. At 1K on a 1 gigabit NIC that's fully saturated, very uncommon. But if it's fully saturated, you can handle 100,000 events per second. For your 100 megabytes, divide by 1K. If you're on the lower end of the size spectrum, it's about 500,000 events per second, which again is a lot. Even coming off of several thousand endpoints, you probably are not going to see that. Off my web server, which admittedly is a low traffic web server, I only average about 6 megs of logs a day across everything. So you probably are not going to saturate this network connection. Syslog NG thinks that this is possible, even if you're doing some modest event filtering on more or less any modern quad to octa-core system with 48 gigs of RAM, and vital gigi or higher networking. So you can deploy this out on your favorite cloud provider for like $40 a month, somewhere in that ballpark. And you can handle more events per second over UDP than over TCP, but Syslog NG does recommend collecting over TCP so that you are less likely to have dropped events. Dropped events can still happen, but they're less likely. There's also an interesting note in the Syslog NG documentation that I ran across that there is an internally hard-coded limit of 64 threads that it will run at once. It will not run more. So if you give it your brand new $100,000 system with 128 hyper-threaded cores, ThinkMate will sell it to you. Literally 3/4 of that CPU is not going to be used at all. It will not go past 64. So, excuse me, like I said, this is not an expensive proposition. And if you're load balancing multiple systems into individual site clusters, you can get away with each of them being a little bit smaller because they do actually aggregate up to an equivalent large system. You can most places, I'm not going to say everybody, but most places can afford to throw a couple VMs out in each data center or each cloud provider, throw, if you're using some stuff in different availability zones in Amazon or Google or wherever else you like to run, you can throw a couple smaller collectors up that will handle everything on a load balance basis. We're not going to tempt the demo gods today because I actually had this fail last night on me. So we're not going to tempt them into a live demo. Plus, it's not that interesting to watch someone install Syslog NG. I'm going to jump ahead a slide. These are the steps I'm not going to show you, except that they're on the screen. Get their repository or their key, echo their repository into your config file, do an apt update, apt install. Ta-da! That's not very interesting. No one needs to watch that. So I pre-staged this for speed. But I do have a live syslog collector running. It's collecting off of 2 or 3 systems up in the Hetzner cloud right now, which I'm going to show off in a minute. So, and they're very tiny, right? I mean, they're like the minimum sized Hetzner VMs because I'm cheap. Jumping back ahead here. So one other thing, this is kind of a career life pro tip that I was given about 12, 15 years ago. Never customize anything. Okay? Configure whatever you want, but you never set up a custom syslog collection. You set up a site configured syslog collection. And the word is important because if it's custom, you are tied to it forever. And the last thing most of us want to be is tied to managing some config files the rest of our lives. Maybe some of you like that. I am not like that. But if it's configured, you can document it. It's documented. You can hand it off. You can go do something else. Maybe you can come back and edit it later yourself. But like I said, you don't want to be tied to it forever. You want to be able to hand this off to somebody else. The other reason I did not show you these steps is 99% of log collection is not installation and configuration. It's what you do with it afterwards. Syslog NG and rsyslog are both very modular in their config file arrangement. They'll go into a standard config directory, and then from there, every one of them gets read in at startup or restart time or reload time. Syslog NG, I haven't actually checked rsyslog, but Syslog NG does have a caveat in their configuration files. They are handled chronologically. So have any of you ever used Brockmeier back in the day for mail filtering? Way back. All right, yeah. 3 hands up. Cool. Me too. So like Brockmeier, like a lot of config files, not all, but a lot of config file-based tools, as soon as it finds a rule that fits, it uses it. So if you put a less restrictive rule at the top and a more restrictive rule at the bottom, it falls in the less restrictive rule. If you've ever done any coding or scripting, which I'm sure probably everybody in the room has, maybe minus the baby in the back. Everybody in the room has probably done this. You've written, if conditions. You've written else statement, case else statements, or case switch statements. Sorry. And you want your catch-all at the end. Like, all right, do this, do this, do this. I don't know what just happened. Dump it over here. You do that first. Nothing else fires, and then you sit there and you wonder for hours on end. Not that this has ever happened to me, but I've heard from a reliable source. You can spend hours running your head into a brick wall, wondering why this doesn't work. Right, okay. So the other reason to put these, have the smallest config file you can, which does not mean every config file is small. It's as small as possible. The one I'm going to show you on screen and then the results of it here over in a command window in a second. It's only about 15 lines long. You can have very long config files as long as it all goes together. But don't put all of your Linux logging with all of your switch logging, with all of your firewall logging, with all of your application logging. Don't do that in one config file. Can you? Yes. Don't do it. Be nice to whoever needs to look at this in a week or a month or a year, because it may be you, and you are not going to remember. There are times I don't remember in the afternoon what I did in the morning. That's a personal problem. But you're not going to remember in a year what you did today. You're going to look at it and go, what doofus wrote this? And you're like, oh, edit history, me. Oops. I was the doofus. Plus, you may want to have some log files going in one direction, some going in another. So it never hurts to have more config files, especially with source control tools like, what are the cool kids use today? Git, Bitbucket, SVN. It feels like every customer I go to uses something different. I don't know what y'all use. But be nice to yourself. This is probably, I don't know how readable that is. I will show you on screen also. Let me pop out of the presentation for a minute. And is that a little bit more readable? No, maybe. What in the? Those are neat error messages showing up in the middle of Emacs. This is why we don't tempt the demo gods. Let me change the color on that too, because I'm really realizing now that that's not readable. Is that better? Okay. Sorry about the colors. Okay, so Syslog NG does have a kind of a rule for how to put things together. So they have templates, sources, destinations, filters, and logs. It's more than just that, but that's the bare minimum to get this running. The template will force Syslog NG to reformat what it gets into something that resembles a standard format. Do this. You will thank yourself later. And all these are documented as to what the individual key commands are here. But ISO date, put it in a standard date format. Doesn't matter what date format you pick, just use one. Please don't be like some products I've used in the past that have 14 different log file formats. 16 by the time I got out of the product. Dump the host in there. You're going to want to be able to look this up later, and then whatever the host sent as a message. You have multiple listening ports. I like to do this as a way of filtering incoming data. So I know that everything that's on port 514 is a network because N is the 14th letter of the alphabet. Or everything that's on 12514 is Linux, again, L12. You don't have to do that. You can listen to everything on UDP 514. You can listen to everything on one TCP port, but it gets a lot more complicated, and ports are free, right? I mean, you've got 65,000 of them to work with. Use some ports. The kernel is not going to complain. And here you notice I have this split up between production data and dev data just for this demo. So I've got a destination, which is going to store Syslog Linux, and then these all caps words here, those are keywords that are in the config file format for Syslog NG. So Syslog calls a facility the type of thing that sent the message. So like kernel is a facility. I don't know why they picked this. It's 40 years ago, but they did. Then you have a priority, so you have critical, info, debug, warn, etc. The host, and then by using that $R_day, you can actually have Syslog NG automatically roll your logs for you. You don't need to write a log rotate config to match this, which is good because it's less to manage. And you don't have to split it up this way. I'm just, like I said, I did this for a demo. Then we have our filters. So filter in that top one, I only want warning through emergency to go to production. And then down below, you're going to see I have debug through notice going to dev. Okay? So, and it's just a different, in this case, the difference in the path is just, syslog versus dev. But then for the actual log statement, And this is a minimum log statement. The source, so what port am I listening on, any filtering that I'm doing, and where is it going in a destination. That's it. You can get a lot more in here. Syslog NG supports much more complicated logic, if-then-else logic. It supports sending this on itself to anything that speaks REST. So if you want to have, you can have Syslog NG reformat a Syslog message into key value paired JSON if you prefer to use that. Some people like JSON. I like text, but some people like JSON, or you may want to ingest this into a tool that prefers JSON because it'll automatically extract your fields for you, maybe if you do searching like Splunk. So, all right, back to this because I really don't know why it's telling me that something's trying to SSH. All right. Okay. But now that you have Syslog NG running as a collector, you need to send it data. Okay. It's listening on ports. Woo! Right. It's not very interesting until data goes over there. Now, our Syslog tends to exist on more systems out of the box. And I think it's because our Syslog is 100% open source, whereas Syslog NG sort of falls into the almost open core model. And I'm not going to get into the religious wars, but it is more open core than open source. The open source edition is slightly different from the professional edition. But at the end of your rsyslog config on a default server, and I just added this bottom line on mine. We want to send everything to TC port 5514. Add one line. Restart rsyslog on your server, and it's all going there. So, what this looks like in practice. I did install tree because I like tree. Okay. So this is how this is broken down. So, and you probably would not actually do it the way I did. This is just, again, for a demo. So I've got dev data. I've got 3 days. This server's only been up apparently since the 6th. I've got dev data broken out based on auth priv, cron, daemon, kernel, okay, and then broken down into the levels and then the host. You can just as easily do this the other way around where you have host at a higher level and then break it out. You can break it out any way you want to. This just trees out nicely. And then over here, you'll notice that when I get into let's go back. So this is all the dev, okay? Those are all the debug, info and notice. And then over here, this is a differently formatted one that I've got coming in for ARM-based data. Okay, so these are the higher level messages. Okay, so these are coming in, and again, you can break this out any way you want to, but breaking it out lets you get a hold on what you're looking at, so that you have a way of also knowing, did I misconfigure something? Because firewalls don't send the same data as servers. So being able to look at this on the file system or in your log analysis tool, you're going to be able to see really quickly, oh, I have a misconfiguration on an endpoint or a network device. Go fix that and have it pop up where you actually want it to be. And then this tab, this is one of the servers that I set up to forward. Please connect, there we go, all right. So, and then this is all I added to it does help if you can spell. So this one line at the very end, highlight that there, it's a little bit easier. Let me zoom that in also. Okay. One line, and it's going over to my server listening on 1514. So you can break this out differently if you want to. So I'm going to go back to the slide deck for a minute. You can break this out so that some stuff is going to UDP if it's not as vital, or some stuff is going on TCP. You can have it all go on UDP if you prefer. Again, I like TCP more. So, but because of how easy this is to set up on endpoints, especially Linux endpoints, this also means that your OS image master that you're using in your automation tool, because we're all automating our deployments, right? Whether it's Kickstart, AutoYest, et cetera, VM templates, have this pre-configured. So as soon as you bring up a new server, all the logs are going where you want them to be. Questions? There's a question in the back. All right, so the question is, how do you account for time zone differences between your sources? That's why I use ISO-date. So ISO-date is going to come out in UTC, or it will include the time zone. All of your servers should be in UTC. That is the one religious stand I will take on servers, because you can adjust. And timestamps are better as Unix epoch time because you can format it. I won't be quite as dogmatic on that one, but you need to have the time zone encoded in there somewhere. So whether it's everything is UTC or everything is Australian Eastern Time, because there is such a thing, that it's also EST, which is a little confusing. Central European Time, doesn't matter what you pick, right? Just pick one. Or make sure that if you have more than one, please don't have more than one, but if you have more than one, embed the time zone as either a UTC offset or the appropriate abbreviation.
All right, we have the microphone now, so folks can hear us on the internet. Testing. There we go.
Does this system have how much or how little you can log?
Sure. So by how much or how little, well, let me qualify the short. It depends, right? So you can filter out any level that you don't want to hold on to. So if you don't care about debug messages, don't keep them. So that's what. So the filter. That's the filter statement. Let me go back a couple slides here. Well, it's a little hard to read, but that's what the filter statement is doing. So, we only want info up or notice up, or we only care about errors. We are really confident in our environment. We don't have any warnings. Yes. All right. Cool. Got a chuckle. So you can hold on to all of it. You can throw some of it away. If you're using a tool for log analysis that's based on data ingest, so Splunk, that's my bread and butter. It's a commercial tool. Not selling it. I'll sell it to you, but that's not why I'm here. It's based on data ingest. Debug is super, super wordy, right? Very verbose logging. You don't want to be ingesting debug off of everything. That's going to blow your license on any tool out of the water, or it's going to slow it to a crawl. But you can have it just dropped right there by Syslog NG, or only collected on from certain IP ranges. So maybe your dev networks is all done on 10/2020 or 10/20/255, right? So everything out there is dev. We need everything from that subnet, but we're only going to get a maximum of like 254 devices. We can handle that, right? But we don't want it from everywhere, because there are people, not speaking from personal experience, but there are people who turn on debug logging and forget to turn it off. I've heard. You don't want to get that from everywhere. So yeah, you can filter that here. You can also filter, so you can have multiple destinations based on different filters. So maybe you want to send all your debug stuff off, like I was saying earlier. Maybe you want all of that to go to an S3 bucket. Well, since Syslog NG speaks REST, you can send it over there. You can have it pre-formatted into JSON or whatever you're going to ingest later, and then only go look at it if you care. And then keep the more critical stuff around. You start to see something weird in your warnings. Like, oh, I'm getting a lot of warnings from this switch, that started on Monday. Let me go find the S3 bucket from Friday and ingest Friday, Saturday, Sunday, and Monday, and see what else am I seeing about the switch, right? Or about everything that's connected to it. So you also don't have to get everything in. So you can do, it does add some manual intervention, but that manual intervention is also like based on alerts or reporting, so you're not You know, you're not just bringing it all in and then throwing most of it away. Does that answer your question? Okay.
And just a reminder, folks, if you registered, you have an invitation to Slack. And if you're remote, I've been checking the main stage channel for any questions. So don't be shy about that. I'll get you next, Mike. This gentleman had his hand up before. And if you would, share your name and then your question.
My name is Josh, and for clarifications, I'm a Red Hat customer, but I'm curious because Syslog NG has been around for a very long time. Does it interact with the journal CTL log at all?
There is a way of getting it to talk, to get Syslog NG to talk to journal D. I ran out of space to do that here, but they can talk to each other. Yeah, Syslog NG dates to 1998, so it is long in the tooth. But they keep making improvements to it, so.
All right, name and question.
Hello, my name is Mike. So how do you cope with the lack of facilities? Because we have like all of our applications, but we can only use user 1, user 2. Like, how do you deal with not being able to have custom facilities and be able to organize your logging?
Oh, so like, you know, so if you have like overlapping IP space, or
No, applications. Like you have lots of applications, and you want to do syslogging for your applications.
right?
But you can use like user 1 for all of them.
Okay, well, they're still going to be coming in on a given host IP, so you can grab that out. I've got a link to the list of different format variables that Syslog NG supports. One of them, I think, is application name. Please don't quote me on that because I probably just misspoke. But yeah, you can break that out now on, like if you have system accounts that are running things, yeah, you're going to have something pop up as user 1 or www data, right? Like that's going to do a lot of stuff. But system accounts are great, except when they're not. But yeah, like anything that's going to have a username attached to it that shows up in the log file, that's still going to be there. Some of that can be automatically pulled out. Some of it may have to be post-processed. There is some scripting you can do with Syslog NG also. I haven't personally done it, so I can't speak to how detailed you can get with there. But you can do some scripting on top of what's coming in beyond just the filters out of the box. Does that answer your question?
Little known secret, Mike was one of the founders of OLF many years ago. Did you folks know OLF is now old enough to drink? We've been doing this thing 21 years. Name and question, sir.
Hey, so my name's Leland. Do you have any good rules of thumb on retention for the logs you collect?
So on the Syslog NG collectors, so I will speak from, I'm going to switch into my, not sales mode, but professional mode. Logs should not be held on Syslog NG longer than they have to. And that's why I was talking about like a plausible buffer. Half a terabyte on a saturated gig NIC is 80 minutes. A terabyte is just under 2.5 hours. Because it's 5,000 seconds on a saturated NIC for half a terabyte. That's a really long time. If you are then taking data off somewhere else to your log analytics platform or for long-term storage, because like that buffer needs to overcome any network delay that you might plausibly have. Now, can you put 100 terabytes of SSD on there? Sure. Dell will be happy to sell it to you. They'll be happy to take most of your money doing it. So like they're on the sizing front. I don't like to keep stuff around on the Syslog NG server more than about maybe half a collection period behind. So if I am typically collecting everything off within half an hour, I don't care about more than 45 minutes, probably. Now, there's some expectations that go along with that, and site architecture, network problems you have, your relative comfort level. Whether you're using SSDs or spinning Rust will factor into that a little bit. You do need you need more disks if they're if they're measured in RPMs. They need to be set up in a RAID. There's some more stuff that goes into that, for individual sizing. But in general, my rule of thumb is if you need more than 3 hours of buffer, you probably have other problems. Or you're doing all of your analysis on the Syslog NG host, which you can do if you want. But I like separating, because especially since like VMs are cheap. Heck, even servers are cheap compared to admin time. A $2,500 server, a pair of $2,500 servers is, say, a month's salary for a junior IT engineer. So the overhead on that versus the overhead on personnel, like spend a little bit on hardware to save your people time. But that's my normal rule of thumb on this layer. Now what you need to do after that, that's going to come down to compliance rules. So if you're subject to any industry regulations, government contractor, you got the alphabet soup of compliance rules out there. There's a lot of them. But that's typically after this layer. That's on your analytics layer usually. And also why you can tee off data to something cheap like S3 or B2 or your preferred cloud provider and hold on to it forever, because you need to hold on to data for a year. You're probably not running analytics on it for more than a couple weeks. That's just rule of thumb. 90% of your analytics happens in 14 days. 95% is in a month. 99% is 6 months. Like, holding on to stuff past a year, you can do it, but send it somewhere cheap and slow and grab it if you need it.
I'd like to challenge the folks on the internet to ask a question in main stage. I believe in you. I know you're watching. I know you're engaged. Participate. Name and question, sir.
Hi, my name is Benjamin. Do you have a high-level strategy for when you need to migrate the collector host to another host, whether you're upgrading or whatever? Because obviously the logs are still being produced.
Yes.
In the meantime.
So a general migration strategy, and this is why, back up. Bottom item here, put a load balancer in front of them. So a load balancer with a virtual IP, point everything at the load balancer and have it decide where it actually goes. That's the easiest way to handle migration, because if you take one down, you're using, say, HA proxy or your cloud load balancer from DigitalOcean or whoever else, that's going to, you just remove one from the pool, it will stop sending data there. Make sure everything's been collected off, then decommission, do maintenance, et cetera. So it is another component in the architecture, but back to hardware is cheap next to people. It actually doesn't have to be a very beefy machine to handle a lot of data, because all it's doing is basically a pass-through.
All right, we have Michael on the internet. Thanks for stepping up to the plate. Michael's question, and I'm just going to read it out loud verbatim, may be out of scope for this, but do you have a recommendation for a best practice log retention duration? I hear a lot of mixed opinions on the subject.
So technically it's out of scope, but I'll take it. We got 90 seconds left. I'll just talk fast. So most data, and I sort of answer this for Leland in the back, most data you do not need after 30 days. Unless you have a compliance requirement, throw it out. Because the longer you hold on to data, the longer you're liable for it. So that's the other thing, right? Like, if there is let's say you're a company, you have a data breach and you find out about it 6 months later. Yes, it's really nice to have the data from when it happened. Happened with Equifax a few years ago, right? And it happens periodically. Home Depot had one, Target's had them, right? There's high-profile data breaches. You want to have the data surrounding that, but that can go off to your cheap long-term storage. But I personally like to throw away everything I don't need digitally, not in the real world. But digitally, I like to throw away everything I don't need as soon as I have no logical reason to hold on to it. So 30 days is a good rule of thumb, maybe 90 if you're a less mature organization or a more conservative organization. I don't mean that politically, just, you know, you like taking decisions slower. Or if you're brand new to all of this and you're still trying to figure everything out, 90 days is probably the second rule of thumb. But most of the customers that I've worked with on log retention, they're throwing stuff out. They've got like 3 tiers. They've got, or 4 tiers. They've got 15 days for stuff in the cloud because they're rebuilding servers every week. Who needs it after 15 days? The server's gone. 30 days, 90, and then a year for financial stuff.
Big hand for Warren.
Thank you.
Not to be contrary, putting my CISO hat on, I think Warren's perspective's great. I like a year, unless there's a technical or financial reason not to. But that's the security perspective. Well, we have a 10-minute break, and then we're going into lunch. For those who have a ribbon on your badge because you've participated or contributed financially, we're going to have lunch. And thank you for that. And without your contributions, we would not be able to host the event. A significant portion of our budget this year is covered by those who paid to be here. So thank you. Lunch is going to be next door. If you are one of those people, we will start on time at 12 p.m. If you did not pay for lunch, we have numerous great options in the city. North Market's across the street. It's well regarded. Oh, shoot, I could ramble. If you have any particular preferences, I have numerous recommendations, and happy to provide them. See you again soon. Hello. Hello, everyone. Welcome back from lunch. Are you ready to take a nap? Well, that's good, because we wouldn't want to sleep through this awesome presentation coming up right now. I will remind everyone that on Slack, which you have an invitation to if you registered for the event, you have not only opportunities to congregate and stay in touch with your fellow conference attendees, you also have the ability to ask questions. And that's especially important for our virtual friends. Engage. If you have questions later, ask them in the main stage channel, and I'll be sure to keep an eye on that. Hi, I'm Warner. I'm on the organizing team here at OLF. Be sure to thank the organizers who put this together. The folks here put a ton of energy into making this happen over the past year, meeting weekly on a Sunday night. Who likes Sunday night meetings? Well, the folks who put this together for you, so be sure to thank them. One thing, if any of you booked a hotel room and you didn't use our booking link on the website, it wasn't associated with us. So please speak up, let us know if you're staying in the hotel and you didn't use our booking link, or if you need a hotel room, please let us know. We still have some of the discounted rooms available in the block. This is super important for us because if these rooms aren't accounted for, we have to pay for them. We have 4 rooms left we need to fill. So please talk to me, Beth Lynn in the back, or someone at registration if you have a room that you didn't book through the OLF website, and we'll get that sorted on your behalf. Now, we're going to get our presentation started. Ken here, a recent graduate of computer science at Otterbein University here in Columbus Metro. He's working as a system administrator at Hexion, a chemical company here in Columbus. Ken is going to be taking us through a journey on the history of computing. He's going to be starting from very early phases of computing. Super excited to see what Ken has to share with us. Big hand for Ken.
Well, welcome everyone, and thanks for coming to a talk about the fascinating history of computing. My name is Ken Elliott, and I am a computer scientist. I am a communications specialist, a businessman, and a history buff. This is my 4th time at the Ohio Linux Fest. This is my 2nd time presenting. My first time presenting was in 2018 on the history of Linux, and I'll go into a little bit of that history in this talk as well. One of the highlights of my tech career was delivering that first Ohio Linux Fest talk back in 2018, where I had the privilege to share the captivating history of Linux with an enthusiastic audience. The experience of imparting knowledge and sharing my passion with others was truly fulfilling, igniting a desire to continue contributing to the tech community. Computer science and the history of computing have been my lifelong passions, driving me to explore this fascinating field extensively. My formal education in computer science and communication has provided me with a solid academic foundation to delve deeper into this ever-evolving realm. As I continue on my journey in the world of computer science, my mission is to continue expanding my knowledge, honing my programming skills, and fostering a community where everyone can explore and benefit from the wonders of technology. I firmly believe that by sharing our knowledge and passion, we can collectively propel the field of computing forward and make a positive impact on the world. This talk dives into the remarkable advancements and significant contributions that have shaped the world of computing as we know it today. This presentation will be augmented or enhanced by many short video clips. The talk will be presented in chronological order. If I skip over a notable contribution, I do apologize, as there have been many contributions to this great field we call computing. Also, if I am mistaken about a particular fact or idea, please feel free to raise your hand and set the record straight. I've done my best to be as accurate as possible. If you have questions at the end, you may raise your hand and we will collectively do our best to answer them. So we will witness how computing has evolved from its ancient origins to the modern digital landscape, shaping the world in unprecedented ways. And before I begin, I would like to shout out a few people. I got my fearless leader boss over here, Matt Pritchard, if you wouldn't mind standing. Thank you, thank you. And then my mother as well, Paula Elliott. Okay. And back to the talk. So why should we study the history of computing? Like, what are some benefits? Anyone?
To learn from any mistakes that have been made in the past in computing.
That's a great reason. Anyone else? Sure. What's that? Yes, yes, yes. Mm-hmm.
Because history is awesome.
History is awesome, sometimes. So yes, my reasons are it gives us context on how computers came to be and how they evolved, and will help us understand possibly where they're headed. It also gives us an opportunity to celebrate the perseverance and brilliance of the minds that have fueled the remarkable history of this great space. And let me get some multimedia going. All right, we will start this talk with a remarkable device now called the Antikythera mechanism. The name of this instrument comes from the Greek island Antikythera, where the device was discovered in 1901. The artifact was pulled from a shipwreck and dates back to around 100 BCE. It is believed to have been used to calculate astronomical positions and maybe even to aid in the tracking of the seasons. Let me play you a clip.
First looked at the results, it was astonishing. We've had to rethink the history of technology completely as a result of this single object. It's such a clever, extraordinary, sophisticated machine. Completely shocking for ancient Greece.
"120 years ago, sponge divers discovered a shipwreck off the tiny island of Antikythera in Greece. And what they found changed our understanding of human history forever. Among the treasure trove were marble statues, elegant vases, glistening jewelry and ancient coins, and what looked to be a hunk of corroded metal that no one knew quite what to do with.
It was not recognized at all as being anything interesting when it was discovered. It was just a corroded lump about the size of a large dictionary.
But when, in 1902, it was discovered that there were gear wheels inside it, everyone suddenly got rather excited.
This was the first shock because anything from ancient Greece simply shouldn't have gear wheels. These were precision gears with teeth about 1 millimeter long. And this was just completely shocking.
And the Antikythera mechanism has captured the imagination of archaeologists, mathematicians, and scientists ever since.
It's a dedicated calculating machine, and it uses bronze gear wheels to calculate the cycles of the cosmos being the sun, the moon, and the planets against the stars. You can wind it forward 10 years, and you can know where the sun and the moon is going to be and where the planets are going to be.
The question of why the ancient Greeks created such a device has plagued experts since its discovery.
I think it was conceived as a calculating machine that would calculate the theories they had. They had astronomical theories, but could calculate those at the turn of a handle. So it would demonstrate how you could look ahead, say, what's the position of the moon going to be in 5 years' time? You could turn the handle. they'll tell you almost immediately. This is a massive step forward in the history of science and technology. Something we take for granted now, but in those days, that the idea that your scientific theories could be mechanized, the predictions could be mechanized, was absolutely astonishing.
Now kept in a museum in Greece, the 2,000-year-old device is split into 82 fragments, and much of it is missing. But in the years since this discovery, modern technology has vastly advanced what we know about the mechanism. In the 1970s, a team X-rayed the device, and the first secrets were revealed. Dozens of cogs hidden within it. But it wasn't until 3D X-ray technology came along that they could separate these gears out.
We took an 8-ton X-ray machine to Athens, installed it in the museum, and we took X-ray data of all the 82 surviving fragments of the mechanism. And when we first looked at the results, it was astonishing because it showed us not only all the gear wheels in 3 dimensions so we could separate them, but it showed us all these new inscriptions in the fragments as well.
A new world of secrets was revealed. A user guide, hidden within the folds of corroded bronze.
This was a wonderful revelation. Out of that data has come nearly all the breakthroughs in recent decades. Came the discovery that it predicted eclipses, that it followed the variable motion of the moon.
Previous experts had been able to model the back of the mechanism up until this point, but these inscriptions helped Tony and his colleagues with their latest model, which focuses on the front of the device.
There's thousands of text characters in ancient Greek which tell us how it worked. It displayed the ancient Greek cosmos, the sun, moon, and planets, in a sort of ring system. It brought back the history of technology to a much earlier time. It is completely astonishing that the ancient Greeks firstly had the conception of making this technology, and secondly, the ability to actually physically make it. We've had to rethink the history of technology completely as a result of this single object. The great Arthur C. Clarke said, if the ancient Greeks had understood the capabilities of the technology they created, then they would have reached the moon within 300 years, and we'd now be exploring the nearest stars.
Now, Tony and his team will take their theoretical model and use ancient Greek techniques to build a physical model of the mechanism. And modern technology may reveal more secrets of the ancient world still.
There were certainly in the ancient world more devices like the Antikythera mechanism. It wasn't unique. I think the only real hope of finding another machine like the Antikythera mechanism is from a shipwreck. The hopeful thing is there are thousands of shipwrecks down there under the Mediterranean, some of them at very deep levels, but the diving technology is advancing so much that it's becoming possible to explore quite deep wrecks. To understand the technological world we live in today, we need to understand its history. What the Antikythera mechanism tells us is that that history is different than what we thought, that it started earlier, that it's developed in this incredible flourishing of this sophisticated technology, and then it seemed to go backwards. We kind of take it for granted, I think, in the modern world that technology will just keep on advancing. But throughout history, this hasn't always been the case. The history of technological development doesn't go in a straight line. It develops in fits and starts and sometimes gets lost and forgotten.
So the Antikythera mechanism is an incredible analog computing device that has changed our understanding of the history of computers. In order to talk more about the history of computing, we should examine and highlight the people who made computing and modern computers possible. The fascinating individuals who helped usher in modern computing should be celebrated for their achievements and innovative thinking. This here is a picture of Charles Babbage. And we will first remark on him. He was an 18th century mathematician, and he was an eccentric genius. Babbage was born in England in 1791 during the Industrial Revolution. Babbage is considered today as a Da Vinci man, which is a man that has lots of great ideas. He was well educated in mathematics and science, and his most notable contributions were the difference engine and the analytical engine. This is a picture of the difference engine. And the difference engine is an automatic mechanical calculator designed to tabulate polynomial functions such as quadratic equations, which can be used to calculate the areas of enclosed space, the speed of an object, and many other things. So functions like this is what it could calculate. Before he completed the difference engine, he dreamed up of an even more ambitious device, which is called the analytical engine, which he proposed would be a more advanced, steam-powered, general-purpose computer that would use punch cards for input and output. The analytical engine was never built, but many aspects of its design were recorded in immaculate detail in Babbage's drawings and mechanical notation. Although the difference engine was partially built, he never got to see either device fully realized or created.
Charles Babbage was the only child of a tyrannical London banker, a bully at home. But his money kept his son and heir financially comfortable for life. Cambridge educated in mathematics and supremely self-possessed, Charles became an iconoclastic writer and habitual inventor. In 1832, the drawing room of his London home became a showcase for demonstrations of a small section of his difference engine, a far from finished device by which he intended to revolutionize calculation by mechanizing it. At his soirees, London's intellectual society watched what you see now. As Babbage cranked its handle, this machine produced a series of polynomial calculations that were repeatable and error-free. Most astonishing, it was automatic. Any of his illustrious guests might have operated the handle as well as Charles Babbage, perhaps the geologist Charles Lyell, or Charles Darwin, or Charles Dickens. Once set, the machine seemed able to proceed, to think on its own. But what was called the beautiful fragment of the machine Babbage had intended to build was all he ever finished of it. In fact, his imagination had already moved on to an even more ambitious mechanism, one that would make obsolete the abandoned machine. The analytical engine would be a general-purpose calculating automaton. For most of 30 years, he would revise and improve his notional design. Only a few partial sections of it were built, this one after Babbage's death by his son. The analytical engine was an ever-evolving machine. Each breakthrough elegantly drawn up, annotated to describe mechanical motions with a coding system that Babbage claimed was his finest invention. The analytical engine may be the most intricate operating mechanism ever fully realized with paper and imagination alone. In 1846, Babbage abruptly changed course. As if determined to make good on an old obligation, he worked for 2 years to complete a full set of drawings for difference engine number 2. It would require 8,000 parts, only a third as many as the first. He offered it to the government, but did not protest when it declined to build it, and the drawings were carefully put away. Eventually, they came from the Babbage estate to rest in the library of the Science Museum in London. More than 130 years later, in 1985, the museum's new curator of computing, Doran Swade, became convinced the institution could build difference engine number 2. After all, with the intact drawings, it seemed feasible and within financial reach. It took 17 years, and drama to rival Babbage's so long ago. And it works, just as Babbage designed it. Every turn of the engine's driving handle is carried through gears, cams, rods, levers, and springs to release and arrest precisely aligned number wheels. A helical arrangement of steel fingers continually pulls the register towers to find and perform the carrying of tens. In its continuing sweep upward, it is mesmerizing. The intricate printing section can be programmed for 1, 2, or 3 column output, for 2 font sizes at once, for variable margins and column gaps, even word wrap where necessary. It prints hard copy on paper and simultaneously impresses the same output into a tray of plaster to produce a stereotype, a mold for casting a full-page printing plate. When a tray is full, the printer pauses the entire machine. In the spring of 2008, a clone of DE2 commissioned by Nathan Myhrvold was completed at the Science Museum and shipped to California. At the Computer History Museum, it would charm new thousands of discerning eyes. Today, the crotchety proud genius, who never managed to prove it during his lifetime, has a fair claim to honor as a pioneer in the history of intelligent machines, just as his parlor guests in 1832 suggested. His difference engine continues to inspire the admiration of his intellectual heirs, a celebrated and unique icon to chroniclers of computing. Charles Babbage, remember, never saw it, except in his stubborn, prescient dreams.
You can't really mention Babbage without speaking about Ada Lovelace. Lovelace was the only legitimate child of the famous poet Lord Byron. Ada was well educated in mathematics and was decades younger than Babbage, but she was inspired by the prototype of the difference engine that we just saw and became Babbage's lifelong friend. Ada created notes on Babbage's proposed analytical engine, and in her notes, some argue she created the first computer algorithms. Some people claim that she is the world's first computer programmer.
Augustus Ada King, Countess of Lovelace, was an English mathematician and writer, chiefly known for her work on Charles Babbage's proposed mechanical general-purpose computer, the analytical engine. She was the first person to recognize that the machine could be applied to tasks beyond pure calculation. Her work on this led her to publish the first algorithm intended to be carried out by such a machine, and as a result, she is sometimes regarded as the first to recognize the full potential of a computing machine and one of the first computer programmers. Ada Lovelace was born in 1815. She was the only legitimate child of poet Lord Byron and his wife Lady Byron. He died of disease when Ada was only 8 years old, and her mother promoted Ada's interest in mathematics and logic to prevent her from developing her father's perceived insanity. Although often ill in her childhood, Ada was a keen student who loved her work. At the age of 20, she married William King in 1835. King was made Earl of Lovelace in 1838, meaning Ada became the Countess of Lovelace. Her bright intellect and deftly managed social life brought her into contact with scientists such as Andrew Cross, Charles Babbage, Sir David Brewster, Charles Wheaston, and Michael Faraday, contacts who she used to further her education. Ada described her approach to science as poetical. Her mathematical talents led her to a long working relationship and friendship with fellow British mathematician Charles Babbage. She was particularly interested in Babbage's work on the analytical engine. Between 1842 and 1843, Ada translated an article from an Italian engineer on Babbage's calculating machine, supplementing it with an elaborate set of her own notes. These notes contain what many consider to be the first computer program, that is, an algorithm designed to be carried out by a machine. Sadly, her work was cut short, as Ada died of cancer in 1852 at the age of 36. Lovelace's notes are important in the early history of computers. she developed a vision of the capability of computers to go beyond mere calculation, while many others, including Babbage himself, focused only on those capabilities. Her mindset of poetical science led her to ask questions about the analytical engine and examined how individuals and society relate to technology as a collaborative tool.
So that's Ada Lovelace, as we just saw. And this here is Hermann Hollerith, who in 1889 created a calculating census machine for the company TMC, which later became IBM. And I've got a short clip on him as well.
Let's see. This is a Hollerith census machine. Hermann Hollerith, the man who came up with a better way of doing things, made some money, but is mostly forgotten today. What is the Hollerith machine? Well, it has to do with the American Constitution's requirement to take a census every 10 years. Starting in 1790, every 10 years, the American government has taken a census. The next one will be 2010. Everything was counted: horses, dogs, sheep, cattle, pigs, how many wagons you owned, if you were a railroad, how many engines, if you were a ship owner, how many ships you owned, anything and everything of statistical interest for economic purposes for government planning. What you see here is an 1890 machine used in the 1890 census, a better way of focusing, calculating, organizing the information. In 1880, the American census took about 5 years to collect all the data. It took another 4.5 years to complete the census. If you hadn't had the Hollerith machine for the 1890 census, it wouldn't have been complete in 10 years. These machines revolutionized large-scale information handling. The 1890 census took about the same time as the 1880 census, even though there were 16 million more people. What did it do? It provided a more organized way and a faster way of processing information. A large data sheet would be marked. It was organized into a matrix. The matrix in turn would be processed so that a punched card could be used. How was the card punched? A machine like this one, an operator would take a look at the data sheet, place a card in here. If there was a mark on the sheet, it would push down, punch a hole in the card. Then you'd take the card and you'd put it in a reader. 80 spring-loaded pins electrically connected to the counters on the machine above. You put the card underneath, press it down, there was a bed of mercury underneath. Mercury is a liquid metal that provided the ground for the electrical circuit. If there was a hole, pin went through, completed the circuit, and the counter would advance. Each counter number being part of the information being collected. Lift the handle up. Where do you put the card? This is an organizer, a sorter, if you will. Pop up because of an electromagnet relay. The operator would take the card and stick it in the box that was open. No decisions had to be made. Simply put the card in, press the handle down, lift the handle up, put the card into the open box. Was it good? 16 million more people in 1890. The census was complete in 6.5 years, 4 years earlier than the 1880 census.
So that gentleman in the clip there was a representative of the Computer History Museum in Mountain View, California. Has anyone been to that? Very cool. It's a cool place. The next big contributor to computing we should mention is Alan Turing, who was also brilliant in mathematics, like the aforementioned people. Most of you are likely aware of the prestigious Turing Award named after him that is given annually to computer scientists who make breakthroughs in the field. It is one of, if not the highest honor you can earn in the field of computing, and rightfully so, as Alan Turing is considered the father of computer science. He made contributions to the field of AI as well by detailing a procedure later known as the Turing test, which determined whether a machine could imitate human conversations. We have a clip on Turing.
Of the 20th century. Turing was a mathematician, cryptographer, and pioneer of computer science, whose life was one of secret triumphs shadowed by public tragedy. Perhaps known today for his part in breaking the German Enigma code during World War II, Turing was by that time already established as a mathematician of extraordinary capability. Born on the 23rd of June 1912, Turing spent his childhood split between Hastings in Kent and Sherborne in Dorset, displaying a precocious talent at school for maths and science, including condensing Einstein's theory of relativity for his mum at the age of 15. Turing's abilities led him to receiving a scholarship at King's College, Cambridge. He arrived here to study as an undergraduate in 1931. Like many great minds, Turing was never happier than when he had a problem to solve. And in keeping with the exceptional skill and ambition he had already displayed, he turned his attentions to the decision problem, or Entscheidungsproblem in German. Laid out by the legendary German mathematician David Hilbert at the turn of the century, the problem was one of the most important unsolved mathematical challenges for the 20th century. It was here in the spring of 1935, by the flow of the River Cam at Grantchester Meadows in Cambridge, that Turing decided to take on the giants of mathematics at the time. Turing conceived of a hypothetical machine that reads symbols on a strip of tape, rewriting or deleting them based on a finite set of rules. In fact, originally, Turing described a person slavishly performing these operations. He called this person the computer. Given a problem to compute, this machine would either stop and give you the answer, or run forever if the answer doesn't exist. Turing mathematically proved that you can never know if and when the machine will stop. He did this by creating the definitive example of the undecidable problem, an astounding feat that disproved Hilbert's question of decidability, showing that dark areas in mathematics will always remain a barrier to complete truth. The imagined Turing machine model went on to become one of the cornerstones of computer science, and is arguably one of the most influential mathematical abstractions of the 20th century. And Turing was only 22. Returning to Cambridge following time at Princeton, Turing began working for the Government Code and Cipher School, the UK's codebreakers. For many years before the Second World War, the German military had been using a cipher machine called Enigma to encrypt their secret messages. About the size of a typewriter, an Enigma machine has a second set of letters that light up, called the lamp board. If you press a letter on the keyboard, the machine generates a different letter to represent it on the lamp board, creating the code. The standard Enigma machine had over 150 million possible daily settings. Inside an Enigma are 3 rotors, which turn after pressing a key, making the wires of the circuit rotate, thus changing the circuit completely. So pressing the same letter will generate a different result. Double letters, for example, may not become double letters in the code. Enigma posed a formidable challenge for the Allied codebreakers. Codebreaking is a battle of mathematical wits and cunning, and during wartime, the stakes are high. Turing relished such challenges. A day after the UK declared war with Germany, he reported to Bletchley Park for work on breaking the German Enigma cipher. Turing's contribution to the codebreakers was quite simply vital to the war effort. Not only did he make the first breakthroughs with the naval Enigma code, allowing Britain's food and supplies to be shipped across the Atlantic, but along with Gordon Welchman, he designed a machine to smash the German Enigma code, called the bomb, named for an earlier Polish code-breaking machine. By using the fact that the German codes often contained a common phrase, such as those found in weather reports, the codebreakers would try and guess a short phrase or crib that might appear in an Enigma message. They would input this guess into the bomb, designed to perform a sweep of the myriad ways in which an Enigma machine could have been set up. By using the principle of contradiction, combined with extraordinary mathematical insight, the codes were eroded and eventually cracked. On a good day, the bomb machine could find an Enigma setting in 15 minutes.
In 1945, Turing received an OBE for services to the Foreign Office, though the real reason for this honour remained top secret for another 30 years, long past Turing's death.
Today, historians believe that the work of the codebreakers shortened the war by 2 years, and in doing so, saved countless lives. Following the war, Turing went on to work at the University of Manchester and continued to make hugely significant contributions to computing and later biology, until his death in 1954. He is credited with laying the foundations for computer technology and artificial intelligence, and worked on the first recognizable modern computers.
In September 2009, 55 years after his death, the British government made a public apology to Alan Turing.
Turing was gay at a time when it was illegal to be gay. On discovering the truth about his sexuality, the authorities forced Turing to endure horrific hormone treatment. He was labelled as a security risk, and he lost his job as a codebreaker. In the end, Turing committed suicide by biting from an apple laced with cyanide, a desperately sad end to the life of a genius.
Today, we live in a world dominated by computer technology.
From cars to smartphones, desktops to rockets, life in the 21st century is almost unimaginable without computers.
They facilitate our existence. For Alan Turing, hero of Bletchley Park and father of computer science, this was never the aim, or even the point. He cared about filling the gaps in our knowledge, about finding the light, the truth, the solution to the problems.
So that was Alan Turing. Next up on our list of notable contributors is this man here. He is also a genius in mathematics, surprise, surprise. His name is John von Neumann. He is considered by many to be one of the brightest minds to ever live. He had around 125 major scientific innovations, including developing the modern computer architecture. He also came up with the theory of game theory, which is used in all kinds of applications, including poker and war strategies, and much more. He also contributed to the atomic bomb project. His name is not well known to the general public, but his contributions to computing were enormous. And this here is Grace Hopper. She's our next contributor, and she is considered to be the grandmother of computer programming. Again, a mathematician who served in the U.S. Navy, Rear Admiral Grace Hopper is credited as developing the first compiler used in computer programming. Compilers, for those who are unaware, convert English syntax into obscure machine code that the computer can understand and execute. This contribution was game-changing because it made it much easier to, 1, learn to code, and 2, quickly write and debug code without as many errors. She is considered to be the first hacker in history, and she also designed the programming language COBOL. I believe I have a clip of her.
Grace Murray Hopper, the grandmother of computer programming, was born on December 9th, 1906. She attended Vassar College, graduating in 1928 with a degree in math and physics. After graduating, she accepted a position as an assistant professor at Vassar, which would help her pay her way through Yale, where she received both a master's and a PhD in mathematics. Satisfied with 3 math degrees under her belt, Hopper went back to Vassar, now as a full-time professor. She spent the next 10 years molding young minds. And then World War II broke out. Hopper wanted to do her part in the war effort, so she applied for the WAVES program, which stood for Women Accepted for Volunteer Emergency Service. It was basically the first program that expanded women's wartime roles beyond nursing and administrative duties. And in 1943, she was accepted to WAVES and joined the U.S. Naval Reserve. She was then assigned to work on the MARC series of computers at Harvard. The Mark I was one of the first electromechanical computers used in war efforts and the first of its kind produced in the United States. While working on the Mark II, Hopper discovered an unusual glitch. One day, the computer inexplicably shorted out due to a moth stuck in the hardware. The bug was removed, and Hopper referred to this solution as debugging the computer. Finally, in 1952, she revolutionized computer programming as we know it. She and her team invented the first compiler, a program that converted common sense commands into binary computer language. This blew the doors off computer programming. Every subsequent programming language is built on her work, and it's no exaggeration to say that we owe computer programming as we know it to Hopper. At 60, Hopper retired from the Navy with more than 2 decades of naval service under her belt. But her retirement didn't last long. Less than a year later, Uncle Sam came calling again, asking her to come back to standardize COBOL for the Navy. Always the dutiful patriot, Hopper returned to active service for another 20 years. Grace Hopper died on January 1st, 1992. In her later life, when asked what her greatest accomplishment was, Hopper was known to respond, "All of the young people I've trained."
So yet another honorable mention. This isn't a person, this is a computing device. These are timeshare computers, and they were first proposed in the 1950s, and they were realized in the 1960s. The design was composed of a large central computer in the center there that could be accessed via terminals, and the first one was initiated in 1959 by John McCarthy at MIT. And these 2 gentlemen here, Dennis Ritchie and Ken Thompson, developed the Unix operating system. And they did this in 1971, and they were employees of AT&T Bell Labs. Bell Labs was a research center for AT&T, and a lot of cool inventions were concocted there. It's known as the Idea Factory. A lot of influential people worked at Bell Labs, including William Shockley, who headed the team that developed the first transistor, and Claude Elwood Shannon, who conceived the foundations for information theory, which is the mathematical study of quantification, storage, and communication of information. Also invented at Bell Labs was the C programming language, which was developed by Dennis Ritchie, one of the inventors of Unix, the guy on the right. And yes, and the C is considered to be the mother of all modern programming languages, as most programming languages today are derived from C. And let's see. And then here, this is Bell Labs' website, and you can go here and they have a little bit of information on the different things that they've created here. So if I can get to the right arrow, thank you. Unix was created here. this satellite, the laser in 1958, the solar cell in 1954, information theory, 1948, the cellular concept, 1947, the transistor, 1947, television transmission, 1927, sound motion pictures, 1926. So there was a lot of things that came out of Bell Labs. It was a hotbed for very, very cool technology. And let's see. Pictured here is the Intel 4004. It's the first commercially available microchip. And that was invented in 1971, and it's contrasted on the right there with a more modern Intel chip. And so we've come a long way in that amount of time. Next is the invention of the Altair 8800. This was a microcomputer designed in 1974 by a company called MITS and based on the Intel 8080 CPU. Interest grew quickly after it was featured on the cover of the January 1975 issue of Popular Electronics. It was sold by mail order through advertisements. This is considered to be the first mini computer kit to rival commercial offerings. This is what, well, let me don't skip ahead. Let's see. This here are pictures of Steve Jobs and Steve Wozniak. Most people are familiar with these two. They created Apple in 1976, and they released the first Apple computer, I believe, that same year. This is a picture of Bill Gates and Paul Allen. They created DOS and Windows in the company Microsoft. And they created DOS in 1981 and Windows in 1985. Bill Gates and Paul Allen programmed the Altair 8080, and they wrote an interpreter, BASIC, for it. And that's really what helped popularize the personal computer. This gentleman here is Richard Stallman. He started the GNU project in 1983. The GNU project was a project that wanted to take Unix, which was a commercial operating system, closed source. He wanted to develop Unix-like applications for free, for open source purposes. And so he started this GNU project in 1983. He had lots of contributors, and the only thing was missing was a kernel to run the whole operating system. This man here, Linus Torvalds, in 1990 in 1991, created the Linux kernel, which was the last piece of the GNU project, and thus Linux was born. Yay, Linux. And that is the end of the talk. I had planned on talking about smartphones and wearable technology, but I believe we all have a pretty good understanding of that recent history. And so with that, I'll wrap up. I hope you found this history of computing as interesting as I do. And are there any questions?
Big hand for Ken. All right, I will be running around with the mic, and I will just remind folks that if you are streaming, please do ask questions in the main stage channel on the OLF Slack, and I'll monitor there as well. Please share your name and then your question.
Sure, my name is Jimmy. One of the things I've heard, and I don't know if this is a rumor or not, so maybe I'm spreading a rumor, but it's a question at this point, was that at the Bell Labs time, when Unix and C were being developed, Specifically, AT&T, who owned Bell Labs, was under the monopoly, and then in the early 80s, they would be broken up. But at the time, they were directed to not sell these things because they were concerned about their monopoly position. And so they shared a lot of C and Unix source code with universities like UCal Berkeley and those sort of places. And that, in some ways, is kind of a lot of the birth of open source because they couldn't sell it, is my understanding. I don't know if you confirm that or any knowledge of that.
Yeah, I'm pretty sure that's the case there. That's awesome.
It's not necessarily a question, but an addendum. Oh, I'm sorry. My name's Gage. I actually took, when I went to go change my name, I actually took Grace Hopper's last name. But one of the things that I learned after I got out of high school, because there was a guy that wrote an entire book about this, but IBM had a German sort of outpost back during World War II. And one of the things that I thought was pretty interesting when going through IBM's history is that the Hollerith machines, they were here in the States as well, but the Nazis actually contracted IBM to build custom Hollerith machines for the concentration camps. And so in high school, they taught us that, they had tattooed numbers on the Jews' arms, but they didn't really go into that. And it was IBM's fault, it was described by the author of the book as all IBM had to do was stop supplying Hollerith cards. They were like shotgun shells, right? If IBM would have stopped supplying them, a lot of lives would have been saved.
Yeah, that's unfortunate that that technology got used in that manner.
My name is Phil. I just wanted to relate an anecdote that I heard about Grace Hopper in the 80s. A coworker of mine attended a talk that Hopper gave, and during her talk, the question came up: how much longer do you think COBOL, the language, is going to be around? And her reply was, "We didn't think it would be around this long." And of course, it's still here with us today.
Turning more into an open mic session instead of a Q&A session.
It's all good.
I'll ask a real question.
Like
Hi, Rick Wills. You tell a very elegant story. I thought it was very, very well put together.
Thank you.
You start with, 2,000 years ago with the Astrogate, and then you jump to the middle of the Industrial Revolution. What changed from, say, you had Ada Lovelace and Babbage, and then boom, suddenly things in the 1880s, 90s start taking off, and then zoom right through the entire 20th century. What's your opinion of what changed? What drove all that, and then hit the 1990s, and boom, suddenly PCs are here. So how would you describe that? What changed?
I would think things like the Industrial Revolution, the steam-powered technology, and then maybe like manufacturing, like the tolerances with the machines and the metals and stuff to build the intricate machinery. I would think that was a big contributing factor.
In all your research for this talk here, how many email threads did you find talking about GNU Hurd in comparison to the Linux kernel, and how the Linux kernel is going to be outdated in favor of GNU Hurd in the realm of eventually? Which, by the way, you can actually boot Debian right now with the GNU Hurd kernel.
Nice.
My name's Bennett. I'm just wondering, where can I learn COBOL? I've been interested in it for years, and I can't find a class on it.
Some universities brought it back, believe it or not.
I don't know anything about programming, so a little preface here. It might sound like a dumb question. Huh? Your name? Oh, yeah. My name's Thomas. But what I was going to ask is, between and I know this is probably like comparing apples to oranges or whatever, but between COBOL and C, which would you say gets the better optimization at the end of the day? I don't know. I'm just wondering, any programmers out there? C? Oh, okay.
Anyone else while I check our internet friends? We see you, internet friends. You are very quiet. That's not how the internet normally works. Anyone else in the audience?
I'm Kite, and I guess my question to you is just, I guess out of everyone that you talked about, like, kind of for us in like modern 24th century and at this conference, if there's anyone you want to pick that you think would be like the most significant that we should be aware of right now, or maybe like you said, because I know a lot of these people are lesser known or we just forget about them.
Yeah, it's hard to pick one, like the biggest influential person, but if I had to choose someone, it probably would be Alan Turing or maybe John von Neumann, but they all made significant contributions.
Is that kind of related because we're in like this AI phase too now, or would you say, or just wondering what your reasoning is?
They were just wicked smart.
This is wicked.
Right? Like wicked smart.
My name is Zach. So, starting from the very beginning of your talk all the way through, it's been like this exponential ramp of technology for the last 1,000, 2,000 years. And at every point, everyone was looking and saying, we're like at the pinnacle of society, and this technology is really amazing. And what they looked at afterwards, they never ever could have imagined. It was like so much greater than they ever could have imagined. And right now we're sitting on this edge of so much computation with artificial intelligence. What's next?
I'm probably the wrong one to ask.
Moore's law is still in effect.
Yes.
Anything more to add, Ken?
Nope.
All right, big hand for Ken.
Thanks, everyone.
We're going to get Adam set up here real quick and get started right at 2. Hello, world. All right, everyone. I'm excited for our next presenter. I used to work with Adam. Adam is among the smarter people I know. He's an expert as it relates to large-scale distributed computing systems with experience across software and building systems and operating infrastructure. Adam got tired of building really awesome stuff and now teaches people how to build really awesome stuff as a professor at Kent State. Today, he's going to be talking about NixOS and how it can be used for package management. I'm probably moving a little too fast for Adam because I was rude and didn't pay attention to time, so got it too close to his speaking slot. So I'm going to take cue from Adam and stop speaking in the very near future. Meanwhile, I'm going to stare at you awkwardly.
How's everyone doing today?
Try again.
Test 1, 2, 3. Hello, hello.
One more time.
1, 2. Okay. How's everyone doing today?
Yay, Adam.
So I am trying to get this working. I was like, so I use a Mac for my teaching, partially because it's always reliable, right? And I'm like, well, I need to display, or I need to present this on my NixOS laptop. And then of course my window manager crashed. And now I'm trying to get everything set back up. So I am using Wayland. Yeah, that's nice that you are going to boo me on that one. I am not going to show you NeoFetch. I don't get the thing about NeoFetch. Why do people love it so much? It's the people who like to customize their desktops really enjoy it, don't they? Am I getting any output on that? No? I guess I should have run through a test here, huh? What about now? Something. HDMI 1. All right, so that means it's outputting over there now. So let me try to figure out where it is. This, of course, is obviously going to be a big failure here. Who here has heard of NixOS? Who here has tried to use NixOS? Who here has succeeded at using NixOS? Yeah. It was not my first attempt at NixOS that made this work for me. And this is not working for me at all. For those of you who did try NixOS, why did you give up? Documentation, yes. That is one of the negatives that I was going to list about this. If I could ever get my slides to display. And that's not going to do it either. I had an Xorg set up, and I was like, this will be better if we will use Wayland.
It got to the installation part where it was installing stuff in Etsy, and then it told me that the file store was corrupt.
Told you the file store was corrupt.
Yeah, something about a Nix store. I don't know what that is.
So this is working. I just need to be able to see it on my screen. Yeah, so the Nix store, and I'll talk a little bit about that, but the Nix store is where everything in NixOS gets put. It does not have your typical file hierarchy structure. What the hell is going on? I tested this at home. It worked. This is not going the way I want it to. We're still waiting for some people to trickle in here. Overlay screen names, yes. So I'm not getting anything out again, huh? All right. Okay. Let's see if this does what I want it to now. Yes. Yes, it's working. Yes, it's working. So I need to open Firefox. And I need this. Okay. And I want my speaker notes. Okay. I'm almost there. Sorry, people. Okay. We're good to go. I apologize for the delay. As much as I love being a Linux desktop user, sometimes it has some frustrations, does it not? Okay, so this talk here is the basics, from basics to DevOps of NixOS. I gave it this title. We'll get into a little bit of the DevOps side, how you can deploy from one host to another. But I have to lay some groundwork before we can even get to that point. So let's start off. Already failing. So who am I? I'm a professional in residence at Kent State University. What is a professional in residence? Effectively, it means I'm there because of my professional experience, not because of my academic experience. I have a bachelor's. I do not have a master's or a PhD. I'm only there because I have 20 years of IT experience. I'm in the School of Emerging Media and Technology. We're an interdisciplinary school within the College of Communications and Information. And we teach people a variety of things, including computer programming, project management, and stuff like that. You can find more about EMET there, kent.edu/EMET. But formerly, I worked as a DevOps engineer, as a systems engineer, as a software developer, as an engineering manager at a variety of organizations, both public and private. I put my normally favorite handle here of a bee. If you see me anywhere online, I'm normally using this image. And username Adam C. Stevens. You can find me there on most platforms. I had one more slide on here. So why should you listen to me? Maybe you shouldn't. I don't know. That's up to you. I've been using Linux for over 25 years. When I was a teenager in the 90s, my first experience with Linux was, I got a Slackware CD, and I'm going to install it on the second hard drive, this 1 gig hard drive I spent $300 of my own money on, and proceeded to format the Windows partition. So I learned about partitioning very, very early on. I've owned thousands of Linux systems, and owned as in it was my responsibility to administer and run them. I'm a very big fan of configuration management tools. I was very early on in the Puppet world. I used it for a lot of years. It was great. I love declarative configuration management. I've also worked with Chef, Ansible, and I've spent some time with Salt. And now I use Nix for everything. You can continue to try and mix those things, but one thing I love about Nix is it's almost a universal language for everything I'm trying to do. And I'm a programming language polyglot. I can read and write in multiple languages. I have some preferences, but I'm not one of the kind of people who are going to tell you that language is bad or that language is amazing. They all have pros and cons. Okay, terminology. If you come and visit us in the Nix community online, sometimes you may get corrected for terminology. So I think it's important to discuss what the terms are because they all have Nix in them, and that's confusing, isn't it? So Nix is the language and a package manager. It's a simplified functional programming language, but it's the foundation of all of these other things. NixOS is a Linux distribution that is configured and built using Nix. Nix packages is where all of the packages for Nix and NixOS and the modules for configuring NixOS are stored. And then NixOS modules are how we use the Nix language to configure Nix. So NixOS is a declarative operating system. So you declare what you want your config to be, you apply that config, and that changes your system. You'll see that live here in this demo. So I'm going to run through a quick syntax overview. I don't want this to be a programming class. I teach this to my college students. But when you're looking at what I'm going to be showing you, it's helpful to at least understand some of the basics. So we have basic types, your strings, your numbers, your booleans. There's also your normal data structures, lists, and attribute sets. An attribute set is kind of like a map that you've used in other languages. How you can represent them in Nix is a little different. And then we have functions, which use those. So this is an example of an attribute set. This first one's a string. Looks pretty straightforward, right? The second one is an attribute set with a nested attribute in it of a list, which is a list. And then the last one is also an attribute set, but you can separate it with dot notation instead of nesting them inside of the parentheses, or the curly braces. Functions, if you've ever used Haskell, they look a little bit like this. Effectively, argument 1, colon, that's your argument, and then that would return arg1 to it. And then some examples of some sums. So a function that takes 2 arguments, A and B. And then the second one I showed, because it's a pretty common pattern in the Nix environment, which is to pass an attribute set to the function. So in this case, for sum 2, expecting an attribute set that has an attribute A and an attribute B. And you can see how I call that in result 2, where I call sum and I pass it an attribute set with 2 named attributes. Okay. Any questions about this? Probably not, but just a quick overview of the syntax. And then NixOS modules are how all of NixOS is configured and written, and they are almost all files that are functions. So the function's called, and it's passed an attribute set that has config, which is the system configuration, packages, which is the set of packages available to it, and the 3 dots, which you see there, means accept any other arbitrary arguments and don't complain about it. Okay. Syntax. No one really wants to talk about syntax, right? You want to see demos. And my goal here is to spend most of this time on demos. So let me switch this over. That's the wrong side. And pull back up my notes, which I had, but. And if nothing goes wrong, it won't crash on me again. It actually crashed when I tried to mirror the screen. So. All right. Okay. So one of the things I was going to do here is make sure that you all can read this. Is that legible enough? Would you prefer it with a light background? I got one person that said yes. How about that? Is that easier to read? Yes. A little bit easier, yeah. Yeah, when I present in my class, it's a whole lot easier. The projectors seem to do it better if you have a white background than a dark background. Okay, thank you for dimming the lights. It feels so amazing. Okay, so what are we going to do here? I got a couple machines. One's called OLF1 and one's called OLF2. And they're already running because otherwise I'd have to start them. And so I can log into them. And this is my NixOS machine. You can see it. It's great. It looks just like any other operating system, except I'll show you real quick what's in /user. There's a bin in there. What's in /user bin? Just M. So already you can see this is very different than what you would expect out of any other distribution. So let me see here. I got to pull up where I actually am in my notes. Okay. So one thing, NixOS has the capability, I should correct myself, both Nix and NixOS have the capability of installing packages imperatively. And what I mean by that is when you install a package on Debian or Ubuntu, you say apt-get install or apt-install if you're using the newer syntax. And the same thing on Red Hat-based systems where you're using Yum or DNF to just do an install. And that installs the package for you and everything that it needs. You can install packages that way with Nix. I'm actually not going to show that to you. You can find plenty of examples of that, even in the maybe not best documentation. That's getting better. But what I am most excited about with NixOS is the declarative nature of it. The fact that I can say, I want service A installed, I apply that config, and service A is going to get installed. So some of the important directories for us here are etc Nix, which configures the Nix package manager itself, and then etc NixOS. So in here we have 3 files. When you do a basic installation, and I did these VMs based off of basic installations, you will get a configuration.nix and a hardware configuration.nix, which is generated using your, here I can even show this, hardware configuration. How about we use less? And so you can see, I said lots of things were functions. This is a function. And so it's expecting a config and lib and packages and modules path. And that's not so important here. But what's important is this gets generated based off of the installation environment. So it's going to get the kernel modules that the installer thought I needed when I was installing it, the file systems. So you can see my slash and my slash boot. I didn't mount and swap when I was creating these because I didn't really care. And then DHCP. We all like DHCP, right? Well, some people hate it. But I like it because it makes things work, usually. And finally, the host platform, which is x86, 64 Linux. Nix itself has 4 default platforms they support: x86, 64 Linux, ARch64 Linux, and then the same for Darwin. You can run Nix itself just on Mac without thinking about NixOS, because it's not NixOS. You also get configuration.nix, which is going to include hardware configuration.nix, as well as set up your bootloader a little bit, and then have a bunch of commented out options for you to enable to start using your system. I didn't enable any of these. I did cheat slightly because I wanted to make sure this demo went somewhat okay, and I created this other file, core.nix. I'm not going to go through this file because there's a lot going on inside of it, so I'll just close it. My goal there, though, and I'm happy to share it, I'm not trying to hide this from you, but I'm also not trying to overwhelm you with some of the customization I did to make this demo go a little bit smoother. What I actually want to show you is how we can make changes. So let's edit configuration.nix, and let's come down here, and what do we want to do? What do we want to do? So I think I'm going to go ahead and set the host name. So there's an option up here, networking.hostname. I'm going to uncomment it. You can see the default's NixOS. So I'm just going to come over here and change this to OLF1. That's the name of this VM. And I will save it. And then I'm going to NixOS rebuild build. And if I run rebuild build, that's actually going to go compile the new configuration in preparation for applying it. But it's not actively going to apply it. So I've now validated that my config change does work. If the options I tried to set didn't exist, or I tried to use them incorrectly, this step would fail. I can also then go ahead and switch to that configuration. And when I do so, it's actually going to, again, try and rebuild it just to verify that it has correctly built it. And then it will switch the actual running system. Now I changed the host name. That doesn't show up in my prompt right away, does it? So I can show you by typing host name that it is now OLF1 exec. What about that? Yeah, whatever. Not $0, why isn't that not working? Anyways, so ignore my failures. As I tell my class, when I stumble, you see that I'm not perfect, right? We all struggle as we work through technology. So I'll log out and log back in. There you go. So now you can see my host name is correctly updated in the prompt. But changing the host name, that's a pretty simple thing, right? On most distributions, that's editing one file, etc host name, and then that's it. or you can use the newer host name control. Is that what it's called? Yeah. Okay, so let's go back to Etsy NixOS. And this time, I'm going to change something a little bit different. But before I do, systemctl status nginx. I will show you, before I change it, that nginx is not enabled here, right? It's not running. I'm not trying to trick you with any magic. So now I'm going to actually change it. And I'm going to sudo hx configuration.nix. And I'll just do it right here at the top. And where are my notes? Okay, so I'm going to services, where's my mouse? Services.nginx.enable gets true. I will save that, and I will just go back up and rerun this same switch command. And what it's going to do, it shouldn't need the network. I gave it a network just in case it did. But because I've already applied this change, it should already find all the necessary bits locally. It's going to go ahead, compile any necessary config, build any necessary configuration files, and it's going to start the service for me. So you can see on the last line here, I've now started nginx. So now I can run systemctl status nginx, and we can see we're up and running. Now, one thing I learned when I was doing this demo, I'm not a big user of nginx. I generally am more interested in the newer proxies, such as Trafic or some of the others. And in this case, I was like, oh, I don't get anything here. Well, why is not? Because I haven't defined a virtual host. So I know nginx well enough, but I don't write my nginx config in nginx config format. I write it in Nix. And so I'm going to say virtualhosts.olf1.lxd gets, and I'm going to make this an attribute set, and it's going to be, I want to try and align things correctly. So var, this directory doesn't exist, but that's not the point. Don't forget your semicolons if you want things to work correctly. And so I will apply this another config change, which now will set up that virtual host. And it's got to make sure it has applied the correct config. And you'll see, you may have noticed it when it spit it out before. It runs a validation check on the config. It didn't do it this time, but so now if I curl localhost, you can see 404 not found. The specifics of what the nginx server is giving us here isn't really important, but I have now applied this configuration. So how do we think that we go ahead and remove nginx? Any suggestions? Any guesses? Comment it out. Yep. So in fact, I can just comment out the enable line. Because most modules inside of NixOS, or almost all modules inside of NixOS, will only trigger all of the other configuration if the service itself is enabled. So I comment that out, and as this runs, what it's going to go ahead and do is essentially build the configuration that I've already built previously to applying the nginx config. How are we doing on time? And at the top here, you can see it says stopping the following units. I don't know why it's dealing with log rotate checkconf. It is, but it's also stopping nginx. So now you can see curl localhost is gone. Nginx is no longer running. I know some people don't love systemd, and I understand some of the arguments. But at the same time, systemd is a declarative init system. And it's very tightly integrated with NixOS. So if you hate systemd to the point where you refuse to use a distribution because of that, you're not going to have a good time with NixOS. Because NixOS is able to lay down a config file, reload systemd, and then that now makes the service available. So I showed /user wasn't available. I mean, why do we have /user bin in it? Bin in there, because scripts use that to determine where a binary actually is. There's nothing in sbin. There's a bin sh, probably just for the same compatibility reasons. So you start to see, while there are common directories from the FHS file hierarchy structure, it's like /var, all of my packages are stored in the Nix store. So which system CTL? So when the system boots up, it creates this runtime directory which has a bunch of links in it. But if I look at where this is actually linked from, the answer is always in the Nix store. And the Nix store is going to give you a path like this. It's based off of a hash of how it generates the actual package. Okay. So moving on. There is one other option that I will point out for NixOS rebuild, which is called boot. And what that does is it builds the configuration and it adds it to the bootloader as the next boot system. So until you reboot, you'll be in the current generation. But once you reboot, then it'll choose the next one. I'm not going to demonstrate that right now. If I have time, I will show you the bootloader, though. I already did that. So there is, if I come back over here. So where do I find out what packages or what services I can install? There's a great service here called search.nixos.org. So you can search for packages. I can search for Nginx. I get a bunch of hits for it. You can see the fourth one down is Nginx itself. But more interestingly on Nginx is you don't generally install a package in order to get a service. You configure the service to run. You saw I never said install package Nginx. On Ubuntu or Red Hat or any of these other distributions, you install a package, it also lays down the configuration. If you install a package in Nix, you're only getting access to really the binaries and the files, but there is no configuration for the service itself. So you use these options to configure your service so that you can actually run the service. So there's a lot of stuff in here that also talks about Nginx. So maybe if I look at services.nginx, you can see all of the options here. You can see the virtual host one that I used. You can see we can set up and use Let's Encrypt natively. There's lots of options in here. I mean, more than 10,000. Who knows how many there are? I don't. Okay. Any questions so far? I guess we'll wait for questions till the end. So we can also list the generations. And a generation is created every time I switch my configuration. So I'm not expecting you to memorize this path that I'm typing down, because I don't know it off of memory. But if I list this, you can see, and some of these are from my preparation for this demo, but each one of these is a slightly different configuration change. And I can roll back to them here. I can also reboot back into them. Has anybody ever changed their FS tab and not been able to boot their system back? I'm going to raise my hand. So because we're not managing because we're managing the FS tab through NixOS, I can reboot back, and in the bootloader is the list of all of these generations. I can select the one that had the correct FS tab. So I can recover without having to boot a live CD or whatever you need to rescue your system. Not saying there's not ever a case where you would need to, but I haven't needed to yet. Okay, so let's actually look at that one. So system CTL status, system CTL status Nginx. It's not here. So I'm going to open up another terminal, and I'm going to console connect to my VM, and I'm going to reboot this. Womp, womp, womp. So it's hard to see here because this one. Let me try this here. Let's see, stop, OLF1. Yeah, I know. Let's see, start OLF1 dash console. Sometimes VMs move too quickly for us, right? And so you can see here, I have the list of generations. It's not rendering very well. But if I go all the way to the top and go down one, theoretically, we should boot back into the one that has Nginx running. And systemctl status Nginx, and you can see it's back running. So I'm demoing this with Nginx, but any configuration change can be reverted or gone back to based off of those generations. Sorry for the bad rendering based off of my screen size. I think you all have used remote consoles and other things. I hope you understand how bad that is. Okay. So I also said I was in my talk, this demonstration, that I was going to show you how to do this with multiple systems. But before I do, I want to talk about flakes. And what are flakes? What does this even mean? So flakes are a newer feature in the Nix world that provide us a uniform schema for resources. And so using the Nix language still, we can also define our multiple configurations for a host. So I'm going to show you how to convert what we already have into a flake-based configuration. We can also reference other flakes. So those flakes may provide packages or NixOS modules. By default, you're going to be referencing the flake of Nix packages, which is where the vast majority of existing knowledge is already stored. And we can also, as someone who loves the software development world, lock our revisions of our flakes. So we can say, I know I'm using the same version of Nix packages or other inputs in order to generate my config. So I can give you my config, and you could rebuild it exactly how I had. It does provide a new command line interface. And I will point out it's experimental. It's my preference, though, because for me, it took till my third attempt at NixOS for it actually to click for me. And it wouldn't have done so without flakes. Because there's stuff I wasn't showing you as far that manages where Nix packages comes from without flakes that I think is a lot harder to reason through and is contrary to what I want, which is a declarative, reproducible environment. But I will point out they are experimental. So a very simple example of a flake that doesn't really doing anything, but I take an input and I generate some outputs. And the output itself is a function that takes the inputs. And so in this case, I am going to output a NixOS configuration. I hope I'm not tricking you here that that's going to configure a NixOS system. There can be other things in the outputs, like I said, packages and development shells. I think it's more powerful than just for NixOS, but this is a NixOS talk. All right. Slides are boring, right? So let's go out of here. I'm going to close. Let me just get rid of that window. All right. So I can go into Etsy NixOS, and I'm just going to copy a flake I have in place. Flake, flake star. And if we look here, oh, I probably just broke things, didn't I? Yep. This flake.lock is now wrong. So let's look at this flake.nix that I've created. Luckily, I put this in my notes. So this is the lock file that I copied over top of my Nix file. This will be helpful for me because I actually have a copy of the Nix file. So I'm going to move this flake.nix to flake.lock. See this top command up here? I guess it's not. This command in the middle, cp. What did I do? I copied one file onto the other. Yeah, I forgot the dot at the end there. That's what you get for trying to do a demo, right? All right, flake.look to flake.lock. The lock file will be helpful for me here. I would have been happy to recreate it, but I also didn't want to rely on the internet very much. And so in this case, locking what I already had will ensure the configurations I've already applied, prepping for this demo, are already pre-staged here. Normally, you didn't see any of this, but normally if you need to pull down packages and stuff like that, and if we have time, I'll try and do it, you'll see it actually pulling down existing binary packages out of the NixOS cache. All right, so and we'll do this from scratch because I deleted it. We're going to create a flake, and I don't know why I can't see my cursor. And we're going to do inputs, and that inputs is going to take nixpackages.url. It gets GitHub :nixos/nixpackages, and then release 23.05. So NixOS is released on a 6-month development cycle. Personally, I use the rolling release of unstable, which isn't as unstable because it's actually fully tested before things get into that branch. But we'll use this release branch. And then I wanted to take an outputs. And remember, outputs is a function that takes the inputs. In this case, I care about Nix packages and nothing else. And I forgot a dot. And we're going to say NixOS configurations.olf1 gets nixpackages.lib.nixOS system. So Nix packages includes a set of library helpers. One of them is to generate us a NixOS configuration. And in here, I have to specify my system. This is one of the complaints about flakes. I understand it, but as someone who uses multiple architectures, it's actually kind of nice for me too. And I need to set a set of modules that I want to put in here. And in this case, I'm going to pass a path directly to my configuration.nix. So what should this do? Does anyone think? Should it be any different? It's not, because it's using all of the same config that I've already applied. But you'll see why there's an advantage here in a moment. So I'm going to write this, and I'm going to do sudo nixos rebuild. And then let's just build for this moment. And apparently I am going to use the internet. And this is a 34 meg download, so who wants to tell me? I don't know. I don't have any good jokes to tell you guys. Anyone got a good jokes? My jokes are, what's that?
I'll tell you a UDP joke, but I'm not sure you get it.
Yeah, that's a good one, yeah. Yeah, I wouldn't have had to do this download if I hadn't messed up in my copy file, but that's what I get for trying to do a live demo. So while that's running, I'm just going to go ahead and continue on, and we'll come back. So I'll go back here, and I'm going to edit. I almost used Vim. I don't think Vim's installed. So I'm going to edit this. I'm sorry for my poor formatting. And I'm going to say NixOS configurations.olf2, which is the other VM. And I'm going to go ahead and recreate it just like the one above. Linux modules. I probably could have just copied this quicker. Configuration.nix. So this will allow me to build the second one as well. And how can I do that? I guess I should wait for this other download. We're almost there. I built it just the same, but I can give it a target. So it would be NixOS rebuild build flake dot, which is the current directory, and then the name of the VM, or the name of the host that I'm trying to target. And where does that name come from? That name comes from the flake.nix attribute. In this case, NixOS configurations.olf2. We're so close. Okay. I was wrong. It's bigger. When you use a fast internet connection, you don't see this thing, right? I thought of 0, yes. Sometimes the calculations in computers are hard, isn't it? Yeah, it looks like it's now evaluating it, but or my hotspot died. Okay. Oh, I got an error. Errors are great. Oh, I know why this is. Because my demo here doesn't work on stable. So change to NixOS unstable. And this not having a cursor thing is quite frustrating. I know, that's what I'm trying to do. Thank you. Okay. Tell me you're not going to download again. It says it's evaluating. I have a, okay, it's building. Okay, so it built. Exactly the same. And if I switch, nothing should change. We should probably make something change so that it's obvious. But let's focus on this second host just to, for time. So sudo nixos rebuild switch -- flake /olf2. So this should build the config for OLF2. Well, the config for OLF2 is currently the same as the config for OLF1. And if I go over one more window and go to olf2.lxd, we'll see my host name's still NixOS, right? Remember we changed our host name to OLF1. Well, I don't want the host name to be OLF1, right? That doesn't make sense because the machine's called OLF2. So sudo hx flake.nix. So I'm going to come down here, and I'm going to add another module in here that says networking.hostname gets OLF2. I'll write that, and let's build it again. Oh, we got an error. And I thought about removing this error, but it's better to actually have some errors that you can kind of look through here. One of the complaints I have about NixOS is the verbosity of the errors and the meaninglessness of some of it. But if you actually look back here or down here where it says error, the option networking.hostname has conflicting values. And it tells me that the flake provides OLF2, but configuration.nix provides OLF1. So a couple options, I could go pull the networking.hostname out of configuration.nix, that would work. But instead, what I'm going to do is use this example down here, lib.makeForce, which I'm going to say force override that value. This is the one that I want to use. So if I come here, I can say lib.makeForce. And if I rebuild this, I will see that there is no lib because generally lib is available in the package space, but how about nixpackages.lib? Has anyone tried to ever user editor without a working cursor. Is this because I put it in white mode, probably? So now I can run this. It will go ahead and compile, or build as we call it. And I did a switch. So the other thing I want to show here, what did I do wrong? I applied this same config to OLF1. That's probably not what I wanted to do. So let's switch this one back for consistency. And while that's running, I'm going to double check my notes. See how much time we have left. Okay. So this one's still OLF1. That's good. But I can use NixOS rebuild to target host OLF2. And I need to use remote sudo because I'm using sudo. And what this is going to do is it's going to build. If I remove sudo, that'll help. I was sudoing to root locally, so it's trying to authenticate as root. So this is going to build the host locally, and then it's going to push it over SSH and apply it onto the remote host. And so you can see here it's copying paths from my local system to SSH OLF2, and now it's reloaded that. So if I go back to OLF2 and I type host name, you can see I've now pushed from one host a configuration to another host. And I do this a lot in my home lab. I have one powerful machine and some other not so powerful machines. And it's a whole lot nicer to build on the powerful machine and then just push some bytes over the network and tell it to go ahead and switch. And anything I can configure locally, I could obviously configure and then push across the network. Okay, so I have a few more minutes here. When do we want to wrap up? At 50 after? Is that right? Okay. So I'll show one more thing, which is being able to run packages arbitrarily. So if you are on Debian and you want to run the hello package, I know they're not the most exciting one, you can see I don't have hello installed. But I can run nix, I don't have to, nix run nix packages hello. And I'm going to get an error here because by default, Nix experimental features are not enabled. So I will enable them on the command line. You can also do it in the configuration file. But for time, I'm not going to show you that. Flakes and Nix command. No. Extra experimental features. So many long command lines. This one's, how about we do this on the other host where I pre-stage this? So one complaint I have about Nix is a lot of assumptions. Assume that you have a fast internet connection. And this is not the case here, is it? So I'm not able to demonstrate this without downloading Nix packages again. But you can just arbitrarily run these commands. Any of the packages you can run without technically installing. Now, it's going to pull all the bytes down. They're going to be on your disk. So if you're worried about disk space and trying to shave off as much as possible, NixOS is going to be stressful for you. NixOS uses garbage collection to free space, not removal of packages. Because you can have multiple versions of the same package on your system at any given time, especially as you're updating. You're going to be, you have one version of Nginx, and then you update, and you have another version of Nginx. Both of those are still on your system until you garbage collect the older versions. I don't have time to demonstrate all this, but my goal here was not to show you everything about Nix, but to whet your appetite of some of the things you can do. Hopefully I've been successful at that, but we'll see. So final discussion. Some pros of Nix. In my case, a huge one, operating system as declarative code. We can do rollback and system versioning. We can inspect and build our configuration before we apply it. So we can make sure that what we want is available. I call it fearless refactoring as well. I can reorganize my code and how I'm configuring my system and know what it's going to work before I even apply it. And we have a very passionate community. Some cons. If you like to run random binaries off the internet, you're going to have a hard time. Dynamically linked libraries expect things to be in user or /lib, and they will not find them in the Nix store. It has a steep learning curve and very bad documentation. I don't want to say very bad documentation, bad documentation. But there's ongoing efforts within the Nix community to continue to improve those. And I've already seen, in my year of using it, a lot of strides made. It tends towards Nix everything. As you saw, I used Nix to write an Nginx configuration, right? There's some templating going on underneath there. Once you start to get the bug of I configure with Nix, you want to use Nix for everything. And that means if you're missing NixOS modules, it may not work the way you want it to, but we're always happy to have you join us in contributing. The store where everything is put is world readable. So don't put any secrets in it. Passwords, keys, tokens, you need an out-of-band method for deploying those. There are a couple of those in the community. I'd like to see that area continue to improve. A few resources, NixOS manual, search.nix.org, NixDev, and then come ask questions if you need it. There's a matrix community, there's a Discord community, there's a forum. I'm going to skip that and just say thank you.
Thanks so much, Adam. I'll be running the mic around for any questions. I'm going to hijack the first question, though. And I'm going to ask it a couple ways. Take it as you will. What problem are we solving? What is the use case for this technology?
So the problem I see we're solving is we're able to create reproducible environments. I can reproduce my system given a set of files today and tomorrow. If you think about how any typical Linux distribution works, it kind of grows and evolves over time. You lose control of what files have been installed, what configuration has been applied. But by driving it through the configuration files and giving us that declarative language, I think it solves, in my opinion, real problems that we as a system administrator and Linux communities struggle with.
I'm going to try and keep us on time this time, so only a few questions.
Sure. So I'm Jimmy. As a longtime Puppet sufferer, this seems familiar in some ways.
Yep.
What happens when you want to do something complicated in an application configuration? Because the thing that kills us with Puppet modules is oh, we want to do X, but the module only supports 10% of what the app can actually do.
And I mean, I think I kind of pointed that out, that either missing NixOS modules or not fully fledged NixOS modules. Ideally, any configuration that is JSON or YAML or TOML, we can directly convert from Nix to that format. It's, in my mind, more of the legacy stuff that are custom languages like the Nginx configuration. I'd say some of the more common things like Nginx, you're not going to have too many problems with. A lot of people have used it for many years. Some of the more niche things, they may be missing features. And just like with Puppet, I've used Puppet for 10 years or so. You have to get dirty and write some code at a certain point. So yeah, I mean, that is definitely one of the potential pitfalls with this, yeah.
I'm going to paraphrase Jonathan Gray's question from Slack. He is looking for help setting up Nextcloud 27 server with NixOS. Can you direct him to any resources for that particular thing?
Yeah, so I haven't personally set up Nextcloud, but I'd say if he's struggling, the community is definitely willing and able to help. There's a lot of great people. Like, there are a few different communities between Discord and Matrix and Discourse. But if he goes and asks questions, there's a good chance he'll get some responses.
Not like the OG FNet Linux channel where they beat you up?
I mean, so I hang out in both of them, but mostly Discord, and I'd say we try and positively help people. Yeah.
My name's Scott. The generations thing, would it be correct to assume that those, when you apply that, that's atomic?
Yes.
So if I had a very long list of configuration changes, it's an all or nothing?
Yes.
Okay.
Or you'd have to stage them up as separate switches. Do part, switch, do part, switch. Yeah.
And if you have one that fails, does it create a generation for that, or does it just not?
No, it won't apply the config if it fails to compile.
Okay, on the build step. Okay.
Yep. Yeah, that's one nice thing is you get to build before you apply.
We have time for one more question, and I see typing in Slack, and I kind of want to prioritize Slack. I wonder how fast this person can type.
And for those of you who are here, I'm happy to talk after this too. I'll be hanging around. So.
All right, well, they're not typing fast enough. I'm going to call it. Big hand for Adam. Hit him up at the conference.
Thanks.
And Thomas Hancock to the stage. Thank you, sir. Yep. I hadn't even heard of it before.
Now you have.
Yeah, very interesting.
Woo.
Test, test. Test, test. Test, test. You muted this one? It's green when it's on, right? Yep. Okay. This is for you, Thomas.
Thank you. So, wait, how do I clip it on?
Well, you can use this clip. Or you could use your lanyard.
Oh. Hello.
Ms. Him has it muted.
Oh, okay.
I get it, if I may.
A little bit closer.
Yeah. Probably about there would be good.
Okay. Make sure it doesn't like slide on the lanyard. Okay.
You think that's good, Sam? Kind of to the side.
All right.
Oh, so Thomas, you are an artist, and you are going to be talking about Linux. If we're good on the video feed, give us a thumbs up, Sam.
It's an 800 by 600.
Often that's non-native on projectors.
Oh, I guess I could try 1024 by 760.
That's usually safer. Do you know what the native res or your ideal res would be?
I think it's 1920 by 1080.
Probably can't do that on that tiny screen. Can you output 1920 1080?
The most I can do on this box is 1024 by 768.
Yeah, you can't go 1080p.
possible to plug it into like a different sort of monitor setup or something?
I will.
Because I do also have a projector.
Well, Sam is live streaming.
Oh, yeah.
Folks at OLF always like to have the most complicated technical setups.
Okay.
A lot of other technical conferences, it's like non-stop MacBook Pros. We like to do the complicated stuff here.
I'm glad to hear.
Is this box ours or Thomas's?
Oh, that's fine.
Okay. So it's just a HDMI to VGA adapter?
A VGA to HDMI.
Seems poorly seated.
Yeah, it's because there's no actual mount points right there.
Got it.
You know, them trying to be innovative and try to thin everything down.
I can't get it quickly. Do we have any other HDMI to VGA adapters in?
To VGA?
I have it, but it'd take me 5 minutes because I'd have to run across the...
Yeah, mine's in the coat room.
Ditto. I think it's probably his adapter. Oh, yeah. Just by chance, do we have any HDMI to VGA adapters in the room? We have one, but it'll just delay us if I have to go get it. HDMI to VGA adapter? Yeah. Weird request. What's this VGA thing? All right. Do you need this right away? Can you start without it? Or?
The whole presentation's on there, including the demos.
Okay, we're just going to get a little bit of a late start on this one due to technical issues. I'll target ending on time, so we might just cut into Q&A. I'll leave it to Thomas to manage time with his presentation, and we'll make the decision. Pardon me, I need to run and get an adapter. we be able to get this screen on the projector? Excellent. All right, big hand for Sam. He just performed a miracle. I thank you all for your patience. We should be able to keep the schedule on time. Thomas Hancock went to Muscombe University, probably pronouncing that wrong, with a double major in business marketing and digital media design. Common background for folks here at OLF, right? Well, Thomas began using Linux when he was 12, so I suspect he can get as nerdy as the rest of us. Today, he's going to be talking about Linux and how it can help artists be effective at their skills in building art. Big hand for Thomas.
All right. Hello, everyone. I gotta say, first and foremost, thank you so much for getting this all set up. I guess buying a crappy Chinese converter off of eBay doesn't really always work the best. Today, I'm going to be doing a presentation on using Linux as an artist and reasons why you should. And I'm going to be doing this entire presentation off of a 2009 EPC. As you can see, we have a first-gen Intel Atom with only 2 gigabytes of RAM and, yeah, a 32-bit processor. So that's what we're working with here. So let's get started out. How do I get to? Okay, so as I just said before, my name is Thomas Hancock, and these are the outstanding advantages of being a Linux-based artist. So, who am I? As said before the introduction, I am a graduate from Muskingum University. I double majored in business marketing and digital media design. I also work at a company known as Associated Graphics. We do wraps for cars and also fire trucks. And finally, I run my own independent record label known as Tom's Coffee Records, or TCR. I usually like to say TCR because I feel a little bit egotistical when I say Tom's Coffee Records. But I digress. I also am a part of CSCA, which is a collective of graphic designers in Columbus. And I recently got a grant from the Greater Columbus Arts Council. But, above all, I am a Linux user. Now, you might be wondering, how the heck does an artist become a Linux user? That's just such an odd combination. Well, I kind of had an odd start. Back in the day, when I used to browse the web and all that, I grew up on the internet. It's such a great place out there. Great with quotes. So every time I went to a download site, I go through freeware downloads all the time, trying to customize everything. And I always saw little tux icons popping up on all the software. I was wondering, what the heck is that thing? And I also had a little bit of a lack of understanding on how to, quote unquote, share software online, if you know what I mean. And the free label that I saw on a lot of Linux distributions really caught my eye, and it sounded really cool. And around the time 2011 or 2012, it was known to speed up your computer. And I also should make another point. Around 2011 or 2012, I also got my very first CD of Ubuntu 11.04 from this very conference. Now, this was my very first desktop. It is using Unity. I know there's some people rolling their eyes right now. And this is my desktop now. Now, it looks like a downgrade, but I'm going to get to that in a second. This is my current setup right now. Over there, we have a Wacom tablet and an Apple Cinema display. They're both connected in a very, 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 very janky setup. Right here, we have a VAIO PC. Under it, there is a Dremel hole where the PCIe port is, so I could connect a eGPU to it, which right there, I think that's an RX 580. But nevertheless, please don't do this. This is a fire hazard. Just please, please, for the love of God, do not do what I am doing right there. With that said, nevertheless, how did Linux get into the world of my designs? Well, first and foremost, it was it really optimized my workflow for rendering and processing stuff such as 3D models. It allowed me to lower the cost of utilities used to produce and make art. And it also extended the life of useful yet older components, e.g. this EPC right here. But I'd like to condense this down. So I'm going to cover it in several objectives. We have techniques, compatibility, programs, projects examples, and how you can get started yourself. Now, let's begin with techniques. So again, I should preface this. These are all how I went about it. There is many different ways you can slice an apple. You know, you probably can find a way that might work better for you than I found for myself. But this is how I found things, at least in my own way. An operating system sometimes can actually make a difference. And if you are aware of some package managers, sometimes things break a little bit more easily in some, and some don't really break that easily in others. And so with that comes a little bit of a complex level of just like manually doing things and yada yada. But it is important, from what I have understand, to choose something where the least amount of choice is hindered. So in our words, more options would equal a more tailored operating environment for your own digital design work. Another note is you should probably choose a window manager over a desktop environment. And I'll get to that in a second. If you aren't really that familiar with Linux, I would suggest using a desktop environment to just get yourself acclimated. I wouldn't really suggest going straight into something like IceWM or Window Maker just straight up. But you know, if you are new to Linux, choose something lightweight. So what are some recommendations? If you're just starting out, I would suggest something like XFCE, Unity, maybe, or LXQT. If you're getting a little bit more into the weeds of things, I actually still use some of these, even though they're not as complex. I would suggest something like IceWM, Trinity Desktop Environment, or Window Maker. IceWM is probably my favorite, though. But most difficult, in my opinion, but I will say this, it probably offers the most performance. Something such as Ion 3, Waimea, JWM, or FVWM. There's a lot of stuff you can customize. However, it's very, very manual work to really set it all up. But also with that comes operating systems. Now in the past, I would have recommended Ubuntu, but at this point in time, at least when I've tried it out and installed it on some PCs, it seems to have a performance that's similar or comparable to Windows 10 or Windows 11 right now, when it's not debloated at all. So I really don't feel comfortable recommending that. However, if you are just starting out, I would say something such as MX Linux, Debian, or Linux Mint would be a great place to start. Getting a little bit, again, more into the weeds, Void Linux, which actually I'm using right now, or Dev1 would be a good place to move from there. And then finally, if you really want to get more difficult and really manual, actually, I should preface this, Artix can be a little bit in the medium category when you're installing, but it's not as stable when you're doing, even if you're going to go through a graphical install, it's better to have a LTS kernel under Artix, but Artix or Parabola would probably be the more difficult. However, if you are using Gentoo, you probably already know everything I am going to say and everything I will ever say, so you probably don't even need this even need this presentation in the first place. Now, let's get into compatibility. So, one of the first things I wanted to talk about is device support under compatibility. Printers, drawing tablets and displays, and GPUs, besides NVIDIA sometimes, and architecture are all different things that seem to be very easy to set up under Linux. So starting off, let's talk about plug-and-play devices. Some display converters may not work immediately under Linux. For example, I had a StarTech adapter that converted DisplayPort to DVI. And it was some odd sort of DVI standard, but it worked immediately under Linux. However, when I booted it up under Windows, excuse me, it would not even show us something on the screen. Stuff like that usually is automatically detected upon boot. And things such as drawing tablets can also be automatically detected by the kernel, unless your kernel is custom, e.g. Gen 2 users. Now, moving on from there, let's talk printers. So this is probably one of my favorite parts about Linux, and it's one of the easiest things to set up. So it's like, it's really great, but there is a thing when you install Linux known as CUPS, also known as Common Unix Printing Service or System. I can't remember the last, whether the last two words, which one it is, but it will not always be installed by default. However, it will automatically recognize a printer once a brand-related driver is installed. But what's cool about that is when you install a brand-related driver, as an example, HP Lip or CNIJ filter, unlike a Windows driver where you will probably have to set up like 200 megabyte files that have like probably 1 or 2 printer drivers in it, this will install the entire line of that exact printing manufacturer. And finally, this is my favorite part of all the favorite parts I just mentioned, is support for legacy devices. So this actually means I can use a printer like this from 1998. And you might be wondering, that's completely obsolete. Why would you ever use something like that? And the reason for that is actually because of DRM. Most of the printers these days have their chips, so you cannot install ink yourself, or you have to apply to a subscription service. And I can get into a rabbit hole on that. But with that said, printers as old as this one right here will automatically be recognized by Linux, and they won't be recognized by Windows or Mac. And you can like easily refill the cartridges of these and never have to actually worry about having to replace them, unless like the printer cartridge head fails. But at that point, it's like only like $12 for a replacement. You can just get an empty cartridge. But that's what's really cool. Like, these printers can get a second life, and it also allows you to create less e-waste in the process. But moving on from there, let's talk video drivers. Video drivers from even 20 years ago are still supported under programs such as, what is it called? Mesa Amber. And so as an example, I think I was talking about this to someone else in the hall, but devices this old will, like, let's just take the Trident Cyberblade, will be detected by default when you boot up. And it's really nice and comfortable when those devices are still supported. So you can use like a laptop from like 2001 or even older, definitely older than this. It was only recently actually that Linux was even considering dropping support for i4086, but I mean, I don't know where it went from there, but from what I know, devices even as old as i586 are still supported. And with that, you can also get the most up-to-date software. So with that, talking about software, let's actually move into programs. So first and foremost, I want to talk about the program Blender. So Blender is probably one of the most popular 3D modeling programs that we have today. Like, movies that are made today are using this program. If you go to an art school, one of my friends even said it's like an industry standard at places like Savannah College of Art and Design to use Blender. It has modular plugins, so you can download stuff from their store, or you can add things in, and there's different types of open source rendering options, such as Radeon Pro Render or cycles that you can add into it to model with it. And this is the really, really cool part. It can compile for your specific system. So even some 32-bit hardware, such as this computer right here, can support it. And I say in some cases because it has, even though it might support your processor, it might not support your graphics card. So my integrated graphics probably wouldn't work with this, and I'd probably have to get an eGPU that would create another fire hazard. To move on from there, we also have the program LibreSprite. Now, LibreSprite is actually based off of ASprite, and it offers animation support and is a really great pixel art program. I'm actually doing a recent project I'll talk about later with this program. So it also tries to implement newer features while keeping open source. So it's a really great project to see after ASprite decided to close their doors. Then we have color calibration. And this is something I also find really cool. So there is the program XICCD and ColorD. And these two programs in tandem will allow you to set a specific color profile on your monitor. So as an industry standard, most of the time it's important to use Adobe RGB 1998 because it was heavily studied to make sure the colors were as accurate as possible to whatever you print out. So with that said, you can actually set up different color profiles on different monitors as well. So it doesn't have to be the same one on each monitor. You can also, it's just really cool. And it also starts up directly with Xorg. So with that, I'd like to also do a couple demos. I was going to do these with my graphics tablet, and I tried to remember it. I brought the pen. I brought the actual cable, but I did not bring the actual tablet itself. Now, I'm going to try to do this MS Paint style like a third grader on this thing right here. So let's go into some of the programs. I'm going to start with a program made by a good friend of mine known as CSprite. This was, I got to say first and foremost, the developer of this is amazing. He has really great communications with everyone who submits an issue to him. I remember I had a little issue where it had an out of bounds where I would draw and it would crash with out of bounds. I submitted that to him within a couple hours. He fixed it. He is a phenomenal developer. I will say that right now. In this program, you might be wondering why it's called CSprite. It is developed completely under C. Now, what's cool about this is it allows you to input custom palettes. So if we go up here, let's see, palette. We have some palettes that people submitted right here. This is CC29. Let's try to draw a little, actually I'm going to go up a little bit on the brush size, a little happy worm. If we go around here, I just need to scroll upward and it will increase the brush size. If I want to zoom out, I can hold down Control and it will zoom out, and I can just add a little smile right here. Oop. We'll get into that in a sec. And I can draw a little, let's make sure his smiley face is all the way visible. Really happy guy right there. He's really glad to be here. And yeah, so you can set that all up. I actually, on one of my projects, I used it to make a t-shirt, and it just worked fantastic. So if you have time, I would definitely check out the project. It's by a developer known as Pegvin. So yeah, definitely check it out. It's a really great program, and it compiles really quickly. But now let's move into probably one of my favorite programs. I've done so much on this over time. And it's kind of funny how I found out about it. I was just reading a thread, and it was just like a bait thread online. And it was for I think it was for GIMP or whatever, and people were like, oh, Krita's better. And I was like, I don't even know what Krita is. I looked it up, and I tried it out, and I just love it. But we're going to try a sample, and a little preface. I love to work on projects and art pieces based off of internet history or internet figures of some sort. This is a character known as Magichan. Now, if we open it up, I heard that from back. I think some people know who this is referring. Perhaps. Now, if we go into the color selector right here, what's really great about this program is it works under here. I think this compiled within a day. It took a little long. But if we color right here, you can see it's similar to what you would see in Illustrator or something you would see under Photoshop. Because actually, I should mention this too, it imports Photoshop files such as PSD files into it too. So it's really great in that regard. But unlike Photoshop or GIMP, it's designed particularly around artists. So even if I go under settings, there's color profiles I can set for this specific application. And let's just do a little thing here. Let's just say I put this little blob here. If I want to color within that specific blob, I can click this little lock right here. And let's make an awful graphic design as my patch in color that is inside that other color. And you can see it goes within that actual blob right there. Now, what it also does, if I was to show my graphics tablet right now, is it also has pressure sensitivity right out of the box. Under Windows, I've tried this. It's really annoying because under Linux, under Windows, if you hold down too long, it will pop up like a little question mark and ask you a bunch of little questions and get you out of the immersion of creating your art. So it's a fantastic utility to just get into. If you have something more advanced like that Wacom I showed earlier, excuse me, it will basically allow you to turn around the pencil and erase with the other side. Now, let's actually move into some of the projects I have done in the past. So these are done mostly using programs that I have shown you here today. My first one is a shirt I made known as Pixel Bros. This was made under C-Spray and admittedly Illustrator. I'm still trying to learn Inkscape, but I really haven't gotten around to it. I need to make an effort for that, but once I start learning that, it should make it a little bit easier. But this was created by making sprites under a gray and black, a grayscale color palette, and then printing it onto recycled thermal paper from receipts. And then from there, we placed it in a rectangular shape and printed it onto a t-shirt, as you can see here. It was a really cool project. But moving on from there, it was also completely manually sublimated using sublimation printers. The next project was a dedication I made to the artist Kazuki Takahashi. He was one of the artists who worked, one of the main people involved in making Yu-Gi-Oh! Back in the day. Now, this was completely made under both just me manually drawing, scanning it in, and then I did everything else, the shading, the coloring under Krita. So this is the first result. You can see in black and white. That was the initial scan, and at the end, that is what I got by the end of it. Now, these are some projects I am still working and are in production. First and foremost, these are some album covers I've been working on. This is the first one. This is for an artist known as Pingapong64. This is done using Krita, and I did a bunch of different filters and all that, but it's supposed to be industrial power plant. And the second one is known as Cloud Replica. I try to use a grayscale and black and white color palette with my album artwork to try to keep a consistency under. So when you line up the albums, they all kind of look consistent. So I try to keep everything black and white. But this is the album artwork for soon-to-be-produced Cloud Replica. I was supposed to have it done yesterday, but still need to get some stuff underway. I had some issues with the printer. But yeah, I did that under Krita as well. And then we have, this is one that I'm really excited for because it's almost completely done under open source software. This is a reimagining of scientific illustrations. And what I'm doing with this it is basically a T-shirt that will be made from scientific illustrations from like the 1800s and early 1800s and early 1900s, where we have some fish, and some of them look obscure, or they have an odd sort of illustrator who created them under the scientific illustrations. And what I wanted to do was recreate it, and then try to 3D model it, and then create a pixelated skin that would go over the 3D model. And then that will be rigged onto it and then put onto a T-shirt. I might also make a video too, like as like an introduction when it's created, but this one I'm really excited for. And with that all said, how can you get started? I would say, first and foremost, find a slower computer you tend to use less. Reinstall your OS, whether it's Windows or Mac OS X, but instead of installing it over the complete hard drive, partition it so you have one half for your system and one half for your Linux system. Start with something like Debian or Linux Mint and install that on the other partition. And until you start feeling comfortable with things, just keep on switching back and forth. Try to use Linux more, but with the programs you feel like you're most comfortable with, and when you feel more comfortable with other things, just keep on testing the waters until you feel comfortable. And when you feel a little too comfortable and used to things, it might be good to switch it up. Try something a little harder to challenge yourself, and then go on from there. And that's what I would suggest. It's really great to constantly learn. That's one thing I've learned as an artist over time. And with that all said, thank you for listening. If you guys want to reach me, my QR code's right there. The website is right there. And I am completely open for questions.
Do you have any audio to share or show us?
Audio? Oh, I don't make music. I wish I could. That's the thing. That's actually why I created a record label, because I can't make music myself, and I love music to death. So I want to try to help out artists as much as I can who are musicians. Anything else? Yeah, that's me. I try to be resourceful with my lack of materials, so it's me and a close friend of mine. Yeah.
Do you have suggestions for physical setup on the drawing tablet? For instance, I believe yours was set up that it looks like a actual monitor setup.
Yeah.
It is vertical, so your hand will drop instead of a lot of the tablets out of the box. They're set up to kind of be on your desk, so you're going forward and back, which isn't intuitive if you've learned to paint.
So if I'm getting what you're saying is how you position a tablet parallel to the screen so it feels more intuitive. Okay. Well, there is, I would say first and foremost, I found it most useful for me to use like a Cintiq since it's the screen and that, but I can understand spending a little bit less. If you were to do that, if you have it tilted on the side, like kind of just like at an angle right next to the monitor, it kind of helps your hand kind of feel like used to the strokes and all that. But yeah, hopefully that helps. I can definitely talk afterwards about other things. Oh. Oh, so that friend I actually showed earlier who was modeling for the T-shirts, she was one of the people who went to Savannah, and she has like this ethereal knowledge when it comes to Blender. So she taught me, sent me a couple tutorials one day. I was going on a long car ride, and I decided to go through it, and I started to get more and more of a better understanding of how to use it. And then from there, I also just picked up some things along the way, you know? That's the great thing about YouTube and all that. It just has so many different ways you can learn a different program. But yeah. Those shortcuts. Oh, one thing with that, I don't know where they make them, but there are some like overlays people get where they put them over the actual keyboard and it shows you exactly what keys go to what specific shortcut. It's really cool. I'm too cheap for that though. Well, thanks everyone for coming. I really appreciate this. This is a great opportunity.
I don't see Warner in here, but we will be taking a brief break between now and the next session. It looks like 15 minutes.
All right, I got this, Sam. Thanks so much. The other door was locked on me. I couldn't rush in fast enough. Waking myself back up. Questions. And our friends on the internet, please do ask questions in Slack on the main stage channel. Any questions in the room? Oh, all done then? Okay. I'll check online real quick. I heard the applause and thought Q&A was just starting, so apologies, everyone. Got it. I was corrected in my pronunciation of Muskingum. I might have to practice that. Have you had, this is Edward Davey, have you had any luck getting Wacom tablets to work on Linux?
Yes, actually I have. One thing, and this is what I was going to talk about too with older devices, it seems like the older it is, the better compatibility it has. So if it's at least like a couple years out of date, it should pretty much work. If you have some issues where, like, for instance, I had this issue where the pen would not really actually work. Actually, I can show this right now. I unplugged it. It might not work. I can try this. But one of the things that you can do to set up your system, let's just say you find a script online that shows you exactly how to set up the display so it connects properly, so then when you tap it on the screen, it doesn't go to the complete other monitor. What I usually do is I have a little folder that says scripts. I don't know if it's popping up. Oh, it is popping up. Sweet. So right here, I have a folder called scripts. And under there, I have a little set of different folders. And what it little files. And what these files do is if I well, first I do a chmod plus x, and then the name of the file. I type the code under there, and then whenever I feel like I need to run it, let's just say every time I boot, I need to run this so it makes sure it expands the display a certain way and detects the tablets a certain way. It will execute all that, and it should work pretty well. So definitely having a scripts folder set up for different display outputs and all that, that really helps out.
Awesome. Thanks, Thomas.
No problem. Sorry about the long answer for that.
A couple housekeeping items. If anyone has lost anything, we have an informal lost and found at registration desk. So just poke your head over there, share what you lost, and we'll take care of you if we have it. I think we're close to addressing our needs with the room block. A few folks have stepped up, but if any of you booked a room at the Hilton and didn't use our room block, please do let us know. We have a sign-up sheet at registration. We have to pay for those nights if they're not accounted for. So if you already booked a room and didn't use the room block, please do let us know. Or if you need a room, we still have a couple rooms available, and we can get it to you at our discounted rate that we negotiated with the hotel. So thank you for that. We will continue the program right on time at 4 p.m. Wow, it's almost 4 p.m. See you soon. Hello, Linux Fest. Everyone awake? You don't sound very awake. Let's try this again. Hello, Linux Fest. All right, that's acceptable. I won't do the tedious repeat exercise. I am pleased to introduce Zach Kohler. Zach is a chemical engineer, but noticing a theme here, he started programming in 3rd grade and begun using open source in high school. So he's been doing this stuff for a while. Zach started a narrative with his presentations at OLF a while ago, and this is the 3rd evolution of that narrative. So an exciting time today, where he's going to be talking about simulated AI hardware, a toy matrix multiply. Big hand for Zach.
So I've been a longtime freelance software developer, and my background is actually chemical engineering in college, but I've been programming for a lot longer than that. Some of my relevant interests to this talk are programming, electronics, and retrocomputing, and some of my irrelevant interests are running, cooking, and gardening. I got a house recently, and I've been putting in a lot of stuff around the house. So what we're going to talk about today is my motivation for why I'm doing this talk. I'm going to talk a little bit about the tools that I use, including a RISC-V CPU, Renode, and my own home-built operating system called Kohler OS, or Chaos. Then we'll get into accelerator hardware in general and kind of a background about how accelerators work and why you would need them. And then talking a little bit about how to describe hardware with code and how to simulate that code, Verilog and Verilator. Then we'll be implementing my accelerator and wrapping that up in an interface that can talk to Renode, which is the system simulator. And then, of course, if you're going to have hardware, you have to have software to drive it. So we're going to write the driver for it. It's a lot to do in 50 minutes. So why do a toy system? So this talk seeks to explore the line between hardware and software using a minimal simulated environment. So if you have something very, very simple, it's easier to inspect and understand what's going on. And if you have a full system like Linux, you may get lost in the details and how people are using in production. And so what I mean by a toy is something that we can inspect and understand, and it's as simple as possible. Some of the things you sacrifice with a toy emulator would be performance. You don't care about how fast it's going to run, and you don't care about having very intricate features. So you're going to be sacrificing performance and features for something that's easy to understand. It's also not a talk about practical topics, such as optimizing AI hardware or training or getting faster inference with the AI hardware. And it's also not about making you guys understand Verilog. There's a million tutorials about Verilog, and if this piques your interest, go ahead and play with those. But I do not understand Verilog well enough to teach it, and so that's not what we're going to do here. Abstraction. All of computer science is built on abstractions, and that's because simple interfaces allow for complex systems. You don't need to think about radios every time you send a text message, and this is a really good thing. If you had to think about that, you would never get anywhere. And so computer science is built on many, many layers, from your applications that you build all the way down to the lowest level where people are worrying about the exact atoms that they're doping onto the silicon to make a gate at a certain performance and frequency and a tiny size. And everything in between is someone else's job, and it's kind of the interfaces between each of these layers that one person can understand and become an expert in. And so my previous talk is kind of highlighted in the blue color. I talked about the operating system and how that talks to the level right below it, which is the CPU instruction set. And so I wrote in assembly language a little bit of an operating system and tried to understand how that works. And in this talk, we're going to go a little bit deeper through a couple other layers through the hardware interface and how you actually go from a data path, which is basically how you think about the bits in a digital circuit. How does that interface to a driver when you're writing software? Because at some point, you have to do that. You have to make that communication. So on my way to this talk, I've been playing with real hardware. I breadboarded up a microcomputer, basically hand-wired the RAM to the CPU and single-stepped it at 1 hertz and wrote a little program with switches and did 2 + 2 = 4 in machine code. That worked. That was fun. But I didn't want to write any larger programs than that. And then I also did a CPU emulator in Python where basically wrote the entire CPU in each register. You could see how everything transferred from memory into the ALU. You can add A plus B, and you get 2 + 2 = 4 again, writing back into memory. And then in 2021, I did a multitasking toy operating system, and that's what we're going to use to demo this hardware today. That's the chaos. So first you kind of need to understand what is bare metal. When you write a typical program in C, when you compile it, it expects to have an operating system there. You're going to allocate resources, such as memory, file system access. It's easy to open up a file and read from it. But if you run your compiler, say GCC, with -freestanding, it tells the compiler that there is no operating system. So you don't get open, and you don't get print. You're required to implement all of those yourself. And it's handy for when you're writing an operating system, you're responsible for everything. And so this is written in a bare metal style. RISC-V. So my CPU is a RISC-V CPU. It's an open instruction set, unlike x86, which is the Intel, or ARM, which is in all your phones. RISC-V is a new free and open instruction set. You can kind of think of it as the Linux of CPU instruction sets. Renode is the simulator that all of this is running on, and a lot of the power of what I'm able to do depends on Renode being a really great tool. They've done a lot to optimize this simulator for embedded. There's a lot of really good emulators out there. Most of you probably know it from playing games. But those are emulators where you're very specialized for a specific set of hardware so that you can play the game accurately, emulating the sound and the graphics. Renode, on the other hand, is made for embedded, and it's very extensible. So there's a whole bunch of processors that are supported, and you can even put your own processors in there with Verilog. You can put in your own hardware and plug it into the architecture. And so that's what we're going to do here. And then Kohler OS, it runs on a Renode simulation with a 32-bit integer only, that's no floating point, RISC-V CPU with 256K RAM. The only I/O is a serial port, and now there's the addition of a 3x3 matrix multiplier hardware. The operating itself is multitasking, which means you can run 2 programs at once, but there is no dynamic memory allocation. So everything's statically allocated, and all the programs and all the drivers are written and compiled into one binary that you load into the simulator. And it goes into memory and all runs at once under machine mode, which is basically kernel mode. So any process can, if it wanted to, overwrite other processes. That's kind of the trade-off you get for simplicity. You don't have those security protections at all. There's also a shell with foreground and background processing. So if you want to run multi-threaded things, it's all handled by the chaos shell. So now we get to the accelerator hardware. So how do accelerators fit into a system? There's 2 main ways that an accelerator can fit. One, you have CPU instructions, and on the other hand, you have coprocessors that attach to the system bus. A CPU could be as simple as a floating point accelerator. So most CPUs, when you tell a C compiler that you're creating a floating point variable, the reason you need to know that type is because you have to tell the CPU what this set of bits means. So whether it's a 32-bit float or a 32-bit integer, the CPU multiplies them differently. And so that's one type of accelerator, is a CPU instruction. You can also have vector instructions where maybe you load in 512 floating point values and multiply them or add them with another value. And then you say, multiply, you do one instruction. So it's multiple data with a single instruction. And then the other kind is a coprocessor. This is where you attach to the system bus, and it can run code of its own. So a good example of a coprocessor would be a GPU. You load code onto it, known as a shader, and it runs code all on its own, and you just pass data to it. And while the CPU is doing something else, this coprocessor is cranking away and doing computation. And so the two examples here, if you're looking, the accelerator is going off of the system bus, and the CPU accelerator is within the CPU. So examples of the system bus accelerator is like a GPU or a tensor processing unit. That's like what Google uses to train their AI. And basically, you load that up with the same code that you're going to be doing over and over and over again, and it can process the data. It can even access memory on its own while the CPU is doing other things, loading up maybe a new inference. And then in the CPU, it always requires a CPU in the CPU cache to go through main memory itself and load something in and do a instruction. And so some aspects of accelerators, they could do direct memory access. What that means is, just kind of as I explained, the processor could be on its own and talk to main memory. It can step through the calculation in multiple cycles to figure out the answer to the whatever question that hardware is trying to solve. It could even require firmware. In addition to the software that you're loading onto it, it may have some software that you can't even access or know about within that piece of hardware. And sometimes you push your software to it. That's a shader for a GPU. Most accelerators, I would say, leverage hardware to speed up computation. And some of them could be packaged as a CPU instruction. And some of them talk to the outside world. So a GPU is a special kind of accelerator that's also an I/O device. And the data that's going through the HDMI is never touching the CPU. It's completely in the hardware. That allows you to very quickly, play a movie. You pump the compressed bytes over to the GPU, and the GPU only talks to the HDMI. That's why it's easy, that's how you're able to play such high definition videos that are compressed and do the decompression only on the hardware. And then some really specialized accelerators could reconfigure themselves even in the hardware. And so what I mean by that is if you have an FPGA on a piece of hardware, you could write software that could tell the accelerator card to change the way that its gates are put together. And maybe instead of doing a matrix multiply, you're doing some other matrix operation or some other vector operation. And I just wanted to talk about the RISC-V vector extension a little bit. Most people are familiar with MMX and AVX. Those are like the multimedia extensions, Intel called them. But in general, they're just single instruction, multiple data approach to accelerators. And so if you want to run a game and you are rendering a three-dimensional world where you have a bunch of different vectors and you're trying to create a frame buffer from those vectors, you're doing the same math over and over and over again. All that's changing is maybe your character's location, and then you're reprojecting all those pixels over and over and over again. And so what you do is you put the big array of the data that you want to act on into the memory of the into that instruction, and say, put those 500 bytes in there and execute only once that multiply. But the thing that makes the RISC-V special is that depending on the hardware that you want to use, whether it's like if you're going to do acceleration with NVIDIA or you're going to accelerate it with MMX or AVX, it all requires different code. So like AMD has their own set, Intel has their own set. There's some overlap, but they all require different machine code for that to work. And so it becomes complicated for the compiler writers. What RISC-V did special here was it allows you to write one binary code where you just tell it, this is what my data looks like, this is the operation I want to do. It's almost declarative, but at the hardware level. And then you can throw all different sorts of accelerators at it from the hardware side. And if you put a bigger accelerator on it, it'll just run that same machine code faster. So it's kind of future-proofing you and allowing you to run the same code. You don't have to worry about which binary do you load onto the system at runtime. It's a single binary for the whole thing. And so why did I pick a matrix multiply to be the toy example for this talk? Deep learning is a lot of matrix multiplication, and it is the main reason you're seeing lots of TPU hardware out there now. All these data centers, when you're talking about ChatGPT, it's doing lots and lots and lots of matrix multiplication. And so it's the first thing you think to do when you say, I'm going to make AI hardware. And so I just wanted to show, I'm not going to explain this, but when you're doing matrix multiplication, you have these vectors of numbers, or matrix of numbers, and to multiply them, you're doing a bunch of little multiplications and then adding them together. But it's always the same operation, it's the same grid. And so it's very, if you're going to do this with software, it requires a lot of looping, but it's simple enough that you can do it with hardware and accelerate that where it all runs at once and you get the answer out more quickly. So that's the approach we're going to take. And then in the real world, when you have a matrix that's bigger than a 3x3 or whatever size your accelerator is, you can still accelerate those using a smaller hardware. So you use this thing called block multiplication, where you break down your matrix into a bunch of smaller matrices and then use the hardware on this piece, this piece, this piece. And it's actually the same stride that you're doing with regular matrix multiplication. You're just doing it at a bigger level, where you multiply all these submatrices and then add them together. And you just have to make sure you multiply each part with each part. And if you do the math, you basically use software for the block multiplication, but still use the underlying hardware at the bottom. So simulating hardware, to actually get this to work, we need a couple of tools. So I already talked about Renode, which is basically our emulator level. That's like it takes an image and it takes our description of our hardware and makes a virtual version and a virtual CPU. It's like our emulator, like our virtual box. But then to do the virtual hardware, we need to describe how those wires and gates are. And for that, we're going to use a language called Verilog. Verilog can describe the hardware, but it's not a simulator in itself. So that's where we have Verilator. And then we're going to use a protocol called Wishbone to integrate the virtual hardware into the software system. So what is Verilog? It's a hardware description language. It's used to describe and simulate digital circuits and systems. And so it could describe everything from a very small piece of hardware all the way up to a full CPU. Unlike Python or C, it doesn't run in order. It basically describes you have these wires, and the and or of these will be output onto this wire. So it's describing the gates. And the main use of Verilog is to describe the hardware, and you can actually synthesize it. You can simulate it, but you can also take this directly to hardware and tell someone who's going to make a chip, take this Verilog code and create real hardware from it. So it's used in real hardware design. Let me grab a water. I should have done that before. Sorry, it's making it impossible to think. All right. So if you look at this bottom here, this is a description of a half adder. You have these two gates, and you have two inputs. You have A and B, and then your output is the sum. And you also have a carry bit, because when you add 2 bits together, you can get up to 2 bits out. And so what this is showing is if you put a bunch of these together, you can make a full adder of some length. And to describe this hardware, you have this little bit of Verilog code. So if you know that CPUs are made up of a whole bunch of gates, you can imagine that if you scale this up, you can describe digital hardware at very large scales. But this is the only example of Verilog I'm going to show. I'm new to Verilog, and I'm not going to teach Verilog. And so Verilator, how does it work? It takes that hardware description, and instead of compiling it to hardware, it compiles it to C++. It actually takes that Verilog code and outputs a bunch of C++ source code. Then you can use an open source compiler like GCC to compile that down to a program that executes on your native system. And so what I'm doing is taking some Verilog code, compiling it to C++, and then compiling that C++ down to x86 machine code, which runs on my laptop. Renode also runs on my laptop. So what we need is a way to allow Renode to talk to this other binary. And so the way I describe my system is basically in the Renode platform. We have our RISC-V CPU. We have some amount of RAM. We have our little serial port that's the UART. And that teletype that you see connected on host PC, that's my interface to my system. So to give a sneak peek of what that teletype looks like, on the right-hand side in green, this is Renode running. And on the left-hand side, this is the terminal interface for the operating system. And so if we start up Renode, what happens is it boots, and you can see the shell if I ask what commands are available. And so this is the teletype that you're seeing there going through the serial port. And then, of course, there's the matrix multiply hardware. So earlier, I set up a really long slide talking about everything that a accelerator could contain. I've crossed out everything that mine does not. So the three quintessential things that I thought that would be useful for understanding a very simple hardware is that we step through in multiple steps in the calculation. We leverage hardware to speed up computation, and I chose to attach to the system bus. I did this because it's simpler to write a driver for that. Now, the ones that attach to the bus can be very, very complicated, like a GPU, but they don't have to be. As you'll see, they could just be a location in memory with registers that you write to and read from. And actually, let me dig into that here. If you look, this is matrix multiply 3 by 3, and then you have this hex value. That's the address that I've mapped it to in memory, 3800 or 6,000,3800. That's a hexadecimal address of where I placed it in memory. And then you see some offsets, +0, +9, +12. What that's showing is the +0 is a space in memory that's 9 bytes long. That's the 9 bytes that represents the 3 by 3 matrix. So you could think 3 by 3, that's 9 values, so they're spaced 9 apart. Why is it 12? It's because it's hexadecimal. It's actually still evenly spaced. It's not a typo. You can see on the far hand side, it's labeled A, B, C. Those are the 3 registers that we'll need to use software to address. And so how did I make a toy matrix multiplier? Well, I borrowed someone's. There's a huge library of open source Verilog components, all the way up to processors, system on a chip, all sorts of different I/O devices that you can use to kind of mesh together and make your own hardware. You can make your own systems on a chip. And that's what I did. If you see the interface for this matrix multiply, it's purely electrical. It didn't have an easy way to talk to Renode. It doesn't know anything about memory buses. But you see it has a clock input, a reset pin, an enable pin, and then these 2 inputs called A and B that are each 72 bits. You see why it's 72 bits? You have 3 by 3 by 8. So you have 9 values, and then each is 8 bits, because they're 8-bit integers. And so that's 72 bits of input for each matrix. And then you have 1 output register and a done flag. And so you could think of this as a chip, a little dual pin or dual inline pin IC, where each of those is it would have to be a lot more than that actually, but you could think of it with three input pins, and then A and B are each 72 input pins, and then the C is another 72 input pins. So it's all parallel access, it's not serial. And then the done flag would be 1 more output pin. So it's this piece of hardware that you could sit there, and if you gave it electrical values on A and B, and you would hold enable high, and then step the clock from high, low, high, low, high, low, electronically, eventually that done wire would change from 0 volts to 5 volts, and you could read out the answer to that matrix on the hardware. This is a bespoke electrical interface, and you could wire it up and actually do this on a breadboard. But we want to talk to it with a computer. And so what we do is we wrap it in an interface called Wishbone, which is what's on the right. That's what Renode understands, and it has software that talks in a Wishbone protocol. And so basically, it does the memory mapping for me. I use a little bit of logic. So this is all the Verilog I wrote. It's right there. It's the wrapper between the real matrix multiply and the Wishbone interface. And it says, if we have the right enable pin on, then either A or B memory locations are valid. And then if we don't have write enable on, then the C is valid. If you don't have write enable, that means you're reading. And so we're either going to be writing to A or B or reading from C. And then I wrote just enough Verilog to map that memory address from the Wishbone protocol to that electrical hardware on the Verilog. And now it speaks the same language. And this is how people integrate systems in the real world too. Maybe they don't use Wishbone, but they use some standard bus, maybe AXI, where all these little off-the-shelf hardware components can talk to one another by saying, okay, if I'm reading and writing now, you're not reading or writing. So the CPU kind of controls the flow of that. And that's how we get the memory map. I tell Renode, put this wishbone mapped at that 6 billion 3800, and then the offsets are dictated by my wishbone interface. One other problem that Wishbone solves is the timing. Remember I said if we were to breadboard up that matrix multiply and we held the pins, you put the values for A with 1s and 0s, you put the values for B and 1s and 0s, and then you toggled the clock high, low, high, low, high, low. There is you'd have to do it a certain number of cycles. And so in the Wishbone protocol, it tells the CPU to wait until the computation is done. Basically, there's an acknowledge flag. If you look, the second to last one, the last one's error, and the second to last is acknowledge. And you can let it step through a complicated calculation with multiple clock cycles, and until you acknowledge it, it's not going to tell the Wishbone, the controller for the Wishbone, it's not going to say the calculation's done. And so what you see here when I added some debug code to my Renode simulator, as I'm writing the bytes, you write a byte, each takes 1 clock cycle, but that one that takes 32 clock cycles or 31 clock cycles, that's when I did my first read of that C buffer. So basically the 3x3 matrix multiply hardware was sitting there clocking high, low, high, low, high, low, and it's going through the state machine of all the different buffers and registers and wires and gates, pumping this logic through, multiplying those numbers, and when it's ready, I throw the acknowledge flag. The system is allowed to read that memory, and then all the subsequent bytes come through quick because the done flag is still raised, and the number's ready, so we just read it all out. There's much faster ways to do this and way more convenient or way more performant ways to do all of this instead of writing byte by byte by byte. But for simplicity's sake, that's what I did and it works, at least for understanding how to write a driver. And so most people don't think about writing drivers, but a lot of people in the Linux community do, or a lot of people that work on Linux, almost all that code is driver code. And so it's kind of important to understand what are drivers. And so this kind of shows what drivers are at the lowest level. It's a specification for writing your software to interact with actual hardware. And so sometimes the compiler handles it for you. Like my CPU does not have floating point hardware, but it can still do floating point math. It just uses integers to do it, and it loops and loops and loops and does whatever it needs to do to get a floating point divide done. And the compiler does that for me. I actually had to add a library in. It's built into GCC. It stubs in a little floating point divide for you based on integers. Sometimes there's a framework that handles it for you. Think OpenGL or DirectX. You're writing these high-level commands towards this library, but under the hood, they're creating these shaders and packaging off to the GPU, and then you get back your frame buffer. And sometimes it's a custom binary that's like a one-off. So think consumer hardware that's like not necessarily a standard computer. You buy some widget like a Bluetooth headset or a microwave. They have a microcontroller in there, but they have a bunch of other weird little hardware. A lot of it's prepackaged at this point, but they are writing code bare metal with no operating system, often is with no operating system. It's saying, if the door to the microwave is open, do not allow the magnetron to turn on. And it has to do that by, there's little registers mapped into memory where they're reading, is the door open? And then it says, if the door is open, loop back around and say, okay, turn off the magnetron. And that's how all those little hardware work. And you call that embedded development, but really you're driving the hardware with code, so that's a form of drivers. The way we're doing that today is we are going to write a custom implementation to do our matrix multiply and give the software developer a nice interface to do their multiplication. So the first thing you'll see on this slide is a type-def struct. I call it map-mall. It has the three matrices in there. They're a pointer of pointers, and it's this memory location represented by that struct. And so a software developer, me, in the next function, use that to read and write from that memory. This is the most absolute naive way you could write the driver, but we pass in these three matrices to this function, hardware matrix multiply. You have A, B, C, right? These are all inputs to the function, but the C is an output variable. And so the first loop loops over and writes the matrix that you pass in. It writes it into the hardware. Then when you get into the second loop, we're reading from C in the hardware and pulling it back out. So like I said, we just put those numbers in there one by one, each integer, and then we pull them back out. The very first read in that second loop is the one that waits and cranks 32 or 31 steps, does the matrix multiply, and then lets you read out those bytes of the actual result. And so now any software developer, I would give you a software development kit. There's a library. You could just use hardware matrix multiply, use it, and now your computation runs faster than it would if you were to just write the naive loop and do the multiplication. I also have an identical version called software matrix multiply. That's what I use to check my answer. And you can imagine in a scenario where you're deploying software to customers, if you could check, you could say, hey, hardware, multiplication hardware, are you there? And if it's there, you can use it. And then if you don't, you just stub in the software version. So you kind of ship in your library software stubs for the hardware so that your software doesn't crash, just runs slower. And that's the same approach that GCC used. Okay, here's my live demo. So on the right is Renode, and I already showed you, I brought up the basically the shell for chaos. If I run the Hello World program, it just echoes Hello World. And so the two that we're going to test today are V and M. So the first one is the Verilator matrix multiply test, which is kind of a test suite of a couple different matrices. And you can see I just did a couple different examples where you're multiplying A times B. This is the expected C. So the first with the expected C, that's the software implementation, and then the last one is the actual hardware, and it checks to see, okay, is that correct? Let me run that again. I don't know why it truncated that. Hopefully it doesn't do it again. Okay, there. Now we have the full C matrix. So what this last example is that block multiplication. It takes 81 separate hardware calls, and then we use software to fit that together, but we're actually accelerating a 9x9 matrix with the 3x3 hardware and proving that that can be done. Oh, yeah, I forgot. There's also M, multiply your matrices. Quick, does anyone have a favorite hex number? Okay, let's do 1, 2, 3, 4, 5, 6. Okay, dead beef cafe. Okay, now let's just, and final B. Okay, and it works. Can someone check that? So we went over why do we explore this line between software and hardware. It's a line people don't often look at when you're trying to get something done at work. You want your application to run, and that's what you care about. You don't think about all the horrible stuff that happens underneath. But sometimes it's good to ground you. It's kind of funny that as AI gets smarter and smarter, there's actually less and less software between a human and computation. When you're using these large language models to get an answer out, there's many fewer layers of software than, say, a Google search. You could run that on one computer. Google you cannot run on one computer. We talked about the tools that I use to run this simulation. We talked about accelerator hardware in general, and different ways to attach it to the bus. We talked about how to describe hardware with code and how to simulate it, and how you could take that same code and make a real piece of hardware out of it, an application-specific integrated circuit, or ASIC. Then we talked about implementing my wishbone wrapper around someone else's 3x3 multiply, and how we wrote the driver for it. So some things I didn't talk about. I didn't talk about any performance considerations. We didn't do benchmarking. We didn't say this technique accelerated by this much. It's a toy. It may even be slower. I didn't want to know. I think it is faster, but it might not be. We didn't talk about modular, reusable drivers. We wrote one driver for this one very specific piece of hardware in this one memory location on this system. In Linux, you're doing all this automatic configuration, probing the hardware and asking the hardware what can it do, and dynamically configuring all of that. That's very, very complicated stuff, and that's what the majority of the code is. That's what's hard to get right. That's why turning your computer off and on again fixes stuff. We didn't talk about writing Verilog or testing Verilog. You gotta test your Verilog. It's much harder to inspect and know that your Verilog is right than any software language that I've seen. Other hardware definition languages, Verilog is not the only one. There's VHDL, I think that's right. And you have high-level hardware definition languages. MyGen and MyGen, I think it's called Amaranth now, where you're using Python and pulling off-the-shelf components. You pull a processor, you pull a memory, you pull these different pieces, I think a USB controller, Ethernet controller. And you press one button after saying, put these all on the wishbone bus, and you could put it into an FPGA and you have a working system. And there's projects called Litex that will automate all of that and compile the software for it to run. And so basically you can use this off-the-shelf FPGA demo board and configure your own system on a chip with Python. It's pretty cool. We didn't talk about how hardware can have interrupts, and actually while a piece of software running, if the result comes in, you could interrupt a running process and say, hey, my hardware's done, get my answer now. And how to port an AI runtime to my accelerator. And so typically once you build an AI accelerator, your first step is to take TensorFlow Lite or some other AI platform and re-implement that little edge between hardware and software to use your accelerator. And so maybe that's what I'll do. I don't think so, though. It's not really powerful. I didn't talk about how to create good hardware. I took my first stab at playing with it, and I don't know whether I did it good or bad, but I know the software interface was very simple, so I like that. But I don't know what an actual hardware person would think of what my Verilog code is. And there's plenty of hurdles with real hardware. You have size constraints. You have to fit it in a certain cost budget, a certain power budget, and timing constraints of real hardware. The Verilog doesn't always do what the silicon does, even when you simulate it. If you want to try this for myself, try this for yourself. You can go to this blog to get the bare metal RISC-V Renode set up. And I have a bunch of make files that allow you to bring up this environment. And if you go to the chaos folder, that's where you'll run the make file to actually bring up the simulator. And you could mess with it, make it a 4x4 multiply or something, or do a different piece of hardware altogether. Thank you. And
Big
I'm ready
hand
for
for
questions.
Zach. All right, reminder, folks on the internet, ask questions in the main stage Slack channel. For those of you in the room, we still have some slots available for the Birds of a Feather sessions this evening after the keynote. Those are essentially self-organizing groups around topics. So if there's a topic that you hope to cover and discuss with your peers here at OLF, there's a whiteboard by registration. Get your topic up there. Questions for Zach? Damien.
One general question I had about coding for hardware. Going over the matrix and interfacing with the computer, how much of that skill is transferable to a more general case? So for instance, setting up a keyboard or a macro pad or some other device where no matter what it's doing, you want it to present itself as a USB HID type device. Like I guess I'm asking, like, how much of that complexity can you hide, and how hard would that be to do from what you just showed us? Like, how much more work would that take, I guess?
So you're asking how much work would it take to put the 3x3 matrix, instead of behind a wishbone, put that behind like a USB interface? So I think there would definitely be off-the-shelf USB controllers, and that would be a really cool thing to do, especially if you were using FPGA. Because if I were to take this to FPGA, it would work exactly the same way. If I FPGA'd this whole system, the RISC-V CPU, which is a tiny, tiny CPU that totally could be done on a really cheap piece of hardware, it would work exactly like this. It wouldn't do anything fun. But if, like you said, we took a piece of USB IP, put it in, and implemented like the HID part of it, we could probably make that act just like a serial, like a character read. So it would be one memory location. It would probably have some registers that say there is a character ready to read, just like the UART. And yeah, I think that'd be totally doable, and that'd be cool because then you could plug in a keyboard. A mouse would be way harder. I don't know what I would do with mouse movements. I don't even know how mouse comes through, but definitely a keyboard would be doable and is probably off the shelf. That'd be really cool. That'd be harder to simulate, right? But Reno does have facilities for actually putting together two simulations or even networks. Like over Wishbone, you could have an Ethernet and then connect two via virtual Ethernet, and they have testing harnesses to do all of that. That's one of their big selling points.
All right, we have time for one more question, and it's back there. So I get to walk. Please share your name and then your question.
My name's Sean. I was going to ask about a website, but you already gave it, so I'll ask something slightly off topic. So I could put together a single board 6502 or 6809 system, do the board up in KiCad and ship it off to PCBWay and get some boards back.
Yeah.
Can you do that with the Verilog? Is there a service that would actually send you back a chip?
There definitely are. It's going to be really expensive. But there is a guy at Google, I forget his name. I really should know it because he got me started on all of this at PyCon in 2018. But he has a project. If you Google it, just Google Tim Ansel, maybe? He has a project at Google that they make one big chip, and you get like a 5% of the area. And so they take a bunch of people. You could put whatever you want. You test it really, really good. But once you're sure of it, give it to them, and they'll put it to the fab. They'll make silicon and send it out to you. They'll package it in a little IC, and they'll send it to you. And they do it gratis. I'm pretty sure they do like once a year, every 6 months or something. So that's really cool. I've never done it, but the thing that I always imagine I'd want to make is compile a full neural network of weights for handwriting recognition. So compile that down into an ASIC where you have a bunch of pins where you are saying like the intensity of light at an area, and then it puts out in binary what handwritten digit it is. And so there'd be no microprocessor, no computing happening. It would just be a piece of hardware that could read human digits. And that should be theoretically possible, just combinatorial logic. It might be too big to do for their project, but I think it's possible in theory.
Big hand for Zach. Thanks so much. All right. As a reminder, my name's Warner Moore. I'm VP and board of OLF Conference. I'm going to be handing over to our conference chair, Vance, who's going to be closing out the program with you tonight. Without Vance's work over the past year, this event would not be happening. Huge hand for Vance. I'll be returning tomorrow and guide you through the program then. Don't forget the BOF sessions tonight. We have more for you after our closing keynote. Thanks, everyone.
Thank you very much, Warner. And yeah, we're just going to take a little break now and wrap up for our closing keynote. So we'll come back on at 5 o'clock. Good say. All right. Welcome, everyone. Please file into the back here. Come on, yeah. The more the merrier. Great to see this room so much fuller than it was this morning. Again, welcome to the 2023 OLF Conference. This is our 21st annual conference here in Columbus, Ohio, and it is really exciting to be back here at the Hilton once more. We are closing out this evening with a keynote by Joe Brockmeier, who many of you may know as Zonker. Those of you who have been around for a while probably recognize this name. He was involved with a lot of different media organizations covering the Linux and the free and open source software world. He is currently the head of community at Percona. And he's going to be, those of you who have been around a while also probably remember many examples of seeing conflicts between different business models and free and open source licensing. And as it happens, we're seeing some of that again today. So some things never seem to change. And Joe is going to talk a little bit about that, what's currently going on, and he's going to, I think, challenge us with some of his takes on how those things interact. So please give a big hand to Joe Zonker Brockmeier.
Thank you so much, Vance. Thank you. And thanks to everybody for coming out. So this is the first time I'm giving this talk, so this is a bit of a road test. So yeah, it'll be fun. All right. Okay, I don't have my cheat here. So all right, so there we go. Excellent. So first thing I want to do is to thank immensely all the organizers of OLF for putting this on. You know, without which I wouldn't be able to come here and speak to you. And if you've never organized a conference, this it is not easy. It is a lot of work, a lot of mostly thankless work, but I would like to make it at least a little more thankful. So please, everybody, give everybody here a hand for organizing the show. So it is an amazing amount of work. Thank you so much. So. Got a little bit there with the introduction. I'm going to probably retread some territory a little bit, if you'll pardon me. So, but yes, my name's Joe Brockmeier. Some friends know me as Zonker. Some people call me JZB. Some people call me other things, and probably best that I don't know what those are. But yeah, I've been involved in Linux and open source for a very long time. Started using Linux in 1996. I happened to stumble on a Slackware CD, and had no idea. Open source as a term hadn't even been coined yet. Didn't even meet another Linux user for 2 years. And then I started working for a company called Linux Small. Then I started writing and getting involved in tech publishing. Did a little bit of work with a hosting company as a sysadmin. And then I was fortunate enough to land a job working with the OpenSUSE community as the first OpenSUSE community manager. Also was fortunate enough to work with Citrix with the Apache Cloud Stack project for about 1.5 years. Became a member of the Apache Software Foundation, was recently the Vice President of Marketing and Publicity for the ASF. Did almost 9 years at Red Hat in a bunch of different roles, and currently I'm head of community at Percona. I say all that not to, you know, sound impressive. Probably the actual effect is like, man, this guy doesn't have much of an attention span, does he? Basically, I just want to establish I've been involved in a bunch of different roles in and around open source. So hopefully that establishes some bona fides to give this talk. Also, I live in Durham with my wife and family and many cats. And I asked on Mastodon today, it's like, well, I really love my cats. We have 5 cats, down from 7, sadly. And I really love to sprinkle pictures of my cats in. I was like, but is that professional? Should I be doing that? And I asked Mastodon. Mastodon said yes. So if you're in the 8% that says, no, I'm sorry, but you're going to see probably going to see some cat pictures during the talk. This is a big topic. It's something I've been thinking about a lot lately. As Vance mentioned, there's been some stuff in the news. We'll talk a little bit about that. This is a big topic, very small amount of time to cover such a very large topic. Also, it's nonlinear. I have my college degree actually is in communications, journalism, and English. And so I like things that are linear. I like to tell linear stories. My wife does not, but that's a whole nother story. But I try to walk from the beginning to the end and make it make sense. But this is, a lot of interconnected things. So I'm going to try very hard to tell a narrative from beginning to end, but we'll see if I succeed at that. Also want to start with a caveat. So for folks who have been following some of the things that have happened this year, particularly around CentOS and so on, there's been a lot more heat than light in those discussions. And I want to bring it down, and I want to have discussions, and I want to make sure that everybody understands that everything I say here is with love. There are definitely businesses that have done things that I disagree with, but I understand from their vantage point as a business, and there are people running that business. And I will definitely take issue with ideas and challenge ideas, but I don't want to come across as saying anything that's attacking a person, okay? So like if I pop up a slide with somebody's name on it, it's not necessarily me saying I wouldn't go out and have a beer with that person, because I probably would. These are like the kind of politics when people say you should be able to disagree about politics and still be friends, this is what they mean. And I agree with that. Like, I can disagree with you strongly and still go let you buy me a beer, okay? Or some good scotch. All right. I want to start off with this. Open source is not a spectator sport. This is something I've been hammering on for more than a decade. Open source isn't a spectator sport. If you are a proud user of open source, that's great. But we need contributors. We need a community that is active and involved. And so mere use doesn't really help all of the time. We need people who are active in some way. Doesn't necessarily mean code. If you notice from the introduction, none of my jobs that they mentioned involve code. We need people who do documentation. We need people who do bug reports. We need people who help put on OLF. We need people who do translations if you happen to speak more than one language. We need people who do all of those things that make these projects healthy, but it's not a spectator sport, okay? Open source has been around for a very long time. Again, like I started using Linux in 1996. A lot of things have changed since these licenses were written, since these businesses were formed, since communities were formed. There's a lot of stuff that needs to evolve. That doesn't mean that we need to concede anything, however. And one of my concerns about the open source community over the years is that we have made a lot of concessions and haven't gotten as much in return. The other thing I want to comment on is really nobody seems to agree on what open source really is anyway. So when you have a discussion about open source, like if you get on Hacker News or if you get on some forum and you see people talking about open source, they will make an assertion. Open source is this. Show me where it says that on the Open Source Initiative website, right? It's not in the license. There is no consensus. Red Hat has the open source way. The Apache Software Foundation has the Apache way. There are a lot of different ways to do open source, and we all disagree a lot on what it means to be open source. Some people will tell you it's not open source if a company doesn't publish their code for everyone to use. Show me where it says that in the license, okay? We don't have an agreement on that. I will say I don't really think it's open source if somebody just chucks it over the wall and doesn't let other people contribute. But it doesn't say that in the license. There's no requirement that a company or a vendor or an organization have any kind of governance, okay? We all have different ideas about what open source is, and we need to kind of come to more of a consensus. And that's something the OSI is doing right now around AI, okay? I'll talk more about that in a little bit. There's a really good article on opensource.com from February 2018 about the genesis of the term open source. I would recommend everybody read it. It's by Christine Peterson, a name probably very few people in the room recognize, but I would go read that because it's really illustrative about how that term came about. Pardon me while I take a drink before I lose my voice. I drove up here from Durham this morning, and I alternated between kind of talking through what I wanted to say and singing along to some punk and some Rollins bands, so my voice is already a little stressed. Okay. All right. The one thing I want to get across, too, is I do think we are at a bit of a crossroads right now with the economy and a lot of things changing. And I think if we don't act now, we stand to lose a lot of ground as a community. And remember, the title of the talk is Open Source Can't Win, right? So let's get started. You're like, wait a minute, we've been sitting here for 10 minutes. Yeah. All right. So as I said, I used to work for Red Hat. If you go into any of the Red Hat buildings, in most of the lobbies, they'll have some display with this phrase. And it's very inspiring, right? You know, if you're the underdog, if you're the David to a Goliath, it's very inspiring. First, they're going to ignore you. You keep going. Then they laugh at you. You keep going. Then they fight you. You keep going. And then you win. And everybody thinks right now is where we're at is we won. How many people think open source has won? How many people are brave enough to raise their hands knowing the title of the talk? If I had polled you before you heard the title, but no, most people will say open source has won. A couple of years ago, I would have said the same thing. There are a couple problems with this quote. The first one, if you Google it, you will find that lots of people assert that Gandhi didn't actually say this. So that's the first problem. That's the problem with a lot of great quotes is they weren't actually said by the people we think said them. Abraham Lincoln said, be wary of anything you read on the internet. I can't take credit for that one. But the other problem with this is it's very incomplete, right? This narrative that you win any kind of social movement is flawed because you get this idea that you can work, and achieve success and then quit and go home. You can't, because the forces that you were working against are still there, okay? So, you know, can we all live happily ever after? Is there some point where we can say, hey, look, open source is a success? Now, I could give a talk about all of the things that open source has achieved. Open source is on Mars, man. All y'all who are running Android phones, you got Linux in your pocket. That's a success, right? Right? Most of the internet runs on Linux. That's a success, right? Think of all of the things that open source does. How many of y'all use Chrome? That's built on open source, right? It also basically serves as a massive funnel for your personal data into Google. Is that success? Is that what we thought winning would be 20 years ago? I don't think so, okay? How many people have a Kindle? That runs on Linux. Is that an open ecosystem? Is that making the world better? There are a lot of things that run on open source, but are in fact not really making the world better necessarily. Again, not attacking any of these companies. Google is doing the rational thing that companies do, okay? So, is it really a success? You kind of have to ask yourself really critically if we have achieved what we want to achieve. Now, maybe we have. There are some folks, so for example, again, I'm a member of the Apache Software Foundation, and there are people who think it's perfectly fine to take, you know, they believe in permissive licensing, and they think it's perfectly fine. Some of the members think it's perfectly fine for people to take from open source and not give back. They consider it a gift culture, and they want people to use it in business, and they don't care if they get anything back. And if that's what open source means to you, then you can say we have won, and you can go home. However, if you think that the idea behind open source was to make the world a better place and open computing and open hardware and things like that, you kind of have to ask yourself some hard questions, okay? How many people are familiar with Gil Scott-Heron in this song or poem, Revolution Will Not Be Televised? A couple older folks in the room. The Revolution, it's highly recommend homework for the audience. Go look on YouTube, go find the song, The Revolution Will Not Be Televised, it's excellent. But the idea basically being like, you know, hey, this counterculture movement, it's going to reject all of these things, right? Like we're going to reject the nightly news, and you're not going to sit in your chair and just watch the revolution. This was back in the 70s, right? The revolution will not be televised, but the movement will be monetized, okay? As I said, I was driving up here, I was listening to a couple of things. One of the things that was on this playlist was off of Nirvana's first album, Bleach. And I looked at the metadata for it on my car stereo, and it says Nirvana, Bleach, parentheses, deluxe edition. I'm like, there is nothing less punk than deluxe edition next to Nirvana's first album, right? It's like, look at the history of like everything. And what we see, and this has happened to open source too, is that the mainstream is really good at taking counterculture movements and adapting to them and monetizing them and saying, that was real nice, what you wanted to do, good job. $9.99 right over here in the clearance aisle, okay? So, want to hit two things real quick. Now, some of the folks who are heavy-duty open source old-timers may think that really, is this guy really kind of talking about free software? Is that where he is going with some of that? And the answer to that is maybe. I've given this a lot of thought. So over the years, I've kind of drifted from the Free Software Foundation because they tend to be very strident and put people off. And they tend to be like absolutist about things. I have a family who both have no interest in computers. They don't care. Software is not an ethical thing to them, and they are people I want to convince. So I have to think, like, how can I convince people who are not hardcore computer open source people? So am I talking about free software? I don't think so, not yet, but I'm considering it. The other thing is, happily ever after is a lie. If I haven't drove that home just yet, I just want to, you know, kind of draw a line under it. Happily ever after doesn't happen. Even if you take the position open source won at some point, the forces we were working against have basically figured out how to adapt and start encroaching on user freedom all over again and figuring out how to monetize these things in such a way where you don't really have full control of your data. You don't really have full control of your computing. Or if you do today, they're going to find a way to take it away from you. That was a little heavy, so we're going to take a cat break. This is Sir Wobbles. He is one of our 5 cats at home. He has at least one operating brain cell at all times. There is a saying on the internet, there are 3 kinds of cats: cats that know that they're cats, cats that think they're people, and cats that don't know anything at all. He's probably in that last category. So, okay, now we're back at it. Open source threats. So I'm going to enumerate a few things that I see as threats to open source and to our user freedom. The first one is technology shifts, and this works in a couple of ways. As I mentioned, open source licenses, most of them were written decades ago. They were written with a model of big bang software releases. You get a release 7.51. It is done. It is final. You get the code that goes with it. End of transaction. They don't take into account SaaS. They don't take into account subscription software. They don't take into account all of the different things that people do with open source. The other thing is that open source has done great for infrastructure and for business. Not so great at end-user computing, which is one of the things that I actually care a lot about. I make my living on infrastructure software, but guess what I use on the weekends, right? We haven't done so great. How many people have a fully open source tablet or watch? I know there's going to be 1 or 2 people in here. There will be one person who is perfectly happy to recompile a kernel every 2 weeks to put onto their tablet and root the tablet and do the thing. But generally speaking, like, if you want to participate in modern day computing, you're probably using a lot of proprietary software. You're probably using a lot of stuff that you don't have full control over. By the way, at this point, I want to give a big shout out to the Asahi folks and the Fedora project and the work they're doing making Linux run on Apple Silicon. That is fantastic. Not to exclude anybody else who may be participating in that, but I'm really looking forward to the release. I think F39 is supposed to support Macs. And I have a work machine that is highly targeted for that. So there are a lot of things that have changed, but open source hasn't really kept up. AI is creeping up on us. And we're, the open source initiative, to their credit, is having a lot of conversations. If you haven't paid attention, go to the Open Source Initiative website. They're doing webinars, they're doing blogging about it, they're trying to solicit public feedback and try to figure out how to deal with these shifts in technology. Another thing that scares the bejesus out of me is legislation. How many people are familiar with the EU's Cyber Resilience Act? That thing is scary because it basically wants to make people liable for open source work. Not businesses that are shipping open source, communities that are producing open source if they're affiliated with business in some way. That's terrifying. That's chilling if you do any work, and most communities do, in the European Union. It's winding its way through. I used to think, as a person in the United States, I used to think the US legislative process was a little complicated, and then I took a look at that. I actually struggle to figure out where exactly it is, like how far it has to go before it's officially. But if it becomes official, like we're kind of in trouble because it's going to have a very major chilling effect. And again, with the adaption, here's the thing. A few years ago, legislation like that would have raised the hackles of all of the companies that do open source work. But I think the major companies that have established themselves that open source is important to have basically looked at that and said, it's just more paperwork, we can deal with it. For companies like Percona, it's going to be a nightmare. And it will have the effect of shutting some people out of that market. Another big problem is treating projects like suppliers, and the corollary, treating suppliers like their projects. I saw a lot of this. So when I was doing marketing and publicity at the ASF, I was fortunate enough that my tenure overlapped with Log4Shell. Yay! That was a fun December. So basically, I'm assuming everybody remembers Log4Shell. It wasn't that long ago, right? Okay. Worst security hole, vulnerability nightmare in the world, lots of midnight oil burned as people tried to figure out, do we have Log4Shell in our environment? And part of the big problem there is that all these organizations are still treating open source like it's a supplier, like they're just going to check off a bunch of boxes like they would with any vendor, and the vendor will let them know if there's a security vulnerability, right? No, this is open source. You need to participate and be involved. If you're not paying a vendor for this information, you need to be in the front lines participating, and they're not. So to go back to the legislation, they're trying to make open source projects act like suppliers. The converse is also true in that a lot of people want to treat vendors like they're an open source project. And they have the same expectations that they're going to get the stuff for free from the vendor, which maybe you will for a while, but that's not how vendors work. And so over time, eventually vendors say, we need to make more money. And then all of a sudden you're like, wait, that's not open sourcey of you. Hey, guess what? We're a vendor. If you want a project, go use a project. So vendor-controlled open source, I consider a major problem. If you look at what happened recently with HashiCorp, okay? With HashiCorp basically saying, you know what? This isn't open source anymore. These projects, they're business source license now, overnight. A lot of people contributed to those projects thinking they were going to remain open source. They had that expectation. I don't know, pardon me while I take a drink here. I'm not sure why people are so comfortable with that after so many examples over time of that going badly. For those of you who worked in the early days of Linux containers, when Docker was basically controlling the supply chain for container stuff, that didn't go well. You saw problems way back in the day when Oracle acquired Sun and they had to fork Jenkins off of Hudson because Oracle came in and said, we're a vendor, we're taking this over, we're taking the name, good luck, okay? And I'm not I'm not really trying to throw stones at the vendors because they're doing what vendors do, okay? Vendors are trying to make money. That's their purpose for existence. And if, as a side effect, they can produce open source and it doesn't hurt their bottom line, they're going to keep doing that. But if you let somebody, a vendor, control the pipeline for a major piece of plumbing in open source, you're going to have a bad time eventually. So license changes, to me, are a major threat to open source. Now, you might be thinking they're just a threat to the companies that do it because there's already a fork of OpenTF, right? There's already a fork. Hudson was successfully forked. The industry figured out how to work around Docker when they needed to. We've figured out how to work around a lot of things, but here's the problem. The open source community, here's one of the things where we say we've won. We've spent years convincing corporate lawyers that open source licenses are okay to let in the corporate firewall. This endangers that philosophy. Because if you say, hey, it's okay to depend on this, and somebody can just turn the dial and turn it off, lawyers are going to start to say, do we really trust that? Do we really, like, okay, it's Apache license today, will it be tomorrow? So that's a major threat to all of the goodwill that the larger community has built up. Everybody repeat after me, open source is not a business model, okay? I had a conversation at All Things Open a couple years ago with somebody. Normally I would anonymize them to protect the innocent, or maybe not so innocent. This time I've just legitimately forgot who it was, but they were with a vendor who worked on open core. And they were talking about that philosophy, and they were enumerating all the reasons why they were open core. And they were all basically, they boiled down to, we need to make money. We need to control this for our business. And I said, I totally get it, that logic works. Why should anyone adopt that though? Like, this is what I'm struggling with. I understand your problem, but it's not my problem. It's like, why should the community adopt that software knowing that that's what's going on behind the scenes? It's like, those are a you problem. This is supposed to be a community, right? Folks who follow Mattisay know that generally speaking, he's been on the open core train for a very long time, which is fine. And he wrote this recently: the open source licensing war is over. No, it's not. He wants it to be. He wants everybody to believe it is, but it isn't. Don't hold the subhead against Matt. I'm almost certain he didn't write that. That was probably like an editor at the publication. But basically, his argument is that developers do not care about open source licensing. He's not entirely wrong. Like, I've talked to a lot of developers, and there are many who do not really care. But there are two problems with that argument. One is the debate is still ongoing. He wouldn't be saying this if it wasn't, because he wouldn't have to make the argument. And the other thing is developers aren't the only party here, okay? There are the corporate lawyers who have to be satisfied with the licensing. There are people in, developers have an average tenure of what, about 3 years in an organization? But how long does their code live on in that organization, right? So you have to satisfy a lot of other people, but if they can convince people long enough to let the developers adopt non-open source licenses, they win. Another problem that we have, two problems, are apathy and ignorance. Now, I don't know and I don't care which one is worse. It was right there, I had to take it. All right. But we do have a problem with, number one, as I said, I worked at Red Hat for about 9 years, and I could see as the institution itself sort of got tired of talking about open source for a while, kind of got tired of the open source education thing. Those of us who have been around for a long time kind of were like, everybody gets it now, right? We can stop doing this, right? We can stop with the 101 stuff, right? Turns out, no, because there are new people entering the community every day. To completely just abuse a William Gibson quote, open source is mainstream, but understanding of it is not widely distributed, okay? I learned this at a couple of different organizations where I would have conversations about stuff that I thought was just ground level stuff, And I found out it's not. It's not ground level stuff. It was, you know, it'd be like plumbing or something, like, you know, you don't do this, you know, you turn the water off, Brockmeier, before you start working on your plumbing. It's ground level for plumbers, not for me. Not that that's happened recently or anything. But basically, we can't stop educating people, and we can't be apathetic about it. We can't be neutral about these things. Also, people who hyphenate or open source, one of the worst no. This is just a pet peeve. Seeing if I can slide it in there, get some consensus. That is one of my biggest editorial pet peeves. I was like, take that damn hyphen. All right, another cat break. This is Sam. He is kind of the oldest of my wife's cats. We have a Brady Bunch cat situation. He came to us with my wife, and he is a cat that knows he's a cat, and he believes he is superior to people because of that. He's probably not wrong. All right. Now, I've said a lot of stuff that hasn't exactly been upbeat and positive. I apologize for that. It's a Friday night. You all came in here to be happy, right? So you came to the wrong talk, but I'm gonna work on it. All right, let's see if we can turn this ship around. So don't panic. While I will say open source hasn't won, can't win, won't win, doesn't mean we've lost, okay? We can do better. We can rebuild them. We have the technology. Not that many old people in the room. Okay. All right. Number one, advocate. Everybody in this room can do this. You don't have to be a developer. You don't have to be particularly talented. Go home and start advocating to people. We've given up on that. Like I think as a community, we've stopped pressing. Like, couldn't we do that with open source instead? Couldn't we use an open source tool instead? Couldn't you use an open source program to do that? One of the toe holds that I have, my wife likes to sew. She made me this shirt. She does her patterns in Inkscape. She's a Mac person, but she does her patterns in Inkscape in an open source. That's a toe hold for me to persuade her to use more open source, because she loves the fact that there's no subscription, it's free, it's high quality, it works well. So advocate. Educate. Tried to get by the way, this is all these images came out of Midjourney. So this is an attempt at a Lorax. You know, I'm the Lorax, I speak for the trees. Go educate people, talk about open source. Take some people under your wing. If you are in the industry for 10, 15 years, find somebody who's new, advocate and educate. See if you can sprout 2 or 3 new users to replace you, okay? Debate. So I mentioned at the beginning, we had this big debate when Red Hat turned off the CentOS spigot, right? Again, I will say there was a lot more heat than light in that discussion, but it's an important discussion, and we need to listen to each other. Because really, there are a lot of different opinions, and not everybody has a wrong one, and we need to triangulate on what the right thing is. My argument would be that the open source community has let itself down by allowing one vendor to control enterprise Linux. Other people might argue, well, you know, Red Hat owed it to us. Not how companies work, okay? But we need to have this debate, and we need to talk about it, and we need to stay friendly while we do it, because the people who were arguing and yelling at each other all passionately care about open source. I really believe that. They all passionately care about Linux. So we cannot afford to alienate one another. We need to be able to debate and then go have a beer together, where you buy me a good scotch and, you know, we talk it out. And finally, as I said at the beginning, you need to participate. This is not a spectator sport. Open source doesn't win by people just being passive users. If there's a project that you care about, you need to be involved in it. Even if that involvement just means kicking in some money in PayPal. How many people use one of the projects that has a PayPal button but have never actually sent them 10 or 15 bucks? I phrased that weirdly, so I'm not sure why people are raising their hands. Like if you use VLC, have you ever kicked the developers a couple of bucks? If you use Calibre, have you ever kicked those developers a couple of bucks? Because they probably need it, and it would be helpful. If that's all you can do, that's great. If you can be involved in a project, that's better. And one more cat picture. This is Sir Wobbles again with his buddy, Bubby. He is our 18-year-old diabetic cat. He is a senior lord of the household and one of my favorite cats. And that's the talk. I want to thank everybody for listening to me, and I want to thank everybody for caring. You showed up on a Friday night at 5 o'clock. You must care at least a little bit, so I thank you for that. And thanks for listening to me. Thank you. By the way, the lights are very bright, and I can't really see anybody. Do we do Q&A?
Yeah. What I'll do is, folks here, if you have questions, raise your hand, and I'll run and bring the mic to you.
Okay.
And if folks online have questions, please post them in the main stage channel on the Slack. So, in the back here.
So question for you. You mentioned the example of like Apple Silicon affecting open source. From what I can tell, and based on a lot of discussions I've had today, that type of technology change seems to affect way more than just open source. And I'm seeing a lot more, there's a lot of proprietary software out there too, also seeing issues with that. Out of curiosity, do you see things like Apple doing more of these technology advances forcing everyone to change? Or do you think that there might be opportunities for non-open source proprietary software to also push back on that level of technology and the necessary of that change?
That's an interesting question. I haven't really given a lot of thought. Yeah, I haven't really given that one a ton of thought. So how proprietary vendors, I mean, my observation over the years is that proprietary vendors on the Apple ecosystem tend to get drug along for whatever changes they make or they go extinct. It would take a lot of locking arms for people to, was your question like, can they influence Apple or?
Just how would proprietary software, if at all, how would proprietary software, if at all, affect that in comparison to the open source world, I guess?
Not as much, I don't think, because I think they just they are used to that. They go along with it. So, but I am not an expert on proprietary software, so I'm not sure.
All right, next
Other question? Yeah.
So you mentioned earlier that I like saying, encouraging people to mentor, to have 2 or 3 people to replace them. I and a lot of other people I know have been trying to, because that's what they always tell us, like contribute to an open source project and that'll help get you a job, and also is just the cool thing to do. But it is a lot harder than people make it out to be. Especially because certain populations are like actively discouraged from it. What are, I guess, in your years, some things you've seen that were successful in kind of breaking the mold and the gatekeeping to let people who, hadn't been coding since they were 5, like, break into actually contributing to open source software?
And by populations, of course, you mean people who hyphenate open source, right? No. So there are a couple things I have seen be successful. And now here is where, I kind of slapped companies around a little bit, right? Here is where corporations like Google and Red Hat and IBM have actually been helpful. If you look at communities like Kubernetes that were intentionally created, they actually I'm not saying they're perfect, but they stressed things like mentorship and accepting people from every walk of life, whereas organic communities may not have prioritized that. Like Google and others said, we think this is important, not least of which because we have employees we want to participate in these projects who are women or of some other group that is often not treated as well in these. So companies influencing the projects that they sponsor can be very effective because they're also the only ones with the resources to do it typically. If you go to the ASF and you say you need to do a DEI initiative and this PMC needs to do this, it's like, well, with what resources? I'm a volunteer and I don't have time to mentor somebody. I don't have time to do this. So that's one thing I've seen be successful. I'm trying to think of other examples, but that has been the best one, is basically companies putting their money where their mouth is and telling those communities that's the way they need to be created. Things like through the Linux Foundation saying, you know, you need to emphasize these things. That's one way where the corporate stuff does work. I'll try to think of other examples, but that's one. I can tell it probably isn't the most satisfying example for you, but I'll think about it. Did that answer your question, though?
It actually was one I hadn't heard before.
Okay.
So that's actually a pretty good one.
Oh, all right. Score one for me. Woo! I'm on a streak of one.
I'll make my way up to the front here in a second, but we have an online question. It says, what do you say to people less technically savvy who want software that just works in order to educate them on open source?
For people who want software that just works, there is a lot of software that just works in open source, depending on your definition of just works. I would point people first and foremost, I think the most important piece of software for people to adopt today, this is me editorializing, like I haven't been for the last 35 minutes, would be Firefox. Firefox just works. It works great. So I would say that would be where I would point people. And I would point people to things like Calibre, which if you have to manage your ebooks is a program, at least I think, is user-friendly. By the way, my definition of user-friendly is probably heavily skewed. So I still, by the way, you know, moment of silence for Bram Molinar, who created Vim. I still do most of my writing in Vim, and so my idea of user-friendly is probably not a really good one. Okay.
Yeah. Thank you.
I've been logged in since 1999. I don't know what to do. No.
It's fine. I still use Nano. But what was I? Okay. So what do you think about software? I mean, software/hardware right now. Like, there's some really great upcoming things I've noticed, such as RISC-V and the PinePhone, that company, and then also framework laptops. I mean, they're all smaller independent projects, but I don't know. I see some hope in those. I just was wondering what you think of projects like those being sustainable.
Well, so first of all, thank you for that question, because one of the things that I didn't say that I wanted to say, and you reminded me, was I am really inspired by Framework, by System 76, and by the Steam Deck. Software or hardware that is making Linux more usable to a wider audience that just wants something that just works. I have no business buying a Steam Deck, but I did it anyway. And it just works. It works great. It's not as high powered, so I have a Pop! OS on a MSI laptop that has a really nice NVIDIA card and 32 gigs of RAM and everything. And obviously, so I installed Baldur's Gate recently, and it looks better on the laptop than it does the Steam Deck, but the Steam Deck is perfectly usable. So your question, though, was about how sustainable that is, whether that's business is going to succeed, I think, really. As far as I can tell, the Steam Deck is doing great for that company. Framework is well into their third generation of laptops. They seem to be doing okay. I am heartened by the fact that System 76 has been around for well more than a decade, maybe two. So there are Linux hardware manufacturers who have found their niche. And I think, honestly, I honestly think that, like, so there's the Remarkable tablet, which unfortunately it runs Linux, but the software isn't particularly open or easy. They're not trying to develop community. I think that's a big mistake. I think that Let me give a shout out to George Castro, who usually comes, I think, to OLF, but couldn't this year, on his Bazite project, which is a Fedora spin for gaming that runs on the Steam Deck. So you can replace the Steam OS if you want to with Bazite. I think there's a huge appetite for, and I think they can be successful. The thing to watch out for is what happened to VA Linux, which is pioneering a market and getting to a certain point and then having the big guys go, thank you for doing our user research, yoink. That's the only fear. But with Steam, I think they're in pretty good shape, so.
My name is Gage. So I know that probably about 98, 99% of us are not lawyers. But to touch on the relicensing issue, something that flew under the radar for even me until just a couple weeks ago was the fact that Elasticsearch, while Red Hat was doing their thing, just kind of quietly did the same. I'm just curious, like, has anyone come up with like a concrete solution to stop future incidents from happening, or is this just gonna be a, oh hey, Kubernetes is now completely closed source, we don't have it anymore, you know?
Oh, well, so I thought Elasticsearch went to the SSPL years ago. Yes, there is a solution, and that is do not adopt vendor-led technologies that are plumbing. I don't want to. Again, everybody got to eat. Everybody got to pay their bills. I'm not harshing on vendors here. But understand that when you take a chance on something as an open source project that is vendor-led, you are taking a risk. If you adopt something like Kubernetes, which is led by a foundation, that's your insurance. And so one of the things when I guess I missed saying this when I was talking about advocacy, is when you're using your influence at your workplace, advocate for moving things to foundations where they will have neutral governance, where they will be, and that's better for everybody really. Even the vendor, whether they like it or not. Now that may expose that their business model isn't great, but you know, open source plumbing belongs at a foundation or a neutral party, in my opinion. Does that answer your question? That's the insurance. I'm sorry? That's how I know you weren't good at Apache. Well, now Apache isn't right for everybody because they have a very narrow set of licenses they accept. One. Yes, and it works for those projects. It doesn't work for some things though, right? But yes, I do believe in the foundation model very strongly, especially, I will note, I've brought this up on Mastodon. When people say foundation, a lot of people just think if it's a foundation, it is a nonprofit, it's charitable, yada, yada, yada. There are different kinds of foundations. There's 501c3, which is charitable and has to be for the public good and cannot do certain things. There are 501c6s, which are like the Linux Foundation, which are, it amused me, somebody on Hacker News was talking about like, how dare IBM infiltrate the Linux Foundation? My brother and Richard Stallman, they helped found it. They didn't infiltrate it. They actually helped found the OSDL, which became the Linux Foundation. So you might not like what they do, but they've been there all along. Sorry, went off on a little bit of a tangent there. But like, you know, there are different kinds of foundations. All I was trying to say there. All right.
Hi, you had mentioned the OSI over like FSF. Do you think that the introduction of a new GPL variant would help address some of the issues we're seeing?
I think that would depend on which issues we're talking about. I don't know that there's a lot of appetite for a new version of the GPL, but I guess it depends on the issues. Like the vendors, this is something I missed saying in the talk. The vendors that have chosen SSPL missed a perfectly good open source license, which is the AGPL. I wanted to give a shout out to Grafana. which said they looked at the licenses, they looked at SSPL, they looked at AGPL, and they said, we believe in open source. We're going to AGPL it. And they're still around. They're still doing business. As far as I know, I have friends that work there. They seem to be doing good. So it isn't, you don't have to choose the SSPL to deal with the threat of cloud providers if what you want from it is contributions and not just taking the source. So, but it depends on what the loophole you're wanting to close is.
I was thinking about recent changes in package pipelines for high-profile operating systems.
Those aren't new. The turning the spigot off is new. The subscription thing is at least a decade old. It was there before I joined Red Hat. So, or the the vendor, the open source vendor. Are we going to have to go back to like the North American vendor? Sorry. I remember those days. Love trademark. The fun thing about software is the only form of IP that is, or the only thing that's protected by like 4 different types: trademark, patent, software, or copyright, and it's ridiculous. All right.
So this has been touched on a little bit tangentially, but I wanted to get your thoughts on the whole copyleft license, like the GPL, versus non-copyleft, like Apache licenses.
You mean like which one do I like better?
How would you compare them for different things? Which one would you like better? Which one works better for open source?
If anybody from the ASF is watching, you might want to mute. I prefer copyleft personally. I like the reciprocal nature of saying you have to give people the same rights that you got. I prefer that, but there are people who they want to do open source and they just want to see it adopted, and permissive licenses like the Apache license are much better for that. So it really depends on what the creator of the software wants, and of course it depends on the ecosystem. When I was at Red Hat, I worked with a team. Red Hat used to let, and I think they still do, but they used to let basically the developers pick their license. Like legal doesn't come down and say, you must use these licenses. There are licenses they will tell you don't use, but they don't tell you you must pick this license or that license. Red Hat was, at least when I was there, very free with that. But somebody tried to pick the AGPL for things in the Kubernetes space, and it's like, that's not going to work because nobody is going to touch that in that space where they expect the Apache license. So you kind of have to, when in Rome, wear a toga, right? So, yeah. It's like a Zoom meeting. I can hear you, but the people at home can't. So, hi, people at home. Hope you're having a good night. Yep. I could. I'm bad at that. I'm so bad at that. All right.
Sam,
The light's red. I think it's supposed to be green.
Not red or red. Yeah.
There we go.
There we go. On the idea of that you mentioned, right? We let one vendor decide what enterprise Linux is. That's obviously a problem, right? So the obvious response for me, right, is why not Debian, which I think checks off most of the things you would say.
Mm-hmm.
But as someone who works like for a Fortune 500 company in Linux, I know that companies have compliance things, right? Where they say, you must have vendor support for your software. So let's say I wanted to advocate, hey, anywhere say that we don't need WebSphere or an Oracle database, let's use Debian.
Yep.
Right? The lawyers are going to say, you can't, because we don't have any vendor support. Or even if it doesn't reach legal, it'll reach somewhere, so you can't do that. So how would you advocate for using, like, how do you fight against those kind of corporate policies? Because that's where all the money in open source is coming from, right? Like you mentioned, people not donating with PayPal, right? Maybe I'll give 10, 20 bucks here and there when I have it, but still, I mean, is that a winnable fight?
So many thoughts on that. So why not Debian, right? I used to run into a guy named B. Dale Garby at a lot of conferences. He worked for HP, and he was a big Debian proponent. And I think there was a time period when major enterprise vendors could have standardized on Debian and should have possibly standardized on Debian and locked arms and said, this is the community in which we will all participate. They didn't. It's not too late. In fact, this is a good time to have that debate about maybe we should all think about participating in a community like Debian that is neutral, that has open governance, and we should standardize on that and maybe use the Linux Foundation to, revisit the idea of the Linux standard base or things like that. That's what I would advocate for, is the long game. Short game, you're not going to convince them. Shorter game, you should probably just pay for RHEL, honestly, because that's render unto Caesar what is his, okay? In that environment, in the corporate environment where you need those certifications and things, and those are the things that Red Hat provides, pay for them, because it costs a lot of money to do all that. That's one of the things, is like people don't seem to value all of that. They do, but they want to claim it's just about the source. We just want the binaries. No, you want all of the trappings that go with it that's called Red Hat 851 that make the corporate lawyers comfortable, that make the certification people comfortable and the security people comfortable. So pay for it. Or play the long game. Let's all go participate in Debian. I love Debian. I really do. I think it's great. I think it's wonderful that it exists. They celebrated their 20th anniversary recently. 30th, thank you. I even wrote about that and I forgot what it was. I have celebrated a number of birthdays myself. That's why I'm forgetting these things. But no, like I think it is. I hope Debian is around forever. I also hope, tangentially, I hope Slackware is around forever, just because. More power to Patrick. Okay. Did that answer your question, though? I think. But basically, like, understand that if that's the advocacy, that is the long game, and I think it's worth it. But it's a lot of work, and Red Hat has done that work. So,
okay,
any other
I think
questions?
We only have time for 2 more, so.
Okay. I think this fellow in the front row has been waiting a long time. Okay.
Okay, let me get this and then get back up to the front. And
Okay.
Sorry for the folks, but you'll have some time after to maybe mingle with.
I like
Joe there.
Auchentoshan a lot. 20, 25-year-old McAllen. Just no. Hey, you miss every shot you don't take. All right.
I am Maxine Hayes. I'm wondering what your thoughts are on OpenELA.
Tell me what it is.
OpenELA is an association geared around making enterprise Linux open source. It's supposed to be kind of like a neutral organization founded by CIQ, Oracle, and SUSE.
Okay. All right. I was aware of it, but I didn't actually remember the name this time. I keep thinking United Linux. I don't have any thoughts yet because there's been a lot of announcements, but not anything concrete. Like SUSE announced a $10 million investment over years, and I'm waiting to see what that means. I've worked for an enterprise vendor. I know what $10 million looks like in engineering form. It's not really that much. And they haven't specified whether that money is going to a foundation or to their own engineers supporting RHEL. I'm not sure. It has potential. I've also seen, I'm old, and I've seen those kind of things flame out or just fizzle. Now, the last time, to be fair to everybody else involved, that one fizzled because Caldera went evil. So let's hope that doesn't happen again this time. United Linux, for those folks, fun reading. Go look up Caldera and SCO if you're not of a certain age. How they have not made a movie out of that yet? I mean, really? The guy named Darrell McBride, how is this not like somebody? This should be a Netflix movie by now. Netflix, call me. I can write a script. But anyway, so I don't have strong thoughts. I'm waiting to see what happens. I think it's full of possibility.
All right, then last one up front here.
Oh, okay.
Yeah, I was about to say. Hi there, I'm Josh, by the way.
Hey, Josh.
Yeah. So
hi, Maxine. Sorry, I didn't acknowledge you. Thank you. Thank you for the question.
So you mentioned that you had some issues with the Free Software Foundation. First of all, are you aware that they were taking surveys over at their booth on the other room there? And
Okay.
would you be willing to vocally elaborate to some of the issues that you have with the movement?
So, sure. I wasn't aware of the survey. I'll go take the survey. The Free Software Foundation, I've written about this. If you Google, I don't know if you can find it anymore because the publication I wrote before went under and you have to dig for it. But I wrote an article probably 15 years ago called The Party of GNU. And basically, the Free Software Foundation and GNU Project's approach to new technology, when some people say, we want to use cloud computing, no. Richard says no, don't do that. We want tablets, no. They're not free software, don't use them. We want this. Well, the answer is don't use that kind of computing. If free software doesn't exist for it, don't do it. That's not an answer that is going to win most of the population. The thing that really broke me was reading an email exchange where Richard told someone who was visually impaired it was better for them not to make a living as a programmer than to use proprietary screen reader. That was when I said, I'm done with this idea that software is an ethical thing and that it is more ethical for someone not to make a living as a coder than to use a proprietary tool. Now, if he had said, dude, use the proprietary thing and write some, do some penance and write some open source software, some free software, sorry. Write some free software, and when there is a free alternative, even if it's a little clunkier, use that. I'd be fine with that. Like, think long game. How do we convert people? But if you tell somebody who is visually impaired, just don't do it because the thing is proprietary, I can't rock with that. So that would be it. Wow, that was a downer. Okay. Can we have one good uplifting question? No.
Thank you very much, Joe.
So thank you.
Really appreciate you coming out. So as I mentioned, we're going to be having a happy hour out here starting right when we leave this room. Out in the expo area, we're going to have a bar, and we're also going to have some pizza being served. I think it's next door in Ferris West B. I can't remember the exact details, but you'll find it. There'll be people walking around with food. How happy is it? Oh, it'll be as happy as you want it to be. Then starting at 7 o'clock, our Birds of a Feather sessions will start. They're all listed up on the whiteboard, and you have... Oh, yes. Yes, absolutely. After that, we'll have the Birds of a Feather at 7 o'clock. And I wanted to invite a representative of the Rocky Enterprise Software Foundation. Did I get that right?
Almost. Here, I got
All right.
it. Hey, real quick before you leave. Hi, I'm Krista. I'm with the Rocky Enterprise Software Foundation. This is the organization that runs the Rocky Linux project, and I'm more of a writer than a speaker, so I'm going to read a prepared speech, which will be 2 minutes long, maybe 3. Tomorrow at 11, I'd just like to let you know that I'll be talking more about Rocky Linux itself. I've had a lot of people stop by and want to know more. That'll be on the open source solutions stage, which is, I think, 2 rooms over. Maybe I'll see you there. But the RESF itself is committed to ensuring the longevity, stewardship, and innovation of enterprise-grade open source software. We talked a little bit about Enterprise Linux this hour. You may have heard of it. Enterprise Linux is part of the open source world that is going through a bit of a shift lately, and it's a bit of a sensitive subject. And I personally am of the school of thought of why can't we all just get along? So what I will say is that we do sincerely desire to be a contributing and valuable part of the Enterprise Linux community, and that involves supporting individuals and communities in their search for accessible software. I'm not here today to discuss what the nuances are of what accessible means, because then we get into what counts as cost and what counts as free. And that is a conversation that can be divisive. And that's not really what we need right now in the enterprise Linux world. What I can do is offer you something else that really is free with no controversy required. Tonight we are sponsoring the pizza and beer and other beverages next door, and after that we'll have some t-shirts, which are also free at our booth in the exhibit hall while supplies last. So thank you for listening. You all have a great night.
Yes, and thank you very much to the foundation for your sponsorship. We'll look forward to seeing you all at 9 o'clock tomorrow morning.